हरि करना।
Welcome to the fifth module of Intuitive DevOps for You course. The fifth module of iDevOps for You course is CI/CD pipeline. Here we are going to look into all the tools which are related to building a pipeline. Example, a Git and GitHub, then Maven and Jenkins. So as an automation tool, I would like to discuss about Jenkins because this is the most widely used tool. So now we are in first part of fifth module, that is Git and GitHub. Don't think Git and GitHub are same. So they are different. They are two different tools. So now, irrespective of whether you are a developer or an operations guy, it doesn't matter. And Git is compulsory. The Git is compulsory even for the mechanical engineers or designers, automotive designers, and aerodynamic designers. So maximum everybody is using version control system these days. It has become compulsory. It's become a norm these days. So that's why, irrespective of what background you are, kindly watch this Git and GitHub part of fifth module. It's going to be crazy. It's going to be interesting. It's going to be fantastic and fantabulous. Just stay with me for more fun. So here we are going to discuss about what is version control system and different types of version control system that are available. Then Git architecture, Git commands. Then we look into the GitHub. Uh, then we will see the exact difference between the Git and GitHub, and we will wrap up this Git and GitHub with a real world case scenario. Means of 5 developers is working on a one project, so how they use Git and GitHub to work on that project. So using this real world case example, we are going to wrap up this Git and GitHub. So now let's begin our first part of fifth module with an assignment. Okay, so here what I'm gonna do is I'll ask few questions and you have to answer me, and kindly follow this assignment. You just don't watch the video, you just do it with me. You just do it along with me. Okay, so let's begin. So the first activity that you have to do is state one, open a text file. So I will get into my hands-on directory, and there I will create a just text file, a text document. Okay, the name I'm going to give is why do we need version control system. That's the name of the file I've given. So now I'm opening it. So the file has been created. So the next activity that you are going to do, kindly follow with me, kindly do along with me. Whatever I'm doing, those steps you do along with me. So then add the following sentence. This is my first line. Okay, so let me add that. This is my first line in this file. Done. Then save the file. I'll save it. Yes, the file has been saved. This is the state 1. So state 1 of the file is this. It consists of only one line with the file metadata as why do we need version control system. This is all about the file 1, that file state 1. So now let's do a little bigger. Let's do a more complicated work in this case. So in state 2, let's again open the text file and then add a paragraph about how did Krishna build Dwarka. Let's get into the work now. So I have opened the file. Now here I have to add a paragraph about the Krishna. So I'll go to the Google and I'll search it. So here I can see history. So district Devabhumi Dwarka. So I'll copy this. Dwarka was established as the capital in Saurashtra by Aryans. Oh, this Aryans is nonsense. I don't believe all this nonsense. Indians are Indians, just Indians. We are all one. Okay, so I'll just copy this and then I'll paste it here. So, and then I have to save the file. So I saved it. So all fine. Now you may think, what is this nonsense? You are just adding the lines and copying the things and saving the file. Is this the assignment? No. In French, there is a crocodile festival. Okay, I will give you the assignment now. So now all done. So now you have to answer my questions. So my question is, what is the initial state of the text file? Of course, you can see on the screen. What is the, without this slide, what is the initial state of the text file? That's the state 1. And what is added to the text file? Of course, you can easily tell it. Why? Because in first case, in state 1, you have added only one line. That is, this is my first line in this file. And then in second, you have added a complete paragraph. So it's not that difficult to say answer these questions, of course. Okay, so I hope you would also answer this question with ease, because there are not much changes we have done it. So initial state was just with a single line and then paragraph was added. That's it. Brilliant, fantabulous. Now let's move to the state 3. Again, we will open the text file, and in this case we will delete some words and replace words and add few words. Okay, I will do that quickly. So this is our file. The city Dwarkesh. Yeah. Yes. So now in this I say, in spite of Dwarka was established. Okay, I say so I won't say the words that I'm typing here. So you just follow the video. That's it. Delete this. I'll delete this and I'm adding. Even I do not know what I'm adding and what I'm deleting. You just follow that. So I do not know. I'm just removing and I'm just adding the lines. I'm adding the new words. Randomly, I'm deleting words. Even I do not know. Even I do not know what I'm deleting exactly. I'll say Rama here. So So I think enough of additions and removal and replacement. So now let me save this one. Yes, that's the third step. So I've saved it. All done. Now you take your own time. If you want, you just rewind the video with the speed that you comfortable with, but you have to answer my question. Answer the question that I'm going to ask. So the first question that I'm posing is, what is the second state of the file? And the second question is, how many words have been added and how many words have been deleted, and tell me each word that we have added and each word that we have deleted. What word is that? And the third question, mainly I want to retrieve the file with state 2. State 2, after the state 2, in between state 2 and state 3, when I have deleted few words, at that stage, at that state I want. So how will we do it? How will we do it? So that's my question. So the question number 1, what is the second state of the file? And the second question, how many words have been added and how many words have been deleted, and you tell me each word that has been added and each word that has been deleted. Second question is done. And the third question, mainly I want to retrieve the file with a state in between state 2 and state 3 after deleting 5 words and adding 2 words. So how will we get that state? How can I reach to that state in between state 2 and state 3? These are my questions. Now you have to answer these questions. Anyway, you are following, if you follow the exercise, you might have done this. You should know how many words you have added on, how many you have deleted, what are those, and what is the state the state in between 2 and 3. Okay, answer the question, take your own time, and answer this question in comment box. Fine. So I do not know how you answer this. I will see I will see the comment section. That's fine. But for me to recollect the words that I have, the words that I have deleted, the words that I have added, and then the number of words is also very difficult, and for me it's impossible to retrieve into the state in between state 2 and state 3, because I do not know exactly at that state how many things, how many words I have removed and how many words I have added. So it's pretty difficult to keep these all changes tracking without any specific tool. So that's where a Git comes into the picture. A Git, I am talking about the Git, Git. That's where the Git comes into the picture. So the Git is going to do that. So a few years ago, when we were developers and writing code as a part of a team, we encountered recurring problems that were for the most part as follows. The first one is how to share my code with my team members, how to version the update of my code, how to track changes to my code, how to retrieve an old state of my code or part of it over time. So all these issues have been solved. So just replace the text file with the complete application code. You replace a text file that we have typed with the complete application code and see. So all these issues, all these questions will be answered by one tool. So of course, it's not just one tool. We have that version control system. Using that system, there are plenty of tools, but we are specifically talking about Git here. So that's the reason I'm mentioning Git. So these issues have been solved with the emergence of source code managers, also called a version control system, or noted more commonly as version control managers. So now, before we jump into the Git, and before we jump into look at various tools that are available in version control systems, I would like you to take you through one more example or one more assignment, so that it will be much clearer for you why we need a version control system. So this example is, let me bring it to my PPT. Yeah, here it is. Basically, this PPT is basically my brand guideline PPT. So I have two logos for my brand. One is neural mark. I call this as a neural mark logo. So this is because I have neural two neurons which are connected through the neural network, and in between my logo is there. Basically, I'm connecting this world with a neuron or neural network. That's what my logo represents. So for that, this is neural mark, and other logo is just a spread mark. I call this as a spread mark. Okay. So these are the two logos, and then here I have my brand, some of the brand guidelines like logo, which logo I will use in size and everything. Okay. So now when I was when I was designing my logo in a Photoshop, so what was happening when I was designing my logo? So after designing each state, okay, for example, so I have, this is the first stage, this is the first state of employee. So I have checked with the black color. Now I want to check how does it look like in white color. Then I want to make that neurons upside down, and then I want to check it. Then blue color, how does it look like? Then a blue color with a green, how does it look like? And then blue color with a orange, how does it look like? And blue color with orange upside down, how does it look like? And yellow and pink, how does it look like? Green and dark green, how does it look? How does it look like? And yellow, complete yellow. And this is one more logo just with a simple neural network I have designed. So when I was designing this on Photoshop, for each state, in when I see at black color, I have saved that photo and I put it in the PPT. And then after that, I have changed that to I made that into upside down, and then I've saved that image and I put it into slide. So now each slide of this PPT is a version of same logo, a different version of same logo. And then similarly I have did it for all, and after that I can go through the all versions. See, version 1, version 2, version 3, version 4. I can go through the all version. After going through the all versions, I found that black and then white. This in this way, not upside down, in this way it looks brilliant. So then I have decided, I have selected with these two. But then now question comes, can I retrieve any old state of my code, my logo? Of course, I have all the versions here. Whenever I want, I can retrieve the other versions. The next question. Now, I have versioned each state of my logo, so that's where you can find all these versions. Now if I want, I can share this, so at any time I can easily track the changes between each version. So this is version 1 and this is version 2. What's the difference? Sorry. This is version 1 and this is version 2. What's the difference? The color only difference, nothing else. From version 2 to version 3, you can see the logo is upside down and then it's slightly bent right side. Okay. And then the color change, it's a blue color. So even I can find out the differences between each version. So that's what the overall version control system is going to do. Nothing else. Nothing else. So whatever the version control system that automatically does, I have done it manually. Of course, you might have done it manually to design your logo, or to write some paper, or to write some love letter to your girlfriend. For example, the best example, you might have, I do not know whether you are loving love letters these days. It may be messages. So messages, because even when you type a message, if it is first time you're sending to your girlfriend, so what will you do? You'll write a nice message, and in that you'll do some editing, and you'll add a few more words, and you'll change, and then you'll come up with finally one nice, eloquent and beautiful message, and that you will send it to your girlfriend. But where are the versions, man? That's my question. What is the initial version that you have written? And how many words you have asked, how many words you have added to the initial version? What are the words you have removed? Do you know that? It is impossible to track all these things. You have to track all those things in coding. In coding, you have to track. Maybe if a love letter to your a love message to your girlfriend is not, if you don't track the changes, it's not that important. But for coding, it is must and should. It's compulsory. It is important. So to track all those things, so it is, we require a tool. So that tool, that system is called version control system, and the popularly used tool is Git. I hope you got why we require a version control system, either in real life or in software life. It doesn't matter, irrespective of the industry. This version control system is applicable everywhere, even in daily life. The logo design is my daily life, and then even everyday work, whatever you do. For example, you're writing a song for a movie, you're writing a poetry for a movie, or something, whatever it could be, you want to maintain that version. So that is the reason, irrespective of the industry, this version control system is widely used everywhere. As we have seen the requirement of version control system, and then importance of the version control system, and need of the version control system, so now it's time to see various version control systems that are presently available in the market. So but before that, what is the goal of VCS? That's the main important aspect. So the goals of these VCS, version control systems, are mainly to do the following things. The first one is allow collaboration of developers code. So basically, when 3 or 4, maybe 10 people are working on the same project, then they have to collaborate. They have to maintain a central repository, or it could be, there should be a repository where all these people can push the code, can place the code, and then can get the code. Or else it's very difficult to collaborate with each other. So that's, it's a point of collaboration. This VCS is a point of collaboration. And retrieve the code, of course you can retrieve the code from there, and at whatever state you want, then version the code, of course. That's what is happening, we have discussed earlier. And then track code changes. This is very useful thing. Track code changes. When basically, if there is a bug in the system, so by tracking the code changes, you can find out the place where we found this bug, so where this bug has been thrown out. So now, systems for version control can be briefly described as tools to keep track of changes in files. So it thereby becomes easier both to find old versions of files, and to be multiple people working on the same collection of files at the same time. So most version control systems are built either on a client server based architecture, or on a distributed architecture. So either client server based architecture or distributed architecture. So they can be, and they can be used to keep track of large software products like the Linux kernel or the Android operating system, but they are also very useful even in a small one person projects like those faced in a programming course. If you get to know the history of Git, your mind will boggle, your mind will uh, uh, go crazy, because this tool was found by the Linus Torvald just to manage his Linux project. So he's working on Linux kernel. So to manage, to collaborate with his fellow workers, he just he just developed a tool called Git. Okay, so that's the main importance of Git or version control system, is to keep a track of large software products like the Linux kernel or kind of any Android operating system. So now, so what are the uses that we have seen? And then now let's look into various version control systems. So Git Git is a commonly used centralized source code repository. It was created by Linux creator Linus Torvalds for the management of the Linux kernel source code. So all services like GitHub are based around the Git. So when I started working with Git, I had some experience with concurrent version systems. We call it as a in short, we call it as a CVS, concurrent version system, and Apache Subversion, SVN. So I try to understand it in terms of this classic source code repository systems. So that way of thinking only got me a limited understanding of Git's capabilities. Since then, I have grown to understand Git much better. So this video is a kind of note to self, text to remind myself how Git works and explain it to those who are new to it. I assume you know your way around other more classical source code repositories like CVS or SVN. So in this part of fifth module, what we will learn here is a Git architecture first. We'll begin with an architecture of Git, that to in depth. I'm going to explain each and every component of Git architecture. Once Git architecture is clear, so then only you can effectively work with Git. Of course, without knowing the Git architecture also, you can do all the activities. That is not an issue. But when there is an issue, then who answers the question? Then who solves the question? You have to solve the question. You have to solve the challenge, to solve that problem, you should know the Git architecture properly. That is the reason first I will take you through the Git architecture in depth, then we will move on to the activities on GitHub. So after looking into the various commands, and finally we will simulate the real use case of the Git in combination with the GitHub. We will now detail the steps of installing and configuring Git on Windows, Linux, and if it is possible, Mac OS system. Of course, we are going to do only for Linux and Windows, but I would show how to do it for Mac OS in Git documentation. So first, we'll begin with manual installation on Windows. So in this, the first step is to download the Git for Windows tool executable. So this Windows executable file we have to download from git for windows.org. So in spite of that, I'll directly go to this documentation, Git documentation, and we will download that. Git documentation, this is official documentation, Git SCM. Here you can see about documentation and then click on downloads. So Mac OS, Linux or Unix, and then Windows. Click on Windows. Here we have a standalone installer, 64-bit Git for Windows setup, and this is thumb driven. I'll click on 64-bit. Mine is Windows 11, so I'll go for the 64-bit one. So it's 50.5 MB, so it will take some amount of time. So meanwhile, let's go through the documentation by the time it gets downloaded. So here we'll have information about complete about Git. So branching, the main components of Git, those are branching and distributed. So you see master. So this is complete information about Git. You can go through it one by one. Distributed data assurance about Git only. So trademark of Git. So all that information. Then staging area. This is very important concept in Git. Oh, nice one. So if staging area in Git is clear, that means it's very easy to deal with Git. Staging area. You see, you have working directory, then staging area, then a repository. It could be a local repository. So once this setup is done, then you can connect with the remote repo. Of course, we are going to discuss in detail, but I just want to show this staging area concept is very, very uh, important. If that is clear, rest all will fall in place. See, when you do git add, the documents, the changes will be added to staging area, and after that, when you say git commit, those changes will be added to the local repository of Git, not the working directory. From this you can add, once committed, then you can add this by pushing. You can add this to a remote, from local to remote. So the staging area concept and then local repo concept are very, very important. So nicely given here. Fantastic. Very good documentation, not as a packer and this kind of documentation. It's better. So now let me get to the downloads, and here is the Git. Click Ctrl X, and or I'll directly install from here only, or else I'll place this in my directory. So hands on. So here I'll place it, paste it. So done. So now first step is done. Let's go to the second step. So the next step is to, once downloaded, we click on the executable file and follow the different steps that we are going to follow for the installation. Okay, so let's see the steps one by one, and then we'll go for the installation. So the next step is to choose the integration of Git in Windows Explorer by marking the Windows Explorer integration checkbox. Let me open this executable file. Do you want to allow this app to make changes to your device? Yes, of course, I want to install this in my. So now it's asking installation, please read the following important information. I don't need to read. If you want, you just go through it. I'll say next. So this is that one. So where do you want to set up your where do you want to place your setup? So that C, and then program files and Git. So this folder already exists because I have my previous one which I have uninstalled, but I did not remove. So would you like to install to that folder anyway? Yes, you just replace it. So here, so now once the setup comes, now let's get back. So choose the integration of Git in a Windows Explorer. That's what the Windows Explorer just now it had opened, by making the Windows Explorer integration checkbox. Then, so let's see, Windows Explorer integration checkbox has been checked. So if by default it will be checked, if it is not, you just check it. So I have checked it. Now choose the path environment variable option also, or we can leave the default choice proposed by the installer. So path environment variable, so by default we can go with it. Then okay, first we'll click next and then we'll check the other steps. So rest all fine, additional icons and everything, let's keep this default. Now this also don't we'll keep it like this, we don't need to do any changes. So choose the default editor used by Git. Which editor would you like Git to use? So use Vim if it is that, or else what all options are there? Notepad plus, Visual Studio Code, Atom, a lot of options I have because I have installed all those editors. But let's go with the Vim only. By default, when I say in Git Bash, by default I can use Vim, so it will install Vim. Or else if you ask, it will install, if you say Notepad, it will install Notepad. Visual Studio Code, it will install Visual Studio Code. But I will go with the Vim because that's a Linux specific. I am very much adaptable to that. So I'll click next. Then let Git decide. Okay, override the default branch name for new repositories. Okay, main. So let Git decide, you don't need to do. So next, and then use Git from Git Bash only, Git from command line, and also from third party. Yeah, you can use Git from command line as well as the third party, all are fine. So that's why we'll go with that option only. Okay, then I'll click on next again. So now this is what, use bundled OpenSSH or use external OpenSSH. I'll go with the bundled OpenSSH by default. I'll click next, and this is what, choose the type of HTTPS transport that we will also leave by default here in this case, with the use of OpenSSL library. So this OpenSSL library consists of a server certificates will be validated using the CA bundle.crt file. Okay, so then let's click on next. Now here we will choose the encoding of the end files. We will also select the default option, so which archives in Unix format. Here you see checkout Windows style, commit Unix style. Okay, checkout will be Windows style but commit will be Unix style line ending. So let me click next. Now this is what I was, so min tt, the terminal that we are going to use is min. So the terminal that we are going to use is min, so we'll keep this by default. We don't need to Windows default console. This is better, min tty. Then default fast forwarder merge, we'll keep it same, nothing to change. Git credential manager, again we'll keep it same, default. Configure extra options, enable file system caching, fine. And then configuring experimental options, these features are developed actively, would you like to try them? No, not at all. Okay, I'm not doing experiments here. So then finish the installation configuration by clicking on the install button at the end of the installation. So the installation utility proposes to open Git Bash. So let's see, the installation is going on. It is extracting all the files from the .exe, the git.exe. It is extracting it, it's unpacking it, and it's setting up the things in our system. So then once it is ready, we can use Git. So now it is asking the install. Okay, setup has finished installing Git on your computer. The application may be launched by selecting the install shortcuts. So click finish to exit setup. So it's asking whether you want to launch Git Bash or not. So Git Bash is a command line terminal Linux emulator dedicated to Git commands only. This is specifically dedicated to Git commands, but we can use it as a general purpose tool. I think if you follow my tutorials and modules till now, so basically we have used Git Bash a lot. Okay, so I'll say launch Git Bash also and click finish. Here it is. This is your Git Bash. All set, all ready. ls, clear the screen. I'll say git version git, sorry, here it is, Git version 2.39.1 Windows.1. This is specifically for Windows. So that's the reason. So with this, we have successfully installed Git on Windows machine manually. This is manual procedure. Okay. So now what is the another way? And the second thing is installation on Windows using automatic script, that is using Chocolatey. To install Git for Windows with Chocolatey, we must execute the command choco install git. Okay. So for that, what will we do? Again, we will go to our Windows PowerShell, run as administrator, then say S and say, okay, let's leave it. Let's say choco install git. So Chocolatey version 1.1.0 installing the following packages of Git. Let's see. By installing, you accept licenses for the packages. Let's see what's going to show. We have installed manually. So now we have installed manually. So now we are installing Git through automatic script. So 5%, 6%, it's gonna take more time. Let it go on. So we will move on to our slide. We will move on to our uh, next step in our slide. So, and the third one is installation on Linux machine. So installation on a Linux machine is pretty easy. So you have to use apt-get install git. That's it. I just want to demonstrate this on also. Before we set up our EC2 instance, let's look into Choco installation. How far? It's 25%. Okay. So let's set up our EC2 instance, and then we will install Git init. Yeah, it's taking some time, but still okay. That's fine. Yeah, we will set up. Mumbai is fine. In Mumbai, we are going to launch our EC2 instance. Name Git server is the name of the EC2 instance. I'll go with the Ubuntu. Ubuntu 20 is fine. Ubuntu 20 is absolutely fine. Then I will click on t2.micro. I'll go with the micro. That's fine. Okay, that's okay. Micro is okay. Then key pair, I'll say git kp. Then we have our security group, git sg, and my IP, 22 port my IP, and then click launch instance. What's the status? It's taking a lot of time, still 25%. Downloading git.install 2.3.9. And what is our version? I think it's same. Let's see. Okay, so let's click on git bash that we have installed manually. It's a git version. It's also 2.39.1. Let's see what's going to happen. We are installing the same. It should tell at some place that you already have this thing. Yeah, get back to the instance. So this is our instance. Click on connect. I think machine has been started or it hasn't started. Copy this instances. Machine is running. Let me get into the machine first. Clear the screen. Paste it. Okay. That's okay. We are in a wrong place. Let me bring the key pair first. downloads, git kp, and place it in our hands-on directory. Then here you open git bash and maximize it. Then say paste it. Okay, but before that I have to get into my EC2 instance and click on connect, and then copy the SSH command and paste it here. So we have logged into the system. So clear the screen first and then say sudo I, because I am a Ubuntu user, I will become a sudo user. So then what's the command that I have to use? It's apt get install git. So before that what I will do is I'll minimize this. Yeah, so I say apt get update. So we are updating the apt-get package manager tool. So once it gets updated, then we will install the git. So reading the packages, clear the screen, and I say apt get install git. Yes, it's getting installed. Setting up git 1.2. Okay, let's clear the screen and see git option version. Yes, here it is, git version 2.25.1. This is for Linux. So with this you can execute all the commands that you want to execute. So let's keep this machine on and we'll see further. And before that, let's check what's the stage. So it's stuck at this point because we have that window, we have that git version in it, so that 2.39.1 version we have, so that's the reason it's stuck here. That's fine. Let's leave this here. We'll say yeah. So Chocolatey install Jira packages failed. The log for details failure. Git exited. That's fine. We have that. So before you install using Chocolatey, you have to uninstall the tool that you have installed earlier in manual process. That's fine. Anyway, we have installed our Git in a both ways, manual installation and then automatic installation using Chocolatey, and then we have installed the Git on Linux machine also. So we have installed in a 3 ways. So then installation on CentOS or Fedora, it's similar to Linux, but only you have to say YUM. You have to use another package management tool there. And for installation on macOS, similar as we did with Windows, we use Choco. There we have to use Brew. So Brew package management tool we have to use. That Brew repository will consist of Git, and when we say Brew install Git, automatically it fetches the Git Git application, and then it will install the Git application in macOS. Git has been installed in my machine. I hope you also has installed the Git. So if your Git is ready, then it's time to explore about Git in depth. So let's check Git configuration, and we'll look into some of the terminology or vocabulary of Git. Let's begin with the Git configuration. So what is Git configuration? So Git configuration requires us to configure our username and email that will be used during code commit. So to perform this configuration, so what will we do is we will go to the Git. Okay, let me click on Git bash and then open it. Yeah, I'll keep it here. Yeah, let me make it bigger. Yeah, it's fine. So let us do the, because I have opened the Git only. So this is the Git. It's the CLI tool for Git. Git bash is the command line interface for Git. So now we are going to execute some of the commands so that we can configure configure Git with our username and our email. So we are customizing. So the first one is Git is the main command, and then sub command is config, and then we'll go with the option global. It's a global configuration, not local. So I'll global configuration. Then I say user dot name, that's attribute. Then give space, and I'll mention this is Surya, and then Charan. Okay, and let me execute this command first. Done. So then we will config email also. So global option will go with the global long option. Then it is user dot email. So and it is, I'll give my email. Yeah. So email also been configured. So now how do you get to know whether it's been configured or not? How do you get to know? So to do that, to check the configuration, to validate the configuration, so we can check the configuration values by executing git config, and then we'll use a global option, a long global option with a long list option. There won't be any argument. That's it. Git config and use global option, and then a list option. So this list option lists out all the configuration details which are related to the global. That's it. User dot name is Surya Charan, and email is this. So that's how we config our Git initially. So always and always you configure, you make configuration, make Git configuration, then only you start working on the other aspects of Git. So now let us look into Git vocabulary. So Git is now configured and is ready to use. So Git is a tool that is very rich in objects and terminology and has its own concepts. Before using it, it is important to have some knowledge of its artifacts and the terms that compose of it. So here is the brief list of this vocabulary. So it begins with a repository. So what is a repository? So a repository is the basic element of Git. It is the storage space where the sources are tracked and versioned. There are remote repositories that centralize a team's code and allow team collaboration. There is also the local repository, which is a copy of the local repository on the local machine, or it's a copy of working directory on the local machine. So let me demonstrate this on live on my GitHub. So let me go to the browser, click on, go to the Google, and then type GitHub login. Let me sign in to the GitHub. Yes, my GitHub account, it's been signed in. So I will directly want to show the repository. So whatever repo that I'm going to show, these are all remote repositories. These are not local repositories. Local repository I cannot directly show. Once we execute our first git init, after that I can show the local repository. But for this moment, you see the remote repository. Go to this profile, and then profile drop down menu, drop down button, and click on your repositories. Yes, of course, these are my repository. I have a lot of repositories here. That's okay. And then, so these are called repositories. So what is a repository? It's a remote repository specifically. It's a remote repository. So repository is the basic element of Git. It is the storage space. In a simplest way, it's the storage space where the sources are tracked and versioned, where the sources are tracked and versioned. So example, I'll show Ansible projects example I'm showing. This is one repository. So this repository is like a storage space, and this storage space consists of plenty of resources or sources, and these all can be tracked and versioned and can be maintained. So that's our repository. I hope you understood what is a repository. So now let us look into the one more terminology, that is clone. Clone Cloning is the act of making a local copy of a remote repository. That's it. Clone. Na? We say clones. These people, and you clone that. You clone this. Even in Photoshop, we use that word. We have a clone tool even in Photoshop. So clone is nothing but an act of making a local copy of a remote repository. So now let's going to do a local copy of a remote repository. So for that, I'll go to my repos. I will get back so to the Surya Charan Teja. That's the here I find all the repos. I'll click on the repo and I'll select ML repos. I'll select machine learning repo, my ML Madhu ML. This I am going to select. I don't know whether it is, yeah. So my ML is the repo. So I'll copy this HTTPS link and then I'll get back to my git bash and I'll type git and then clone, then give URL, HTTP URL of that, and then click enter. So git clone has been executed successfully. You can see the cloning into this repository, and it consists of 3 objects, and all the 3 objects has been downloaded. So now let me check the status of it. Clear, and then let me check ls. Oh, the wrong place. I have cloned it into a wrong place. Let me close this, and because it's a huge repo, of course, but what I'll do is I'll close this, and here is my hands-on, and I'll open one more directory here. It's git vocabulary demonstration. Yeah, here I will open my git bash and I'll make it bigger, little more bigger, horizontally little more bigger, and zoom it. I'll say git clone and then a repository URL. Oh, that's wrong one. Sorry. I'm sorry. Yeah. So paste the URL as it's cloning into. So it's been cloned, and let me check ls. Here it is, my ML. So that's what we got it, and let us check here my ML. This is our repo. This is our working directory, and this is our repo. Okay, that's how we clone the repositories. That's how we clone a remote repository. Cloning is nothing but creating a local copy. Then we have the third the third term, that is commit. Commit. What is a commit? A commit is a change made to one or more files, and the change is saved to the local repository. So each commit is unique and is identified by a unique number called it will give a unique number, says sha and then hyphen and then different numbers like that. So each changes, and that will allow us to work in isolation without affecting the master branch, without affecting anything. So this is how we commit the code. So let me show in a simplest way. I cannot show the exact code now, so exact commit now, because we have to do an exercise for that. But at this moment here you see, so what is commit? The simplest way, what is commit? Committing is a taking snapshot. That's it. That's it. So here, this is the initial state of my logo. Then after that I have changed this to this color. So this is my, I have done a change. Now this change should be added. Once it is added, then I have to commit this change. Commit means I'm saving this. That means I'm taking a snapshot of that change and I'm putting it into a separate file. Same, I have done some changes and then I have take the snapshot. Then I put it into a separate file. So each has their unique ID. Their unique ID, unique number. The first one unique number is 2. The second change unique number is 3. The third change unique number is 4. The fourth change unique number is 5. So this is what the analogy for commit. Commit is nothing but taking the snapshot of changes or saving the changes. In a simplest way, either saving the changes or taking the snapshot of the change. I hope you got it. So if you want to use the command git and you say commit and you give m, that's as a message option, then you type okay, this is my first commit. I'll say first commit ever. It's saying fatal. It's not a git repository or any of the parent directories of it. Okay, we are not in the git repository. Let me enter into the git repository and give the same command. So now it is main branch. Okay, what is branch? We are going to see. So now I will give the same commit and we'll see what is going to come. So git commit, I said git commit. It's saying on branch main, your branch is up to date with, so nothing to commit because we haven't done any changes to this. So there is nothing to commit here. But I hope you got the analogy. If you got the analogy, then understanding commit is damn easy. So then we have branch. So what is branch? Branch, what's branch? The code that is in the repository is stored by default in a master branch. Master branch in GitHub and main branch. Main branch in GitHub, if it is our local machine, it's a master branch. Okay, so a branch can create other branches that will be a replica of the master on which the developers make changes, and that will allow us to work in isolation without affecting the master branch. At any time we can merge one branch into another branch. So as I have shown you this here, if you see, it is showing as a main branch. The branch is main branch. Now we are in main branch. Inside that we have only one file, that's readme.md. readme.md. So if you want to create, if you create a new branch like version 1, then version 1, so that branch, if you create a new branch with version 1, and that branch is going to copy the same files from here. As I have said, branches are an important part of working with Git. So any commits you make will be made on the branch you are currently checked out to use. So let's use git status to check which branch that is. So we are on branch main, so that you can see on screen. Okay, here you can check, but still you are on branch main, so your branch is up to date with the origin /main. This origin is the remote one, and then main is here the local one. So sorry, origin is the name of this branch, the what we say we have given the pet name, kind of pet name for this, and main is the branch name. Okay, so that's it. So now let's create one branch. Now we are in main, let's create a branch. Git branch and say branch name is first branch, or we'll say version 1.0, because it's normally we create branches for versioning, na? So that's the reason we'll say version 1.0. And then let me enter. So the branch has been created. Just to cross check it, let us check into that branch. Let's check out to branch name is version 1.0. That's it. Now we are in version 1.0. Let me clear the screen and show you. I'm in version 1.0. So what is there in this? ls readme.md. Readme.md. That's it. That's the magic. That's what the branch is in uh, in in Git. So if you see, we have two branches and each branch has a readme.md. Let me check out back to main branch. It's a main branch. Sorry. Git checkout main branch. So now switch it to branch main. So here let us see ls we have readme.md. So here the same thing has been copied when you create a branch. So here how many branches we have? Branch 1 and branch 2. Two branches we have. Git status. So two branches we have. But we have only one directory. Let's get into that. So this is our working directory. This is our working directory, but it has a two branches. Those two branches, that's what we call, that's a separate, that's called a local repository, because it is in our local machine. Whereas this one where we are working now is called present, it's called current working directory. I hope you got the difference. A current working directory is the one which actually exists, whereas a local repository is delusional. It exists in a staging area, and after that staging area it exists. Okay, it's not here. You can see two branches, and you can see two branches, and you can see the, you can't enter inside the branches at this moment, at this point, exactly in the current working directory. So the differentiation you have to make is, one is current working directory where you are working, which actually exists in your Windows machine, and second one is a local repository that you can find out using the branches, and the third one is a remote repository that you see in your GitHub, in your GitHub account. Okay, so finally, if you want to merge, you can just use git merge and then branch name with version 1.0. So it's already up to date, so there is nothing to merge. But before the merging, let's go to that. Let's see what is the next terminology that we have. Then we have branch merge. So git merge combines the specified branch history into the current branch. So this is usually done in all pull requests, but it is an important git operation. So the code that is for merge, this is the action. This is the action that consists of merging the code of one branch with another branch. So let's do the. We will at git checkout. Okay, before that, let me clear the screen and bring this to this side. Yeah, so we are testing merge now. So git checkout, and what is that? Version 1.0. Yes, we switched to version 1.0. Here we have ls read.md, only one file. I'm gonna create touch two more files. We'll say file 1 1 2 5 and .txt. Let's see now how many files has been created. 5. So let's get back to the git do the git checkout, back to main. So we are back. So let's do the git merge with version 1.0. It's already up to date. So version, the git main is already up to date. So then checkout. So what is checkout? The checkout action we have seen. This is checkout. This is the action that allows to switch from one branch to another branch. So let's check out one more time. Clear the screen, and then here but before that, so after the merge, you can clearly see all the files has been copied, all the files has been brought back. So one more time, I just want to reiterate the purpose of merging is, it is mainly for versioning. What is versioning? So versioning is you have a base code. So on top of that base code, you want to add few more features to that application. So in spite of directly changing the base code, what will we do is we will create version. So we'll create version. That is one use case. I say git branch. This time I create version 2.0. So now I will add these new features. Anyway, when we do this, automatically the existing code in the base code will be automatically copied. So now we will add a new features into this. So I do vim read mg. So in this I will add new features should be added. Then I'll save this. So new things has been added into this. Now let's see. So this is the one. Okay, sorry, we haven't checked out to the version 2.0. Okay, first we will check out to the version 2.0. Git checkout version 2.0 ls. You see all files has been copied here automatically. When you create, the base code will be copied. Now let me do vim read mg. So as usual, so this consists of the 2 lines. So now I will add one more line here. So that means I am adding my new features. So feature 1, feature 2 and module 3. So then I'll save this. Now without merging, let's get back. Let's check out this checkout to main. So git checkout to main. So your branch is up to date. So let's do ls and cat read mg. All the features has been come. So that's how the main, so basically merging and checkout will help us in navigating from one branch to other branch. So this is the power of branches. So branches is mainly for versioning, and one more use case of branches is for the debugging. So when you are doing a debugging, you want to find a fault and you want to add some piece of code to that to solve that issue. In spite of changing the base code, you keep the base code in main branch, and then you create a version called debug. Git branch debug version, debug branch, and then anyway base code will be copied here, and then you change the code here. You do the debugging using vim read mg. So you change this, whatever module is, whatever piece of code is throwing error, you remove this and save it, and then you do the git merging with the main branch. That's it. If it is successful, you merge it with the main branch or base code. If it is not, just keep that keep that debugging branch like that. That's it. So now let's look into the fetch. So fetch, this is the action of retrieving the code from the remote repository without merging it with the local repository. So git fetch actually downloads all history from the remote tracking branches. So at this moment, this branch has a remote, this present working directory, there is a git initialized in it, and then at this moment we are in a local repo. What we are playing in a local repo, you see, main branch, it's a local repo. When I come out of this main branch, so now if you see, this is called present working directory. Once you enter inside the git, it's called local repo. So cd local repo. So now when I say git and then fetch, it's going to fetch the history of the remote repository. Then we have pull. So as usual, a pull updates your current local working branch with all new commits from the corresponding remote branch on GitHub. So git pull is a combination of basically git fetch and then git merge. It's like there is a new piece of code in something. See, I'll tell you one more example. So you have to explain each and everything with example, then only it's possible to understand. Okay, let me clear the screen. So let's take this example. So this repo, the GitHub repo, this is the repo. So all three people are working on this repo. Three developers are working on that. So I pushed a code and other one also pushed a code, and now the third one, so before he pushes the code, he has to pull this code from this repository and he has to integrate that with the local repository, then he can push the code. So for that, if you pull the code means it will fetch the code changes in the remote repo, that's where here, and then after that it will merge that changes with the local repo. That's what the pull is. Pull is a combination of merge and fetch. So git pull already up to date because there is no changes here. Let's get to the GitHub. Let's add a file, create a new file. What I'll give, this is, I'll type this script.sh and bin bash and pwd date. That's it, it's more than enough. And let's commit the file. Of course I haven't added any message, that's okay. So the file is ready. Now let's fetch. Before using the pull, let's fetch git fetch. So remote enumerating objects 4 done. So it has fetched this from the remote main to origin main. That's the local main. So now let us check the local main. It got with the script file also. Okay. So now in spite of so we got fetched it. Now we have to merge that with the local one. So git merge. So now updating that, fast forward. So here you can see script.sh. This is the one file has been changed and these 5 insertions has been done to our local repository. So literally from remote repo we are bringing it, we are fetching the data from remote repo and we are merging it with the local repo. Now you do ls, here is the script.sh. You can see that in green. Okay, so that's what the git fetch and merge do. So now what will we do is we'll create one more file, create a new file. I'll name it as code.py, and here I will add x is equals to 1, y is equals to 2, and x plus y is z, and I'll print z. So again, this is commit message python code, and then commit a new file. So new file has been committed. Let's get back to this, and let's say in spite of fetch and merge, we will say just git pull. That's it, game over. So it has fetched the data from, fetched the files from remote repository, then it has merged the files into local repository with one command. Let's do ls. Here is that code.py, the python script. I hope you got the purpose of merge, checkout, fetch, pull. So then finally push. So what push does is a push uploads all local branch commits to GitHub. So push is the reverse action of pull. It allows us to update the remote repository from the local repository. So let's get into our local repo. So this is our local repo. So let me clear the screen. We are in the main branch. So let me create one file. I'll say touch, and then of course we have added so many files. Now we have a lot of files in the local. So this, so we'll do git add all. So we'll commit, git commit all these files with commit message. This is the first commit to remote repository. So the commit has been done. So basically what is commit? Commit is nothing but the changes, whatever the changes that you have done, all will be captured, and takes the snapshot of it and saves as a file with the specific unique ID. That's what had happened here. You see, create mode file1.txt, file2.txt, 3, 4, 5, all the files has been changed, and these are the 3 insertions. Let me give git status. You see that here. So now use your branch is ahead of origin or main by one commit. Okay, my branch, local branch, this is a remote branch, it's ahead by one commit. So now you use a git push to publish your local commits. I have almost 5, you see, 5 files. I have to commit all these 5 files. For that I say git push. That's it, it's been pushed. So you see here, so total 4, all been done, all been done. So now let me get into my GitHub, and here is the magic. See, file1.txt, file2.txt, file3.txt, file4.txt, all files has been pushed into the remote repository. So this is how you can connect your local repository with the remote repository in GitHub. This is how you can interchange the files from local to remote and remote to local using the commands such as git fetch, merge, push, pull. Now let's deep dive into more git commands and more git architecture. So the main principle of git, so once you understand the main principle of git, it is astonishingly simple. So first, git handles the content in snapshots, one for each commit, and knows how to apply or roll back the change sets between two snapshots. This is an important concept in my opinion. So this is the real basic principle of Git. Anything else follows from this. So let's delve into Git a bit further. So let's begin with working with Git in a local repository. No remote repository, only local repository. So this is current working folder. I will show that. So as you can see on the screen, I will create the current working folder or current working directory. Okay, the folder name I'll create, and then so let's create our current working directory or current working folder. So new, so the name of the current, okay, I'll put current working directory. So we have created our current working directory, and this is that current working directory. Okay, so that's clear. So the first one is clear, current working directory, and that consists of number of folders, files. You can have a subfolder and sub files and lot of data in it. So as we have created our current working directory or current working folder, so now you need to run the git init command. So when you run a git init command, it turns your current working directory into git working directory and creates the repository in the .git hidden directory. So this is what's going to happen. That's it. So I'll keep this at this moment where we have only created current working directory. So let me enter into the current working directory and then open the git bash in this directory and make it, zoom it and bring it here. I'll keep it on left side so that it will be clear. Yeah. So now let me click on ls pwd. So we are in current working directory. You can see the visual representation of the same on the screen. Okay, here. So now I will create one file, 3 to 4 files I'll create. Touch file 124.txt, and then folders I'll create mkdir folder 1 2 3. You see, now you have 4 files and 3 folders. So for now, okay, let me enter into folder 1. Let me enter into the folder 1. Nothing is there inside that. I'll create 2 more files. Says touch file 11 to 12.txt. Yes, and similarly I'll create in folder 2 also cd folder. So touch file 21 23.txt. Yes, so okay, rm rf again, yeah. So we have, let me get back into this. Yes, so now our current working directory consists of 4 files and 3 folders, which is similar to the representation, visual representation in our screen. So let me take you to that working directory. You see, our working directory consists of 4 files and 3 folders. This is what is our working directory. So at this moment, let me take this. Yeah. Mm, yeah. So let me clear the screen first. Now ls I do option A. Now you can see only in this directory you have 4 files and then 3 folders, nothing else. Now what we are going to do is, let's do git initialization. Like we have done terraform initialization, we have done the packer initialization. Similar to that, we are going to do git initialization. What happens when you do the git initialization? When you do the git init command, when you use the git init command, it turns the current directory into the git working directory and creates the repository in the .git directory. Here it is. So if you see the animation, current working directory has become a git working directory, and it will create one more directory inside that is .git, and then it will create a local repository at the same time in the .git. Okay, so we will create it, we'll apply the same command and we'll see what's going to happen, what magic is going to happen. I'm giving, so git init, so initialized a empty git repository in this directory, in this path. So now let me check ls. Yeah, that's it, the magic happened. If you see here, just few seconds before lsa there is no .git. After the git initialization you see the .git hidden file. That's the same magic we have shown on in animation form. So now let us go into the .git and see what is there. So cd .git, this is actually git working directory. So now let me do ls. So it consists of a head, config and description, 3 files, and it consists of hooks, info objects and refs directories. Let me cat head. Okay, got it. So it consists of it is referring to the master, and heads are referring to the master. Then we have config, cat config. So config consists of this core information. Then we have description file, description. So description has a unnamed repository. You can edit this. Then we will enter into git hook. Sorry, cd hooks. So it consists of a number of hook files. So number of hook files. It consists of a number of hook files. So what is this hook file will do? So the hook file do cat, and then I'll take commit message. I'll take hook file. So what it is saying, this hook file, an example hook script to check the commit log message called by the git commit with one argument. That's the name of the file. So if you want to enable this hook file, rename this file to commit message. So you just rename it, then this hook file can be enabled and you can use this command. You can use this commit as a commit message. I think it's commit message as a command. So, and it consists of they have given some examples. So this example catches duplicate signed off by lines. You can add any some amount of script here, so that when you call that command, it's going to execute some kind of activities. Okay, so, and we have info, cd info. This consists of some folders, and we have cd objects. It consists of info and pack same, and then finally we have cd refs. So this consists of heads and tags. Whatever tags you create, all will be presented in this. Let me go to the tags at this moment. So there are no tags. There are no tags. We have just initialized the Git directory. So that's why there are no tags. And then let me get back and see the heads. There are no heads. So this is the present condition. This is the present condition. These are the files that are presented inside the .git, or we call it as a Git directory. It's called a Git directory or Git working directory. So the current working directory has become a Git working directory. At the same time, it's going to create a local repository. That's what a Git init will do. Of course, I know it's a detailed explanation, but I hope it helps you. So that's the reason I'm giving the detailed explanation with practical demonstration. So now, what's next? So the focus on the change set is the reason why in Git you have the add command, similar to SVN. So with this command, a change in the working directory is added to the staging area for the next commit. This staging area is usually called the index. Index. If you see on the screen, let me do this animation one more time. So it's getting started, and git add, when I give git add, the staging area will be created. What is this staging area? Where will it be created? Is this the magical? Where will it be? Is it this, will it be visible? You might have all these questions. I'm going to show you. Okay, so let's get into our directory and first clear the screen. So what I will do is I will say git add, and then I will add only one file, that is file one. Okay, where I am? Okay, I'm in a wrong place. Yeah, this is the correct one. So I do git add and I say file one.txt. I want to add only one file. Now when I say git add, where will this file be added? That's my question. Do you know? Does anybody know here? I'm asking you. If you know, you just post this in comment section. So when we say git add, where will it be added? Let's see why to answer. I'll say. So git add, the file has been added, but where will it be added? So here in theory we said the staging area, but where will that staging area be presented? Where will that staging area be presented? So I'll show you that. So now let me get into cd.git. You see, clear the screen first. Again I'll do ls. Here it is, the index. You see that? Index. And here is the staging area. And the staging area will be created inside the .git directory or git working directory. Okay, so now let me cat the index file. Here is that file one.txt. It's that visible, it's that simple. Okay, so whenever you say git add, that will be added to a staging area. In that staging area it will be located. It won't be added to some delusory place or area or directory or folder. No, nothing. There is a concrete index file is there. In that file it's going to be added, because these are all changes. All these changes will be added in that file. Okay, so now let me get back to our main working directory, current working directory. So I will add one more file, git add. This time I will add folder 1. Folder has been added. Let's again get into .git and then clear the screen. ls cat index. Sorry. cat index. Here it is, folder 1, folder 1, and then inside that folder file1.txt, and then inside that folder one file 12.txt. So file 11.txt and file 12.txt, everything has been added to the staging area. I think you're getting my point, or do I need to explain more? Kindly, if you have any more doubts, please ping me on comment section. I will clear off your all the doubts. So let me clear the screen now and get back to the git get back to the working directory, and I will now say git add all. All means all, everything. So I have added everything. So now get into this place and then do cat index. Where I am? I'm in the wrong place. Okay. Yes, I came out completely. It is current working directory, and then cd.git. So now I will do cat index. Sorry, cat index. Here it is. Almost all files have been added. File1.txt, file2, file1, file2, file3, then folder 1, file 11, folder 2, file 21, and folder 2, file 22, and folder 2 is here, and one more file, file 11 is here, and file 12, folder 1, file 12. So all files that our current working directory. So this is my current working directory. This is my current working directory, but here I cannot see because that .git folder is in, it's hidden. So that's hidden. So you have to change the settings and show hidden files, then you can see that, and inside that you can enter into the cat file also. But this is my current working directory, and this all these files have been added into this staging file or index file. We call that area, this file, we call it as a staging area, or we can call it as an index, whichever the one is better. So then we have yes, you see the animation, the file 1 has been pushed into the staging area. So file means it's not exactly file will be pushed, whatever the change that you have done, so it's related to the file, so the file will be added to that index file. Okay, so then file 2 will be added, file 3 will be added, and the initial state is A. Then after that, after adding these file states is B. So now it will take the snapshot when there was no file, and it takes the snapshot when 3 files have been added, and the difference it will note down. It will note down the difference. It will write it as A to B. So then we have once you have added this to the staging area or index, now you have to commit these changes, whatever changes you have done, in a simplest way, saving these changes, or else you have done the changes but you have to save these changes, you have to keep it alive. For that you have to save a change set from the working directory into the repository. So this staging, so for that we have to give git commit, and then m option means whatever I'm typing ahead is a message, it's a argument, that's what it says. Once you commit, then all these files will be stored as a snapshots in local repository. Okay, and you can see that this is snapshot content A, snapshot A, this is snapshot B. You can easily make out the difference the same way I have done with my, yeah, here I have done now snapshot A, snapshot B, snapshot C. I can tell the difference between snapshot A and snapshot B. The same way it will create a local repository, and inside that it's going to create that snapshot A and snapshot B. Now let's Now let's do the commit. We are committing to the local repository only. Okay, so let me clear the screen, get back to the current working directory. Yes, we have all the files. Now I'll say git commit and m option, then I'll type this is the commit message to understand the functioning of commit. So the commit has been made. What it is saying, master, that's the branch name, and then root commit. So this is the ID or snapshot ID. So this is the commit message. We have typed the commit message, and after that, how many files changed? 9 files have been changed. 0 insertions and 0 deletions. Only the files has been changed. Okay, this is what had happened. Now before we do anything else, get into let's get into cd git, and now you see, let me clear the screen first. ls commit edit message has been created. So if we cat the commit edit message, you see that this is the commit message to understand the function. Whatever commit message that I have given, that will be reflected there. Then let's get into cd refs, because cd tags, cd heads. Yes, master is the head. Before there was no head, so now the master head has come. So cat, yes, this is the ID. This is the ID of that master. So let me get back. So now let me look into hooks. cd info, cd objects. You see that all this, let me get into cd23. You see the code. Now let's read cat config file. Then again let's check cat head, master again, cat, then description we haven't changed anything. So let's read index now. Now you see, so all the folders, by and large, everything has been put into this, and it's been committed also. Okay, so we have covered all. So hooks we have seen, infos, log, yes, log, we forgot the logs. Logs we forgot. ls we have head, and then refs. Head we know, we look into refs. Inside that we have heads, master. Okay, sorry. Yes, this is what I want to show you. No. So what had happened? Okay, I'll make it bigger and I'll show it. Yeah, now it's fine. Same command, cd master and cat master. Yeah, here. So complete id, unique id, snapshot, and then these guys. And at this time commit, this is the initial message. It's the complete information about the snapshot, what had happened, how it had taken. cd get back to the working directory. No, still we are there, still we are there, still we are there. Yeah, now we are into master. Okay, so that's what happens. And so just to summarize whatever we have seen so far, we will have a Git working, current working directory. That is this. This is our current working directory. When you initialize Git, then it will become a Git working directory, that is .git. So that's our Git working directory. Then when you want to add these files, when you say git add the files which are present inside the current working directory, then it will create a staging area or index file, and these files will be added into that index file. And once it is added into the index file, then if you want to commit these changes, if you want to save these changes, like what happens when in while you are working on MS Word, after adding 3 or 4 lines, you would like to save that. You would say Control S and you will save that file. Similarly, whatever changes you are doing to your staging area, those you want to change it permanently, you want to save it permanently. For that reason, we have to commit it. Once you commit this, all the information, whatever changes you have done, all will be taken as a snapshot. So before commit and after commit, before commit one snapshot and after commit one snapshot, and that will be put it in local repository like this. Okay, so whatever activities that we are doing, that are not happening in current working directory. If you think all these commands are being executed in this directory, no, they are being executed in hidden directories, but they exist, but they are not visible for you. You have to use ls option a command to see them. So before conclude, I would like to tell one more thing, that frequently you will get this kind of message: capital C, capital R, space, capital L, capital F. This is for Windows, and LF for Unix. So and CR for Macintosh. So when you see, okay, this is not compatible with Linux, and Linux, this whatever code, whatever data that you have is not compatible with the Linux type. So this kind of messages you will get. So you will just understand what is the difference between CRLF and LF and CR. Okay, CRLF is specifically for Windows, LF is for Unix, CR is for Macintosh. So these are, what do we call this? These are all line break types. So CR and LF are control characters, respectively coded 0x0D. So it's a 13 decimal and 0x08 10 decimal. They are used to mark a line break in a text file. As you indicated, Windows uses 2 characters, the CR-LF sequencer. Unix only uses LF, only LF, and the old Mac OS uses CR. So CR means basically carries a return, and LF means a line feed. These are two different types of basically typewriting. So CR and LF, so two expressions have their roots in the old typewriter or TTV terminal. LF, what it does is, LF means a line feed. LF moved the paper up directly, but kept the original position identical. I think you are getting my point. I don't need to explain this. LF is a line feed. Line feed. You will have your pointer constant, paper will move up. That's called line feed. So LF moved the paper up but kept the original position identical. And CR, that's a carrier's return, brought back the carriers, so that next character typed would be at the leftmost position on the paper but on the same line. So whereas CR plus LF was doing both, so Windows will have both CR plus LF, that is carriers return and line feed, whereas Unix and Linux will have LF, that's a line feed, whereas Macintosh has CR only. So these are different ways to preparing for a new line, waiting for the new data to be entered. Let's see more commands. Git status helps you track of which changes have been added or not. So on what branch you are on. So, and git status lists the modified files in the workspace as well as the files in the index. So let's check the git status. I'll put it this side now. I'll clear the screen and I'll say git status. See, now we are on master branch, on branch master, and in this, at this moment, nothing to commit. So working tree clean. So there is nothing to commit. We haven't added anything. So now we will add one file in that. So ls, I will add this time a Python shell script. So touch script.sh. See, now we'll give the git status. Now you see untracked file. How many untracked file we have in this? We have one untracked file, that is script.sh. That's what it's saying. So what we have to do to track this file, you have to use git add and then file name. So git add and it's script.sh. Now let's give the git status again. So now on master branch, we are on master branch, changes to be committed. So the file has been added to the index or staging area. Now you have to commit this change. Now you have to commit these changes. These changes. So I would say git commit m option, and I say it is committing shell script. So commit has been done. You see that master branch and then short unique ID of this that snapshot, and committing shell script is the message, and how many files added, one file changed, and 0 insertions and 0 deletions. So this is in create mode. So now we'll give git status. So at this moment again, nothing to commit, working to clean. So what it does is it will check, is there any new files have been created in your directory. If it is created, if it is not added, if it is not committed, that it's going to show. That's what the git status says. It will make sure that every file is under tracking. So then we have git log. So git log shows the history of the changes, that is commits in the working directory or with the or just mentioning git log and then path, the changes applied to the given path. So let's look into the git log now. So I'd say git log and then graph, decorate the graph. Without that also you can get it, but I want a decorated graph. See here, nicely decorated graph, we got it. So how many commits we have made so far? If you remember, we have done only two commits. The first commit, just please, let me make it slightly bigger. Yeah, this is commit A, and then this is commit ID, snapshot ID, and then from, so head, this is head is referencing to whom? Master branch. So of course at this moment we have only one branch, so that is master branch. So head is referencing to the master branch at this moment. If we are in another branch, that time head is going to reference. Here it's simple. So this commit is done in this branch. That's what it says, nothing else. The head says this commit has been done in the master branch. So then this is other and date information. And what is the commit message? Committing shell script. This is the recent one. Then another commit. So this one is also same, head and master. So that's the reason both were put in same line. You see, same line. Then with the same indentation. Then this is the previous commit. This is the commit message to understand the functioning commit. Okay, this is the previous commit. Now you can see that you can get the number of commits that we have made so far using git log. Then we have, you can look at the differences between files with the git diff command. Just using git diff without parameter only shows the changes in the working directory that have not yet been added to the index. So let me clear the screen and add Python scripts now. Okay, touch module 1 2 dot py. So I have I think 2 Python modules. So now let me do git diff and see what's going to happen. So nothing had happened. It hasn't shown any differences. But if you want to use this git diff command, so you need to add your parameter. That could be basically if you have another branch. So now we have only one branch. Once we create the branch, that time we will use this git diff and find the differences between this branch and then master branch. Okay, so let's do that in next slide, not now. Okay, so git diff, and then if you give the name here or path, that shows the difference between the current working directory and the named commit of the working directory of the given path respectively. The name can be a commit ID or a branch name or another name. So anyway, branch name we are going to do in next slide. So here we will be doing with only commit ID. So this is good time to do this exercise. Okay, anyway, let me give the git status so that I can get nope, I'll give git log, and then I say graph, then decorate that graph, then I say all. Let's see where it is. So where is my, yeah, I'll take first 5, that's enough. Copy this, then clear the screen, git diff, and then paste it. Let's see what's going to happen. Nothing had happened. There is no much of difference between that command and that what do you call that commit and then master branch. So this time I'm gonna give the complete okay, anyway, we are going to see this git diff in our next slide. So let me clear the screen off now. So due to the length of commits IDs, those are called commit IDs. So git log, yeah, you see that very big commit ID, this much. You can see that it's huge. So because of the length of this commit IDs, we only use abbreviations like A, B, and so on in this diagrams, in this pictorial representation. Okay, so if you look at this example, the naming of things in Git. So snapshots are the main elements in Git, as we know. They are named absolutely with the commit ID. You see the commit ID, here it is. So which is a hash ID like 8D23CADF751, etc. So for example, it is derived from the content of the snapshot, which comprises of the actual content and some metadata like time, submission, or other information and parents, etc. This is what the meaning of a commit ID. It's not just simply made. So it consists of an information about the actual content and some metadata like time of submission, other information and parents, etc. So now Git can, let's see, okay, we are seeing the naming convention. Then Git can actually, for convenience, it abbreviate the long hashes to short names by taking the minimum number of characters from the start of the ID so that the short name is still unique within the repository. So in this example, instead of going for the here in this example, instead of going for the long hash ID, you can select the first four characters out of it, and then we can use it. We can use it in our commands. And note that the term commit is used both as verb for creating a snapshot and as a name for the resulting snapshot. Normally, you do not have to work with the commit IDs. Instead, you work with branches. A named stream of changes in other source code repositories is called a branch. In Git, a stream of changes is an ordered list of change sets as they are applied one after another to go from one snapshot to the next. So simply to put, a branch in Git is only a named pointer to a specific snapshot. That's it. It notes the place where a new changes should be applied to when this branch is used. When a change is applied to a branch, then also the branch label moves to the new commit. So how does Git know where to put the change from a workspace? So that's where the head points. That's where the head points. The head of the development is where you last checked out of your workspace. And more importantly, where to commit the changes, it usually points to the branch you last checked out. So note that this is the different from a CVS interpretation of the term head as the tip of the development of the default branch. So then how does Git know where to put the change from a workspace? So that's basically depends upon the head point. I'll show you that head point. 1 minute. So let me clear the screen first and enter into the Git. You see here, you can see the head clearly. This is the head I'm talking about. So cat head. Now at this moment it's referring to heads in, and it's referring to the master. So now whatever commit that I do, that commit will be attached to the master branch only. If you are in a different branch, if you checked out to the different branch and if you commit there, then the head will point to that branch. Anyway, we'll be doing that. Okay, so now we'll look into the tag command. The tag command names a commit and allows you to address the individual commit with a readable name. Basically, a tag is an alias for a commit ID, but commits can also be addressed with some shortcuts. So head as the tip of development in the working directory. So then we have a reflog. A reflog shows what has been changed during the lifetime of the name from when it was created, usually by a branch, until the current state. Now let's see branching. So the concept behind branching is that each snapshot can have more than one child. Applying a second change set to the same snapshot creates a new separate stream of development, and if it is named, it's called a branch. So in Git terminology, the head, capital H, capital E, capital A, capital D, that I have shown you in .git directory or Git working directory, is a reference point to the most recent commit of the currently checked out branch. So the current checked out branch is also known as the head branch. If you're not clear about what I'm speaking, I'm gonna do a practical demonstration to make it clear. So as we discussed, so this is what, so in Git working directory, you'll find this head. I have shown you that. And as discussed, the head is a reference to the last commit of our current branch. It is the last committed state of our project. So now let's take one example. So we can think of head as our current working branch. Simply to make it simple, head as a current working branch. So this is because the head does not point directly to a commit, but instead it points to a branch. The branch itself is a pointer, but references the last commit that was made on it. So the head is automatically updated by Git if we add a new commits to the current branch. So current branch, or we can switch to a different branch. Let's do that. So let's look into the figure now, the graphic infographic. So this figure illustrates this with a simple branch structure in Git. So the branch is a master branch. Basically, the head is pointing towards the master branch because we are presently inside the master branch. If you want to get clarity, so we are in master branch only. Let me keep this here so it would be much clearer for you. So if you want to, if you have a doubt, let me read it. Okay, it's dot git, and inside that I have head. See the reference, it's a master, so we are referencing to the master branch only. Now a master branch where some development happens currently points to the snapshot f. So that's where, but it has crossed all these stages. The initial commit was A, and then after that you have added some files, and then you committed those files, then the commit B. When it reaches the commit B, so there were two development streams going from the commit B. So one for the feature branch, other for the normal way, other for the normal way, one for going for the feature branch, other one is normal way, it's going on. So that's the reason we have tagged commit B as commit tag. Okay, so these are all commits. You can see that A commit, B commit, and at the B commit we have created a branch. And then now we have two streams of branches. One is this side, we call this branch as feature one branch, and if we want to add some features to this base code, till this code, whatever code is there till this part, that part will be copied into the feature one branch. After that we have added few more features into that code, whereas this is our main branch, this is our master branch. Okay, so this is our master branch and this is our feature one branch. So this we call it as a, we have tagged this one as a commit tag one. Okay, so let's practically look into this one. So we'll keep this diagram, the flow in the same way so that it would be much clearer for you. I'll give git, you see at this moment we have only two commits. Just see this one and then compare this git log with this diagram. So this is our first commit 21, this is that commit, and after that I have made one more commit, that is this. So these are two commits, and then master branch, the recent commit is at the master branch, and master branch was being referenced by the head. You see, head is pointing towards the master branch because all these commits happened in the master branch. So you see, it's similar. So now we will tag these commits with the num a and b so that it would be much easier to it's much easier to reference them. Okay, so I say git tag and option a, I'll name it as a capital A, and then for this one, this is our capital first commit, so I'll name it as a capital A. Then message I'll give, this is first commit, this is first commit, it's A. So let me give the git log and see. You see, now in spite of referencing this, identifying this commit with the big hash id, we'll say just A, this is A, commit A. So now I would say next I will name the commit B also. So tag it's B, and then I'll add, here is the hash id. I'll take till 7. I think 7 is more than enough. Then copy this and paste it here, and I say this is second commit or second snapshot, second commit or second snapshot, and I'll name it as B. Let me execute it and let's look the log one more time. Now you see, you got, this is commit snapshot A and this is snapshot B, just for the name, just for identification sake. So we are in, so first 1 and 2 are done, and we will for the B we will reference it as tag 1. Okay, commit tag, oh, B is our commit tag, that's okay, that's done. So now we will create a branch called feature 1. We'll create a branch called feature 1. So for that I say git branch and name is feature 1. Here I want to add some features. So now you can see your branch is ready. So let's give the log and see how does it look like. Now if I see, yeah, we have done only two commits, that is commit A and then commit B. So you have only 2, but we have now 2 branches. One is master branch. At this moment head is referencing, pointing towards master branch, and we have one more branch, that is feature. So feature will also have the similar kind of data. So let's get into the feature branch. Let us check out to the feature branch. Check out to feature 1. So switch to branch feature 1. Let's check. See, whatever files that were there inside the base or master repository, master branch, everything has been copied. See, whatever till now, till this commit, whatever files has been added and committed, all these files has been given to the branch B also. Sorry, branch feature 1 also. Okay, that's how it works. Now what I will do is I will add one file. This time I will add Terraform files. So touch, no, yeah, I'm in feature 1. You see here, you can see I'm in feature 1. I will add Terraform files. Touch Terraform files or configuration.tf 1.3.tf. So now I'll commit these things only into feature 1. this Terraform 1 and Terraform 2, Terraform 3 into feature 1. I will add this git add. Okay, but let me do git log. You see now? See the magic? At this moment, head is pointing towards the feature 1 because I am inside the feature 1. I'm inside the feature 1. That's what I was saying. Wherever we are, that's where the head points. So we are checked out to the feature 1 branch. Now head is pointing towards the feature 1. If you want to see cat dot, okay, before that I'll clear the screen. Cat dot git and then head. See the magic. See the magic. Before it was master branch, but now it is feature branch because we are inside the feature 1. We are inside the feature 1. Anyway, we have uh, we have got the clarity on head and then master branch and creating a feature branch. So now let's add the changes that we have made it to the feature 1 branch. Git add and then dot. So let me give the git status. You see, these are the files has been put into the tracking stage. Now it is time to add. Now it's time to commit. So now let's commit. Git commit and then option M. Message is this is the commit in. This is the first commit. This is the first commit in feature 1 branch. Okay, the commit has been made. Now let me give the git log and see. You see that the third commit and then head is referencing to feature only. Head is pointing to the feature 1 only. You see this commit, and I haven't tagged with any name. I haven't tagged, so I will tag it now. Then we will see that again. Okay, I'll clear the screen again. Now I would say git tag and option A, and this time it is G. I will give the name G and C. C D E F will come into the master branch. This tag, this commit will, I'll name it as a G. And message, this tag belongs to feature 1 branch. Now let's give that. You see that? Now the tag G. So this commit is tag G. Now you see that the feature 1 branch and head is pointing towards the feature 1 branch. So this side it is done. Now let's just check out to the master branch and we will do how many commits? 1, 2, 3 commits. We'll do 3 commits and see. Okay, so git and then check out to the master branch. Clear the screen. We are in the master branch. Now let me give ls. You see that? Only you can find file 1, file 2, file 3, file 4, folder 1, folder 2, folder 3 and script sh. That's it. There is no Terraform file. There is no Terraform file. Why? Because this is a master branch. In master branch we haven't added any Terraform file. So in feature 1 only we have added the new features. If those features are successful, then what we can do is we have to merge those features back into the master branch and then we can merge it, and that's the final branch. Like this we can maintain the versions also. So this we will do at the end of this slide. So but before that we will check the difference between master branch and then feature branch. So git diff. Now we are in master, so I'll give only feature 1 branch. You see that? So this is the difference. Mod1.py, mod2.py. So feature 1 has, this does not have. And then terraform.1, terraform 1, terraform 2, terraform 3. So all these files are the difference between master branch and feature 1 branch. So now you got to know how to use the git diff. Okay, so now let me create, let me commit, let me make the third commit in master branch. So for that I have to create a few more files. This time I'll create packer templates. Okay, so touch and packer 1 2 3 dot json. We'll do json only, then after that we'll do HCL when it is required. So this time it's json. So let me create. So I have added packer 1 2 3. So now I will add it to the staging area. So git add dot, so then all these three files will be packer 1 packer 2 packer 3 will be added to staging area or index. Once it is added to the staging area, so then I can commit. So git commit, so message these packer files are being committed to the local repo. So commit has been done. So now let's check git log graph decorate and all. Now you see total how many we have, how many commits we have. Tag A and then tag B, these two commits belong to master. And then we have tag C. Okay, I haven't tagged it. Anyway, this is the latest commit. This is the packer file commit. And then now the for this commit, head is pointing towards the master because we have done this in master branch. So let me tag this also. Let me tag the recent commit also. For that, git tag option A and then tag name I'm going to give is C. Then I'll copy the ID of this, yeah, hash ID or commit ID. So then I'll paste it here. Then after that what we have is message. So this is packer files commit tag is C. So now let's give git log graph decorate all. Now it's see. So tag A, tag B, and then we have tag C. This is commit C, commit A, commit B, commit C, and then commit G belongs to the feature 1 branch. That here you can see that. Is it visible for you or should I zoom it more? I'll just zoom it more. Yeah, just a minute. Yeah, this part, you see, this is feature 1 branch. It's pointing sidewards. Same. Is it similar? Is it similar? See, from B, this is commit B. From commit B, it's pointing sidewards for the commit G. See, from B, it's pointing sideward for the commit G and it belongs to the feature 1 branch. So we are close, by and large we are close. So now we are going to commit 2 more commits. So that is E and F. E and F. So for this I will create HCL templates. So touch, this time it's templates 1 2 3 dot HCL sorry dot packer dot HCL. Okay, so yes, templates 3 were added. So now let me do git add. Let me add it to the staging area, and it's been added to the staging area. So once it's been added to the staging area, now I'm gonna commit all these changes to the local repository. Git commit message m committing packer templates in HCL format. Yes, commit is done. So now let us tag this commit with E. I'll tag it with E. So there is slight mistake here. I should have two commits. This is D. So by mistake it's B. Anyway, I'll do that. I'll do that commit also. What's that? E. I'll commit with E. The commit name. Okay, before I tag it here, let me get into the Git log graph. Yeah, let me make it bigger. Yeah, let's tag it this commit also here. So git tag option A, and then it's E, and commit ID is till 44. I'll take, and then paste it here, and I'll give space. Then I say message, and this is packer HCL templates commit tag is E. Then it's done. Let's see the commit. You see that E. So here what I will do is I will check out to feature one branch, and I will change the tag of this to D, and then I'll create a new tag with a G. Okay, because A, B, C, D, E has been created, and F, where is that? And E, so F will come here. Okay, then after changing this to D, then I will create one more, and finally I will add it to the F. Okay, so let me check out git checkout branch name is feature 1. So I have been checked out into that. Now let me change the tag, git tag option A and G. So this is the one. I want to change this tag to 4, paste it, and then message M retagging. Okay, now let's check it. Oh, sorry. Tag G and then tag. Okay, this is I put it in a wrong place. Sorry, yeah. See, after tag I should have put uh, I did not put any tag here. So this time I will add the tag. Okay, anyway, that can be changed. Leave it. Okay, that's the G. So then we'll create one more tag, tag D. Okay, one more commit, tag D. For that I will create this time Ansible files, Ansible config file. Okay, it's the just AML files. Okay, so touch Ansible 123.aml. So add to the git add these files to the staging area, then commit these files, git commit m, and then committing Ansible config files. So commit is done. Now let's check how does it look. You see that? Now it's similar. You see this and this, is it exactly same? But we have to add one more commit, that's F, that we're going to do. But this this is commit A, B, and this is commit C. I think here here is that future one. Here we have that. So this is commit E, and this the recent commit, I will name it as a commit D. Okay, I would say tag again, git tag a, and tag name would be this time D, and then I will take recent 15bfc97, copy this, and then yeah, I will paste it here. Then let me give a message, and this is Ansible Ansible files committing tag is D. So now let's look into this and make it minus. So now you see A, B, C, this belongs to A, B, C belongs to master branch. Then we have D and G. Here we have D, you see D and G. D and G belongs to feature branch, and even E belongs to master branch. So this, I think, these 1, 2, 3, 4. So this section belongs to master branch, and these two belongs to feature 1 branch. So now I will check out to master branch, git checkout master branch, and I will give the final commit. So for this, yeah, we are in master branch now. You can see that on the screen. So I will create touch. This time I'm going to create so Ansible is done, Packer done. So we'll create some JSON files, just normal JSON scripts. Okay, touch. Okay, we'll create HTML templates. Touch index to .html templates. So we have two HTML templates. We can see that on the screen. So now what I'm going to do is I'll type I will add these changes into the staging area. Then I will commit these changes, git commit, and then message committing HTML files. So done, committing is done. Now it's time to tag that. So this tag would be git tag option A, and it is F. Okay, but before that we should note the commit ID, right? So commit ID we can see on screen. Okay, yeah, it's 44E. Yeah, where is that? It's on top. Let me type git tag option A, and then commit, sorry, and I'll give F, and I need to get the commit ID. Now commit ID is here, 44E23, sorry, 44E2391. Space, paste it, and tag message. This is committing HTML files tag is F. So let me yeah, now you see it's very clear. A B belongs to master branch, then G and D. So this is D, this is D by mistake. This is D and G. D and G belongs to feature 1 branch, and C, E, F, yeah, F belongs to master branch. Total 5 commits belongs to master branch and 2 commits belongs to feature 1 branch. And if you see here, oh sorry, if you see the head is pointing towards the master branch. So this is the condition. Okay. So now in our feature, so now if you look into the master branch, we will have a different set of files, and if you look into the feature one branch, we have a different set of files, different set of data. So these are two different versions. So how can we merge, what will we do, all those things we are going to do in our next session. Let's whatever the commands that we have used so far, let's look into all these commands one by one, and we will see the final uh, final tree diagram of the commits that we have done so far. So A, B, then after that it has gone to the different branch, that is B to D, then D to G. This branch name is called feature 1, and then after that C commit, E commit, F commit. So and finally the latest commit that we have done is F. So that's the reason my head is pointing towards master. So this is what we have done for this the commands that we have used, and B is the pivotal point to have two branches. So that's the reason so we call that one as a commit tag one. That's okay. So now git branch, to create a branch, this is one we have used, and after that we used git checkout to check out from one branch to other branch, then git diff and to find out the difference between the two branches, then finally then after that we have seen git merge, so that we haven't seen. So now we are going to merge both uh, this branch feature 1 and master, and we will see what's going to happen. Then after that we will look into various types of merging, fast forwarding, conflict merging, non-conflict merging, all those things. And then finally after merging, if you want to abort the merge, you can use that also. So these are the most widely used commands. So now let me get into our file. So I'll keep this one, clear the screen, and then log decorate all. You see, now we are in master, absolutely correct. So tag A, this is commit A, commit A, and commit B, commit B. So at commit B, we have created different branch, so that is commit D and G. So you see, at commit B, it's been separated into different branch, that is commit D and commit G. Okay, D and G, and the branch name is feature 1. Then as usual in main master branch, you have C, that's commit C, and then E, that's E, and then F, and then head is pointing towards the master. Okay, clear? Exactly right. See, and feature 1 is going to have the files till commit A and commit B and commit D and commit G. That's the reason they're both in green. You see color, is it visible? Green color, green color. Okay, whereas master will have all the files from commit A, commit B, commit C, commit E, commit F. That's what the uh, files information. Okay, so if you see, they're absolutely looking similar. So the graph from the git bash and then the graph in my slide is exactly similar. So now what will we do is we will merge the feature 1 branch with the master, and we'll see git merge feature 1. So what it's saying, merge branch feature 1, please enter a commit message to explain why this merge is necessary, especially if it merges an updated upstream into a topic branch. So lines starting with hash will be ignored and an empty message about the commit. So it opened WQ. So git merge made by the ORT strategy. So Ansible 1, 2, 3, these files, and mod 1, mod 2 files, and Terraform. These are the files that we have added from those D and G. So from that, so let's see. Now let's go to the git log graph and see. That's the magic. You see here, all became green. Green. So now we are in master. So it has created a new commit. Of course, it's a new commit. It's not the existing commit. We're going to show that. I'm going to show this is a non-conflict type of merging. I'm going to explain about this, but here I just want to use the merge command, and after using the merge command, how that merge takes place, that I want to show. So A, B, C, that belongs to master, and then E also belongs to master, F is also belongs to master, whereas D and G belongs to feature 1, all got merged. See, till here you see that flower symbol. So all these 5, and then D and G also has been merged, and finally it has created a new commit adding these new changes to this. And at this moment, so this is the new final commit. I tag this final commit as tag, sorry, git tag option A. I'll tag it as a, this is merge commit tag. Then I'll have a message, this is merging of two branches, those are master and feature 1, and this is non-conflict merge. Okay, now let's look into the picture again. Graph, you see that? So this is our tag, a merged yeah, it's a merge commit. So this is a new commit. So with this, whatever data that you have attached, it's like I told you, so you want to develop some new features, so you have developed those new features in the new branch. Now you just want to integrate back into the main base code. So then we have developed all the features and we have integrated back into the main code. So now let me see whether all files has been added or not. ls lrt, you see that file 1, file 2, file 3, folder 1, folder, these are initial ones with the base. Script is also initial. So templates from packer dot belongs to this, templates belongs to that, templates belong to feature 1, packer belongs to this one, index.html belongs to this one, mod, these are all these new additions from mod, Ansible, Terraform, all these belong to feature 1 branch, and all been brought it here. So all been brought it here. So that's how a merging helps, and this is how the new versions can be maintained. The versions after that, these versions can be integrated back into the main or master branch or main code. So now let's look into merging. So one thing you should remember is we are still working in local repository with Git. We haven't connected with any remote repository. Many people think Git means just connecting with the GitHub and doing something, sending files and cloning the files. No, that's not the Git. Git is this. So whatever you do initially in your local repository, then everything is fine. Then you connect with the remote repository. For that, we have to give a remote add command. Then once it is connected, once you establish a connection between the local repository and a remote repository, then only you can basically push or pull the data. Okay, that we will look into that later. But at this moment, it's all whatever we are doing is in a local repository only. So now let's look into the merging. So when you implemented your new feature, you checked it into the repository. So for example, on your new feature branch, you checked into your feature branch. When the feature is finished, you need to merge it back into the master branch. You do this by checking out the master branch and use git merge and then feature branch name. So that's what we have done it. So Git then merges the changes from the given branch, that feature branch, into the checked out branch, that is master branch. So that we have done it. We have seen that. You can see that image here. Let me put that. You see that? What I said? Git merges the changes from the feature 1 branch into the checked out branch, that is master branch. So what Git does what Git does to achieve this is it applies all of the change sets from the feature branch onto the tip of the master branch. So here the tip of the master branch, at the tip of the master branch, this G, that's a commit G and commit D, which belongs to feature 1, has been added into the tip of the master branch. So now depending on the type of changes in the two branches and possible conflicts, there are three possibilities that can happen. So either it can be a fast forward merge, or it could be a non-conflict merge, or it could be a conflicting merge. So but at this moment we are gonna look into fast forward merge. So what's fast forward merge? So for fast forward merge, the receiving branch, let's consider receiving branch as a master branch. Okay, always for us master branch is the receiving branch. The receiving branch did not get any changes since the two branches diverged. I think you got the point. If you look into the picture, you will get it well. The receiving branch still points to the last commit before the other branch diverged. So you can see that on the screen. In this case, Git moves the branch pointer of the receiving branch forward. Let me show that. So this is the example. So this is the master branch. We can call it as a receiving branch. And this is, so at this point after the commit B, this is being diverged into a new branch called feature 1. After the diversion, the master branch has not done even a single commit. Okay, in that case, so what kind of merge we get is, it's called fast forward merge. In this case what happens is, so this A, B, then it fast forward and it attach those D and G commits to this. That's it. So as shown, as I have animated on the screen, it will, the Git moves the branch pointer of the receiving branch forward as you see on the screen, because there is nothing to do besides moving the branch pointer forward. So Git calls this as a fast forward merge. It's very simple. As it does not have any commits, it is fast forwarding the existing commits of the receiving branch, and the feature 1 branch is putting their commits like that. In spite of in our previous example we have seen they have created a new commit altogether, but here they are not going to create a new commit. Whatever commits that feature 1 branch has, it will just bring it and place it in master branch. That is what we called as a fast forward merge. Fast forward merge. Now let's do an example for this. So wq clear the screen, cd get out of this directory, and I'm gonna create one more directory saying fast forward merge. So cd fast forward merge. So nothing is there inside this. Okay, so now git status. Okay, as of now we haven't initialized only, na? Okay, let me initialize first. If you see lsa, there is no file inside it, so git is not been initialized. Let me initialize the git first. So git initialization has been done. Now let me check lsa. So other than the git working directory, nothing else is there. So now let's add some files first, and we will create a commit A, then commit B, and at the commit B we will diverge into the new branch. Okay, let's do it step by step. Our first focus is to create commit A. Okay, let's create. Now for commit A we'll use just text files. Now we are in master branch, that you can see. So I would say touch file 122.txt. ls, you got the two files. So now I will add these two files to staging area or index. So two files has been added, git status. Okay, two files has been added. Now it is ready for the commit. I would say git commit and m option. So I say committing text files. That's it, committing text files. So commit has been done. So now let me get git log decorate, git log graph, and then decorate, and then just a minute, yeah, decorate all, git log graph. Okay, at this moment we have only one commit. So this is our first commit with the committing text files. I'm gonna tag this with a so that we can identify easily. So it is git tag option a, and then it's capital A tag name. Then I'll copy the hash id or tag id and commit id. We have copied it. So now we will write the commit message. So this is committing text files is identified as a capital A. So now let me do, you see that it's tag A. Of course we have only one branch, head will point out to the master, that's not an issue. So tag A, absolutely fine. So we got our first commit. So the first commit has been identified with the tag A. So now we are going to add few more files to make the second commit. So I would say this time I would add text files are done. Then we will go for the Python files. So touch module 122.py ls. You got the module files. These are the Python files. Now let me add these files to the staging area or index. Then let me commit these files. Commit to commit message I'm gonna write is committing Python modules. Done. The commit is done. So now let me check the graph. Anyway, here from this we can get the hash id or commit id. So let me tag it. Git tag option a, this one is b, and then it is b21e74e. then tag message is committing Python modules is identified as capital B. Done. So now let me check the git log, which is, so tag A and then tag B. So commit A, and we have two commits which are identified as A and B, that is in master branch. So now it's time to create another branch. Let's diverge from here. Okay, we will tag this we will tag commit B as commit tag also. Okay, because that's where diverging tag, we will say diverging tag or diverging commit, we'll tag it like that. Okay, this one I would say here diverging commit. Okay, then message I'm gonna give is this is a diverging commit. After that, new branch is gonna be created. Done. So let me, you say that. So we have diverging commit. So we have tagged this commit also. So A, B, and here we want to create a new branch that's called feature1 branch. So git branch, name of the branch is feature1. See that? Now again, let's run it and see. So we have created the feature1 branch. Now let us check into the, let's check out feature1 branch. So now we are inside the feature1 branch. Let me check what all files are there. Of course, this file1 and file2 are the result of commit A, and module 1 and module 2 are the result of commit B. So because A and B, after that the feature branch has been created, so all the files which are there in main master branch has been copied into the feature branch. This is known fact. So now here we are going to create two more commits. One is D and other one is G. Let's do D first. Okay, D, for that we are going to add files. I will add directly Excel file. Okay, so touch, here we will add, okay, PPT and Word file, because this is featured now. So we there it's related to Python, and here it's there in master branch, it's related to programming. Here the files are related to the word editing. Okay, so word processing files. Touch, I would say PPT presentation 1 to 2 dot ppt. Okay, so ls, yes, we got the presentation 1 and presentation 2, two files. So now I will add these two files to the staging area or index area, and once it is done, I'll commit these two files and I'll attach the message presentation files are have been committed. Okay, so then its commit is done. The commit message is this. Now let me tag this. The tag I'm going to give is capital D. So git tag option A capital D, and then it's 25 A 8 FC B, then message, it is committing PPT files, committing PPT files is identified committing PPT files is identified as D. Done. So let us look into the graph. You see that? So this is our new commit. At this moment we are inside the feature 1 branch, so that is the reason head is pointing towards feature 1 branch, and then the latest commit identified as a D. Okay, superb. So now we have to create one more commit as per this, so then we can go for the merge and we'll see what's going to happen. To create one more commit, I'm gonna create a few more files. This time I'll create word files. So touch, let's say touch and article 1 2 dot word. So ls the word files has been okay, yeah, article 1 and article 2 dot word files has been added. So now it's time to add these into the staging area or index area. Then after that we'll commit them using, and the message is committing word files. Now we will tag this commit also. Git tag option a, and this one I name it as G, correct? The other one we named it as D, right? This one is capital G, and then it's 3 4 5 2 AA4. That's the commit ID, short commit ID. So now I will add a message. So message is committing word files is identified as, what is that? It's G, correct? Yeah. So let's look into the graph, log graph, which is, so tag A, tag B belongs to master. You can see that here. So tag A, tag B belongs to master branch till here. That's it, till here. And then tag D and tag G belongs to feature 1 branch. At this moment head is pointing towards the feature branch. That means we are inside the feature branch. Okay, this commit has been made inside the feature 1 branch. Now in feature 1 has all the data. You see that? Tag A, commit A data, commit B data, commit D data, commit G data. Whereas let's check out to the git check out master branch. We switch to master branch and let me execute the same command. Now if you see, let me make it bigger. Now if you see the master, where is master? So here. So master branch only has the files which are committed from A and B. Only in these files, whatever the files you have committed, that only those files only master branch has. And so we got the difference. So now this is master branch. Let me check ls. So master branch has only 4 files, that is file 1, file 2, module 1, module 2. Let me go to the git checkout and then feature branch ls. It has, in addition to file 1 and module, it has a presentation as well as article, so ppt and word files also. So let me check out back to the master branch. Okay, so now you see the image. So this part is done. So this part is done. We have exactly set up our both branches this way. Now let's do the merging and we will see what is going to happen. In this case our receiving branch is master, and then merging branch is feature 1. Let's see, let's execute the merge and see what's going to happen. So git merge feature 1. Merge is successful, updating B21E74E3452AA4. These are the two commits. Basically these commits tagged with D and G. So now let me run First, let me run the graph log graph and see the magic. Fantastic. It did not create any new commit. You have only the same commits exactly has been copied, or the files which have been added from the commit D and commit G has been copied into the master branch. So that's the reason now. So master branch has all four commits. You see that? If you see, the diagram exactly resembles this. And here the D, the last commit, which is G, the G commit had master as well as feature one. Now if you see, feature one has all these commits and master also has all these commits. So that's the reason the final location of feature one in the graph is at the top commit, because master also has all these commits, files that belongs to all these commits, and feature one also has files that belongs to all these commits. So if you remember exactly, we got it. This is what we called as a fast forward merge. Let me check the files. You see that we are in master and all the files are there, Word files as well as PPT files. This is how our fast forward merge works. I hope it's very clear. So now we will also see other types of merging. So merging primarily depends on so it depends on the type of changes in both the branches, merging branch as well as receiving branches, and possible conflicts that those changes bring. So there are three possibilities that can happen when merging takes place. One is fast forward merge that we have seen in our earlier session, then a no conflict merge, and the third one is conflicting merge. So let's look into the no conflict merge and then we'll go for the non conflicting merge. So in no conflict merge, there are changes in both branches. If they do not conflict, then no conflict merge takes place. Let's take this example. So this is our first commit, then this is our second commit. So now our head master. So then at B we are going to take diversion to the another branch, that is feature 1. So once we take the diversion to the feature 1, in feature 1 we have created two commits, that's D and F, whereas in master we have created two commits, that is C and E. Okay, this is the condition of our repository. So after creating the E, so the master will be pointing to the E, the head will be pointing towards master, and that would be at E, commit E. Okay, so now we want to merge this feature 1 with the receiving branch, that is master branch. How can we do it? What type of merge we'll get? In this kind of situation, we will get the no conflicting merge. You see that? No conflicting merge. If you have this kind of commits which are not conflicting with each other, so here you can get the no conflict merge. Let's see how it looks. A and then B as usual. Then at here the diversion remains same, then DF, whereas on other side C and then E. But what happens with the no conflicting merge is these two will be considered as one commit, and it will be committed, it will be added or it will be committed as a new commit. We call this new commit as a merge commit. So whatever files that you have added in D commit and then F commit, all these files will be added to the master branch with a new commit, and we will identify that new commit as a G, and this commit is called a merge commit because it is merging the files from feature 1 branch into the master branch. That is the reason we call this as a merge commit. And this kind of merging is called no conflict merge. So let's quickly get into the practical demonstration of this. So I won't explain everything now because we have been doing these exercises for almost 1 hour. So let me quickly do this so that I can demonstrate the actual one. Okay, so let me clear the screen and ls. So I'll come out of this. So I will create one more directory. This one is no conflict merge. ls cd to no conflict merge. Nothing is there. Let me clear the screen. lsa no git was initialized, so I will initialize the git. So lsa, so git has been initialized. Now let's start our action. So I will create so as usual in master master we will create a programming related files. In feature we'll create word and ppt templates. Okay, so here I'll begin with .py. So touch module.py, that's enough. ls one file is enough. Then git add git commit message adding committing python modules. Then let me tag this git tag option a, capital A, and then it is 5650 acc, then m option, and then it is committing python module is identified as, how do we identify, as tag a. What's the issue? Okay, 5640. Oh, that's the mistake, and that's so it's better to copy. There is no such commit 50. Yeah, it's done. Now you give git log and graph decorate and all. Okay, so the first action done. Here is that a the initial commit has been identified as capital A. Then we'll do the second commit quickly. For this I will use .net. I use .net extension, or say .html. It's simplest one, easiest one. So index.html, git add git commit, where is that, git commit committing html templates, html templates. Then let's tag it, tag I'd say b, and then it is 569bfd2, 969bfd2. Then I'm committing html template is identified as b. Done. So let me log, let me see the graph. Yes, you see commit a, commit b. So two commits has been identified as a and b. So at this moment, if you see here in our previous animation, the head is at b. So now let's take the diversion from b. Let's create a branch. So git branch, and we will name it as a feature1. So now let's look into the graph one more time so that we'll get a clarity. See, at this point we have a branch. You see that branch. So here we have taken the diversion. So I'm going to add one more tag to this. We call it as a diversion commit. So let me check the graph. Yes, so this is tagged as diversion commit as well as b, and then it's feature1. So now let me, after creating the branch, so now we have to do the c commit also, commit c. So I'm going to add one more file. This time I will add .css. Okay, it is touch template dot css, added git add and git commit, committing css templates. So committing is done. Now we need to tag it. Tag, let me come here. I'll tag this as C in master branch, and it is F426646, and then committing CSS template is identified as capital C. Done. So let's look into the graph. You see that? So feature 1 is left at here only. You see that? Because this is where at tag at B, at commit B, the diversion has taken place. So after that we have created a C. So that means it can't be a fast forward merge. Okay. So now let's check out to A, B, C is done. Now let us check out to the D. Let's check out to the feature 1 branch, and let's do our first commit in that, and we'll identify the commit as a capital D. Okay, git checkout, and it is feature 1. So we have switched to branch feature 1. So let me check what all files are there. You have index.html, module.py. That's it. We do not have CSS file because that was created after creating this branch. By the time the diversion has been taken place. Okay, it's clear now. Okay, so now let me create ppt file. So template, ppt template, ppt. So the file has been created, git add, and then git commit m option, and message is committing ppt templates. Okay, done. So let me tag it. Tag, we'll tag this as a capital D, correct? And it is, let me copy this and paste it. It would be much faster than typing. Copy and paste it. So committing ppt template is identified as capital D. That's it. Let me check the graph now. Let's see how does it look. You see here? You see that? A, B, C is in one line, and A, B, D is in another line. You see? A, B, D. This is in one line. A, B, C. This is in one diversion. Here at B, you can see the diversion. You see the diversion. Two routes, a bijunction. B is a bijunction for us. Okay. Anyway, so next commit we will do, so A, B, C, D, E. E commit we are going to do in master branch. So let's check out to master branch. So now we will do the graph. You see that now A, B, C. A, B, C. Now head is at the master branch. This is one unit, and A, B, D. This is one unit because A, B is common. The files that has been committed using commit A and commit B is common in master branch as well as feature 1 branch. So that's the reason A, B, D is the root of feature 1, and A, B, C is the root for the master branch. So now let's create one more commit in master branch, that is E. Okay, so we will add one more file, touch. Now we will take .NET file. So okay, database file. We'll take the SQL database. Okay, students db, git add, then git commit m option and committing database files. So now let's tag this. This is E, right? Capital E, and this is, sorry, yep, copy, done. Okay, committing database files is, oh sorry, that's okay, it's just committing message, it's fine. So then let's check how does it look like, the graph, log graph. You see, a b is common for both. A b d is, this line is the feature one branch, and a b c e is the master branch. You see here, exactly, a b c is the master branch and a b d is the feature one branch. So now let us check out to the feature one branch, and we are going to do one more commit. So git checkout feature one branch, and see, a b c e is one branch, a b d is one branch. So now let me add one, let me create one file. This time ppt is done. Okay, so now word file. So story.word, then git add, git commit message committing word file, then let's tag it. This time it's f. So f, and it is cc81a, paste it here, then committing message, we say word files is identified as capital F. That's it. Let me check the graph now. It should look exactly similar to what, yeah, it's exactly similar, exactly. If you want, I'll zoom it a bit. It's enough, right? Little more. Yeah, it's perfect now. So let me make it bigger. Yeah, it's clear now. Commit. Yeah, let me make it a little more bigger. A, B, C, and E. A, B, C, which is green, that belongs to master branch. Exactly, you see here, A, B, C, E. So A, B, C, E, this is master branch, and then A, B, D, and F, this is feature one branch. At this moment the head is in feature one branch because we are inside the feature one branch. So it's clear, the picture is exactly depicting what I have depicted in what I have depicted on the slide, correct? So now let me, this is correct one. So let me check out master branch. Now I'll give again the same one. You see, now exactly we are representing the picture. So this time A, B, C, D is our master branch. Sorry, A, B, C, E is our master branch, and head is at master branch. You see, master head is at master branch, and then D, A, B, D, F is at is belongs to feature one branch. So simply, if you put it in another way, the files which are committed through A, B, C, E, are there inside the master branch, and the files which are committed through A, B, D, F are there inside the feature 1 branch. So now feature 1 branch is like a development for me. So I just want to merge all those files that I have committed in feature 1 branch into the master branch, because master branch is the main branch. Master branch is the base branch. That's what the final I want to use it. So this feature 1 is a development. So I am doing development. As I do feature 2 development, as I do a few more developments, I will create more branches: feature 1, feature 2, feature 3. At the end of the day, I have to integrate all these new features back into the master branch. So now I am going to do that. Let's see how it's going to turn up. So git merge, and what's that branch? It's feature 1. Okay, it has thrown a message saying, but we are not worried about that, WQ. But meanwhile, the merging has taken place. So what kind of merge? So merge made by the ORT strategy, the Git has formed a strategy, and then story.word and templates.ppt. These belongs to feature 1 branch of story.word is f commit, and template.ppt is d commit, and these two has the two files has changed, and it has created a new 1006464 10064. This is a new commit. Okay, so let me go for the graph. See the magic, and exactly see this graph, exactly same, right? See this? I will explain. Okay, so A and B commit, these are common for the both the branches. And then E is C and E is only belongs to which branch? It's master branch. So A, the green one, A B C E, till here it is master branch. Whereas feature branch A B and then where is D and then F. Now what happened? So the D and then F, these two commits, the files which are committed through D and then F, has been committed to the master branch with the new commit. We call this new commit as a merge commit. Okay, so you see that this new commit is called the merge commit. You see that line? It's been the branch feature branch here. This is head master, and the feature 1 branch has been merged into the master branch. Okay, yeah. Okay, let me name that first. Let me tag that. Let me tag it. So I will tag this as a merge commit and copy the commit ID. So this is merging. This is merging two branches. So this is merging two branches, and this is identified as merge commit. Okay, brilliant. So now let me see the graph again. You see that this is our merge commit which is on top. Now let me explain one more time. So this is, see the flower symbol? Okay, I will make it bigger. I'll make it bigger. Yeah, there is no point also. Whether we make it bigger or smaller, that much only visible. Yeah. So this is commit A. It's common. Commit B. Oh, sorry. Commit B is common for both the files which are committed through B is also common. Then we have commit C that belongs to master. Then we have commit E that belongs to master. You see that green color till here it's green, and after that you have red. So these four commits belongs to master A. Okay. Then after that there is after B there is one more branch got diverged. Okay. The diversion has taken place after B. So this branch is called feature 1. So feature 1 has two commits, that's D and then F. Now if you see these two commits these two commits has been merged back into the master branch with a new commit called merge commit. I hope you got it. Same thing had happened here. A, B, C and then D, F belongs to feature 1. When we do merge, this D and F, whatever files that have been committed through D and F has been merged back into the master branch with a new commit called merge commit. Let me make this much bigger. You see that? Now I'll scroll it up. This is commit A, commit B. Then at commit B, the diversion took place, and then that's the feature branch, feature 1 branch. Feature 1 has two commits, that is D and F, and these two commits has been merged back into the master branch with a new commit, and we call that new commit as a merge commit. Okay. So that's how our no conflict merge works. I hope it's pretty clear for you because I have shown the animation as well as I have shown the practical demonstration also. So now let's look into the conflicting merge. So if there are changes in both branches, but if they conflict, if they conflict if the changes are conflicting each other, in that case the conflicting result, what we get is a conflicting merge. In that case what Git says is the conflicting result will be left to the working directory for us to fix it and commit it. We have to enter and we have to check, okay, so which commit should be entered first, and then which commit should be entered later, that we have to give it manually. So once you have give it manually, then the system will execute that command. So that's called a conflicting merge. So with this we have seen all three types of merging: fast forward, no conflict, and conflicting merge. So now we have seen merging and types of merging. So now it's time to move into more advanced topics in Git. So one of that is so the concepts of rolling back and re, replaying change sets carries even further with advanced features like rebasing and cherry picking. So sometimes you develop a feature, but the master development also heads on in parallel, and you don't want to merge your feature just yet. The consequence would be that the two branches move away from each other quite quickly. So it's however possible to apply change sets from one branch to another. So Git offers the rebase option and cherry picking feature for that. So let's look into the rebasing. So rebasing, imagine that you're developing a feature, and you need to incorporate the latest changes from the master branch to keep up with the general development. So this kind of functioning is called rebasing. So rebasing your feature branch, so it moves the diversion point between the two branches up on one of the branches. So what Git does is it then replaces the changes from one branch on top of the tip of the other branch, so creating new commits for each of the original commits. In the example, that we are going to see on the screen. uh, we will we will demonstrate this example after understanding the animation of rebasing. So commit A, and after that commit B. As usual, exactly at commit B, from the master branch we have diverted into the new branch, and the branch name is feature 1, and this feature 1 branch consists of capital D and capital G to capital G, two more commits. And after that, in master branch we have added two more commits, that's C and E. So this is the present condition of the master branch and then feature 1 branch. Okay, so master has 4 commits, and then feature 1 has 4 commits, that A, B, D, G, and then master A, B, C, E. So this is the master line, this one is a feature 1 line. So now what is rebasing? So for rebasing, so you have to check out to the feature 1 branch, and there you have to say git rebase master. When you say git rebase master, what's going to happen? Let's look. A, and then B, and then we have a diversion at B. Then that's the feature branch, which consists of D and G commits, and master branch consists of C and E commits. Now once you give git rebase master, we want to rebase the master, then what's going to happen? Let me click and see. I have clicked, yes, that's the master is at E commit now, because that's the latest commit. Oh, once you give git rebase master, this is going to happen. Let me reanimate this. Once I gave git rebase master, this is going to happen. What had happened? Rebasing the diversion point from commit B to commit E. Commit B to commit E. So that is going to happen. This is what we call it as a rebasing. So if the replay results a conflict, a rebase stops at the first conflict and leaves the conflicting state in the working directory for the user to fix. Then the rebase can be continued or aborted. So with the onto option, the rebase can actually move the diversion point onto any newer snapshot in the other branch. So that's how it works. So this is git rebase master. So let's do the demonstration for this. Okay, so clear the screen, cd ls mkdir and rebase. Cd rebase, ls nothing is there, clear the screen, git init, then let's begin our action. So commit A, so as usual touch module.py git add git commit. I'm not giving commit messages too much, I'm just giving, yeah, then tag it, then after that message again A, capital A. So done. So git log graph decorate all. Okay, the first one is done. Then similarly touch, I will give this time it's dot html. This is B. Then tag B, B, rest all remains same, and then commit ID. Okay, again, yes, you see, commit A and commit B, and exactly the condition that we have shown before diversion. The master, the head is at the master, pointing towards master, and we are in the master. So now let's take a diversion now. So git branch, it's feature 1. So now you see that you got the diversion. You see the diversion. Now let me add one more. So diversion branch, that's B. So let me tag diversion branch. Sorry, this is B. That's okay. Here, diversion commit. Yeah, now you got it. So this is our diversion commit for this moment before rebasing. So now we'll check out to the git checkout to feature 1 branch, and so now commit D we have to add. So touch paragraph dot word git add git commit m, this is D. Then tag it D 61. This is D, correct? Yeah. Done. D is done. And we have left with C also. So let me get into the git checkout master branch. So let me add one more file. This time it's CSS. That's template.css. Git add, and then git commit m option, and it's C. Then tag it. It's C, and it is 26 D1665. Then it's C, rest all fine. Let me check the okay. So A, B is common for both, and D belongs to feature 1 and C belongs to. So this line, the straight line for the master branch, and then a Y till B, and after the diversion, this 1, 2, 3, these 3 flowers is for the feature 1 branch. So now let's check out back to the A, B, C, D, E. So E we are going to create. So one more commit we are going to create here. So touch, what is that? What we are touching now? We'll create okay, packer. So touch template dot packer dot HCL. Then git add git commit m, it is E. Then E, here is that BA897BA. So copy this and paste it here. This is E, rest all same. So let me check the log now. Yes, you got the A, B, C, E. This belongs to master branch. A, B, D belongs to feature 1 branch. So now let me check out to the git checkout, and it's feature 1 branch. So now I have to add one more. That's G, commit G. So touch, and this time I'll give PPT. So article this is mm, business PPT, business template. So git add git commit m option, this is G. So now let me add tag this G, and this is C44E6. Copy this and paste it, and this is G again, rest all same. Okay, sorry, yeah. If you see this now, git A, git B is common for both. The diversion point is at here, you can see that diversion commit and then B, and after this from here the straight line which goes to the D and G, this line, exactly this vertical line belongs to master branch, and this diversion point belongs to, sorry, this vertical line belongs to feature one, because we are in that branch now. So let me go to the git checkout master. Now let me execute that. Now if you see, but still okay, git checkout feature one. Anyway, that's fine. So till here it's tag commit A, commit B, and after that commit C and commit E. This line belongs to master and this vertical line belongs to feature one. So total in master we have 4, that's A, B, C, E, and in feature one we have 4, that is A, B, D, G. Okay, proper, perfect. Now it's time to do rebase. So git rebase, whom you want to rebase, master. That's it. Git rebase master successfully rebased and updated. Let me zoom it here. Successfully rebased and updated refs, heads, and feature one. So that's where your rebase will be there. So now let me execute and see the magic. So where is your rebase? Now B is no more a diversion point for us. Okay, it has created so one more commit which is not tagged. You can see that head feature one. So that's how it works. The base has been rebased. Now we will look into the most useful and important concept of Git related topics is GitHub. So what is GitHub? In a simplest way, a GitHub is a source code repository. Source code repository. Okay, so this is GitHub is a storage space where we can store our source code and collaborate, and all other people, or maybe 5 to 6 developers can collaborate and working on that code. So that's the simplest way. Now we will add more complexity into this definition. So GitHub is a code hosting platform for collaboration, and the most importantly, version control. So GitHub lets you and other fellow developers work together on a same project or any kind of projects. So the GitHub essentials are repository. It's nothing but a storage space with additional components attached to it. Then branches, we have seen the branches in a local repository. If you remember, whatever we have discussed in our previous sessions about the local repository in our local machine, all the principles will be applied to the remote repository also, because GitHub uses the Git tool for source code management or version control system. It uses Git only. So the same principles can be applied to the remote repositories also. So, and commits, pull requests, obviously Git, the version controls software on which the GitHub is built on. So now let's see the GitHub installation and configuration. Then we'll see the most important terms in GitHub. So let's look into the GitHub configuration. So we have to, with a personal account on GitHub, you can import or create repositories. So collaborate with others and connect with the GitHub community. So let's, the first step in starting with GitHub are to create an account. So then let's create an account. And once we create an account, we choose a product that fits your need best. Means in GitHub, after create your account, they will provide you with 3 products. One is free, other one is you have to pay some money, and the third one is for the teams. So one is free, other one is personal, and other one is to work with teams. These are the products. You have to choose one and then verify your credentials, that's email address, and set up 2-factor authentication, and then you can view your profile. So this is the way we can create our account or configure. So it's not just creating an account. After that, we have to configure that account. There are several types of accounts on GitHub. So every person who uses GitHub has their own personal account, so which can be part of multiple organizations and teams. So your personal account is your identity on github.com, like Facebook, like Insta, like LinkedIn. It's also here also you have to create your account, and that account will be identified. It is an identity for you in that github.com and represents you as an individual in github.com. So let's begin with create an account. That's our first step. So to create an account, so let's sign up for an account on github.com. Let's get into that. Yeah, this is a github.com and this is my account. So I'm gonna sign out now so that I can create a new account, and then I would say sign up. Okay, so sign up. Now it's asking, welcome to GitHub, let's begin the adventure. So it's asking me to enter email. I'll give cherryrams127@gmail.com and click on continue. And password, yep. So would you like to receive product updates and announcements via email? I say N, no. So now verify your account. So please solve this puzzle to verify that you're human. Okay. So pick one square that shows two identical objects. Pick one square that shows two identical objects. So done. Now let's create an account. So we are almost done. So it's the second. So it's basically they have sent a launch code to email. So let me get into my email and I'll bring that code. Yeah, I'm looking into my phone to get that launch code. Yeah, it's just a minute. Yeah, here it is. Got it. So it is launch code is 7343925. Launch code is too big. Done. So now how many team members will be working with you? So I would say 2 to 5, that's enough. Are you a student or teacher? I would click on student and continue. And what specific features are you interested in using? So collaborative coding we are going to do, automation and CI/CD, and project management. Okay, those two are more than enough. That's it. Now the second, so first one, creating an account, and to keep your GitHub account secure, you should use a strong and unique password. That we have done it. So now the second step. So choosing your GitHub product, you can choose GitHub free or GitHub Pro to get access to different features for your personal account. You can upgrade at any time if you are unsure at first which product you want. So let's choose. So at this moment we have two products here. One is absolutely free, other one is okay. I've selected the student, so that's the reason. Other one is a different product. If you are a teacher, the product suggestion would be different. So as a student, it was get additional student benefits if you want to go with it. So this one, of course, it's not free, but there will be some discount offers such. So for free, we'll get unlimited private repository, unlimited public or private repository. So how much you want, you can create, but and then 2000 CI/CD minutes can be set. Continuous integration and continuous deployment can be set, and then 500 MB of packet storage, 120 core hours of code space compute, 15 GB of code space storage, and community support. This is what we are going to get as a free account. So let me click on continue free. Oh, wow, brilliant. I really like that effect. So it's every 1 month they're going to bring some new additions to the it's uh, UX, basically user experience. They'll make some changes to the UI, user interface, and some changes to the UX, user experience. Okay, it's done. So now you can see that this is your rep. We have created an account in GitHub, and you see that account name Cherry Rams. That's the username I have given. Brilliant, fantastic, fantabulous. So then verify your email. So that has been done, or you can set up one more. So then if you want, you can configure for two-factor authentication. And what is two-factor authentication? So two-factor authentication is, or 2FA is an extra layer of security used when logging into websites or apps. I strongly urge I strongly urge you to configure 2FA for your GitHub account for the safety of your account and for the safety of you. So then let's view our GitHub profile and look into the contribution graph. So your GitHub profile tells people the story of your work through the repositories and gists you have pinned. So the organization memberships you have chosen to publicize, the contributions you have made, and the projects you have created. So let's do that action now. It is, yeah. So let me click on profile. Where is that? Your profile. So name, image, we haven't changed. Let me put the status. Busy, stay status. Then now you see that your contribution graph, you see, till now we haven't contributed anything because just now we have opened our account in 2023. You see that joined GitHub, just joined GitHub 2023. So now let me edit a profile. So name I would give Surya Charan Teja and add bio crazy about AI and mad about ops. And finally, in one word, in love with AI ops. That's my bio. I hope you like it. Okay, then Imlike is my company. Imlike.org. I'll take Imlike. That's location Kannadiga, Bengaluru, and display current local time. Website, my website is www.imlike.com. Twitter, cherry.twitter.com. Save it. That's okay. Done. So my profile has been edited, all done. Okay. So now let's get back into our slide. So with this, we have created a new account in GitHub and then we have configured that account also. So now let's look into some of the work terms of GitHub. So the first one is creating a repository. What is a repository? So basically to collaborate on GitHub, we are going to do some activities. So what are those activities? The first one is creating a repository. A repository is like a folder for your project. So you can have any number of public and private repository in your personal account, because we have seen that while we are creating an account, as we have selected the free account on top in the product guide, it is mentioned that you can have n number of public and private repositories in your personal free account. So repositories can contain folders and files, images, videos, spreadsheets and data sheets, as well as the revision history for all files in the repository. So let me show the repository first. Just come here to the drop down menu next to the profile icon. Here you can find in this vertical menu, first is your profile, then your repositories, your projects, your stars, your gists, your sponsors, and all other stuff, settings and all. So let me click on repository. I have clicked. So now the repository page has been popped up. Now if you want to create a new repository, you click on new, and then owner name is this. I have only one account in this, so owner name is Cherry Rams, and repository name I'm gonna give as first ever repo. Okay, and description, this is just to understand what is a repository in GitHub. That's it. I'll make it public. That's it. Initialize with a repository. I'll add a readme file with that, and then let us click create a repository. Yes, the repository has been created. Now if you see here, you can add any file. You can either create a new file or you can upload a file. So for uploading a file, you just drop from there and drop it there. To take from some folder, and you just drop it here. That's it. We have uploaded the PPT. So .ppt file. So you can actually upload anything similar to that. Okay. So that's how your repository works. Basically, it's a storage space in simple words. Then we can clone a repository. Okay, so cloning a repository, the next activity in GitHub is cloning. What is cloning? That we have discussed in our previous sessions also. You can clone an existing repository from GitHub to your local computer, making it easier to add or remove files, fix merge conflicts, or make complex commits. Cloning a repository pulls down a full copy of all the data that a repository consists of that GitHub as at that point in time. So it including all versions of every file and folders for that project. Just to reiterate the same sentence, repositories, when you clone it, repositories can contain folders and files and images, videos, spreadsheets. So when you clone it, what exactly happens is cloning a repository pulls down a full copy of all repository data that GitHub has at that point in time, including all versions of every file and folder for that project. So let's going to do the demonstration of this and see, then only you will get to know that. So let me put one file here. So GitHub, I'll directly drop it here. Okay, and I will commit this also. So file has been uploaded. So I'll say ppt commit and commit changes with the same branch, master branch. Here it is, I think, main branch. Okay, it's main branch. Now our repository consists of how many files? Two. One is ppt, second one is readme.md. md.md extension is markdown extension. Okay, so now where do you want to clone it? So I will go to that folder where I want to clone it. I'll come here. So part 1 here, hands-on. In hands-on, I'll click on new folder. So this is GitHub clone exercise. So GitHub clone exercise. Here I'm gonna open our git bash or git bash. So Yeah. Okay. Let me make it bigger. Now let me check what is there inside that GitHub clone directory. Let me check the pwd present working directory. We are in GitHub clone directory. So what is there inside that? Nothing. So nothing is there inside. It's absolutely empty. Okay, so now I'm gonna clone it. I'm gonna clone this directory. For that, you just go to the drop down button on code and next to the code, and then https, and copy this https link and say git clone and paste it. Cloning into first repo, enumerating objects 6 done, and compressing those objects, and then after the compression it's going to bring it back to our local machine. This is in a local machine. Let me see, let me do ls. Here it is, here it is, your first repo. You see the name, first repo. You see the name here, first repo. You got it? If you don't get it, I will explain it one more time. Nothing else. Okay, so if you see that, what are the files in it? PPT and then readme.md. Readme.md. Okay, so we have seen here. Let me get into that directory directly. You see that first repo has come here, and then these are the two files. This is what we call it as the cloning a repository. Simply the data which is in the remote repository, we have cloned it into our local machine. In this case is my personal laptop, on which on that machine I'm recording my video. In that personal laptop, I cloned a repository, a remote repository from the GitHub into my personal laptop. That's called a cloning a repository. Then it's called forking a repository. Forking. What is a forking? Fork is a copy of a repository that you manage, where any changes you make will not affect the original repository unless you submit a pull request to the project owner. So most commonly, forks are used to either propose changes to someone else's project, or to use someone else's project as a starting point for your own idea. I hope you got it. If you don't get it, I will do the demonstration. Okay. So let me get into the, okay, I will take the best. Okay. Python application GitHub. Python application GitHub topics. Yeah, somebody's okay, some Muhammad or somebody. Okay. Anyway, that's fine. I do not know who is this guy, but I just want to fork this. I want this repository. This is somebody's repository, somebody's GitHub repository, that is Mohammed. Okay, Mohammed. This guy's repository, I want to copy to my GitHub account. So this is my GitHub account, Cherry Rams, and this Mohammed. Okay, this is Mohammed GitHub account. So I want to copy this repository to my account. How it is possible? How it is possible? For that, here you have fork. So now I have created a new fork. So this is I'm the owner, and this. So now let me click on, this is the application I want. A repository name is awesome Python application. You see that? Then description, Okay, whatever description that he have mentioned, we'll keep that same only, and I'll create fork. So now a repository is being created. Now let me get into my my account, and then to refresh and get into my repositories. Here is the magic, man. Here is the magic. Of some Python applications, a repository has been copied, or best way to say is forked into my account. From Mohamodu account to my account. You see that? That's what we call it as a fork. A forking a repository. So then there is one more important important feature that GitHub has is you can enable GitHub discussions for your repository to help build a community around your project, and maintainers, contributors, and visitors can use discussions to share announcements, ask and answer questions, and participate in conversation around goal. It's basically to make a effective and efficient collaboration. That's it. Let's deep dive into teaming up in GitHub. So with GitHub team groups of with GitHub team groups of people can collaborate across many projects at the same time in an organization account. So this slide will walk you through the setting up, configuring, and managing your GitHub team account as an organization owner. So the first we will look into configuring your organization account on github.com. So about organization, what is organization? Let's see what is an organization. Organizations are shared accounts where businesses and open source projects can collaborate across many projects at once. Owners and administrators can manage members' access to the organization's data and projects with sophisticated security and administrative features. So that's what an organization is. So now I will show you one organization. So or else we'll create an organization. Before that we will look into okay, first we'll create an organization, then we will look into teams in that organization. Okay, now it's time to create our first organization in GitHub. So you can see that this is my new account that I have created only for practical demonstration of GitHub, nothing much. Okay, so here this is the profile drop down. Here you will find these settings, whereas if you come here and this part, you will get this plus symbol drop down menu. So consists of new repository, import a repository, new code space, new gist, new organization, new project. So I'm gonna click on new organization. It's taking some time. Yes, pick a plan for your organization. How often do you want to pay? Neither. I don't want to pay. I don't want to pay. So, so we have three options here. First one is absolutely free. So, but there are limitations. Unlimited public or private repositories, but code space, and these are the limitations that you have. Whereas second one specifically for teams, and these are the benefits you'll get it out of it. Whereas the third one is for the enterprise consists of plenty of teams in that, so that's the reason you have a lot of options here for enterprise You can see all those options. 50,000 CI/CD minutes per month. Brilliant, brilliant. 50 GB of packages storage. Okay, that's okay. So let's go with create free organization. I don't want a paid one. So let me name it as first organization. First organization. And I DevOps for you. Okay. First organization of I DevOps for you. So email I'm gonna give Cherry Rams. Then my personal account organization belongs to my personal account. It's not belongs to institution, not neither to Volvo, GitHub. No, it's my personal account. Then verify your account again. So pick one square that shows two identical objects. I think this one. So I hereby accept all the terms of service. So it's gonna create our first organization. So the first organization has been created and it's saying, welcome to first organization I DevOps for you. Now you can start collaborating with each other. Let's collaborate. So add organization member. The first step here is add organization members. Organization members will be able to view repositories, organize into teams, review code, and tag other members using at the rate of mention. We can even chat. I'll show you that also. So now I will give you Surya Charan. Oh, there are a lot of Surya Charans, huh? Like me. Brilliant. Fantastic, yeah. That's nice to know. Surya Charan Thandu. But I think nobody will be with the name Surya Charan Teja. Yes, that is only me. Yeah. Okay, let me add this guy. So I'm gonna add one more person. That's a Rahul Ramesh. This guy works in Volvo only. In the same team, it's 97, I guess. Yes. Yeah, this guy, Rahul Ramesh. So we are forming an organization, and that organization consists of three members. One is Cherry Rams, Surya Charan Teja, and Rahul Ramesh. And let's click on complete setup. So now we have to give more information. What do you spend time on most day to day? I do now I'm doing writing code also, but mostly I do managing and coordinating in not engineering work, it's software works. Okay, I'll select these two. Billing administration, nope, not at all. So how many people do you expect to actively work within the GitHub organization? I would say 1 to 5. Yep, fine. Then what type of work do you plan to use this organization for? Open source projects, education projects, and personal projects. That's it. No work projects. Nothing to describe here, or just to write it is used to demonstrate GitHub organization GitHub org in my iDevOps for you course. So what do you expect to do on GitHub in the next 7 days? I say manage code, collaborate code, set up CI/CD. That's enough. Now, do you have an existing repository for your project? No, not at all. We're going to create that. So let me submit it. So you can now follow organizations. Okay, got it. Now we have sent the request to other two members. At this moment, we have only one guy in this organization. We have sent a request to other two people. So once they accept, see now we have only one guy, but invitations were sent to two people, Rahul R and Surya Charanteja. So let me accept the request on another laptop. So let me refresh it. I should get the notification of this organizations. Yeah, I got it. And okay, I'll show you that. I'll show you that. I will log out from this account. I'll sign out from this account and I'll sign into my another account, that is SU. Oh, oh, yes. No thanks, dude. I don't need your help. I can remember. So let me go to your organization. See, you got the blue button. There is something. Yes. So organization's invitation will expire in 7 days. Would you like to join or would you like to decline? I would say I will join. So you have been invited to first organization ID for you. So join first organization. That's it. Join. So now I can create a new repository from here in that organization. But that's okay. Now I'll get back to our uh, tutorial account. Our account that I have created for this tutorial specifically. Okay, that is Cherry Rams. Oh, just remember the names. Huh? Yes, done. So now let me go to your organizations and see, this is my organization that we have created recently, and let me click on this organization, and now you see you have two people and one more person. He should actually accept it. It's taking more time. Okay, we'll accept it after that, after some time. So here you can see that 2FA, two-factor authentication. Here you can attach the roles. That we will look into this after some time, but for now creating an organization and inviting the people is done. So next, let's look into creating teams, about and creating teams, a GitHub team in an organization. So teams are groups of organization members that you can create to reflect your company or group structure with cascading access permissions and mentions. So organization members can send notifications to a team or request reviews, and teams can be visible or secret. So you can create independent teams, or you have multiple levels of nested teams also to reflect your group or company's hierarchy. So anyway, that we are going to see in creating teams and that hierarchy in our next slide, but for now we will look into adding members and setting up teams first. Okay, we have invited the member when we are creating a group organization itself, but for now we will look into creating a team. So managing members of your organization. You can invite anyone to be a member of your organization as long as they have a personal account on GitHub. So you can also remove members and reinstate former members for your organization. So let's do one exercise in creating and removing, inviting new people or new accounts. Okay, so here we have, so you can see that invite a new member. These are the existing member. I can invite a new member. I have my intern, she works under me, Jancy Volvo. Yeah, here it is. She works under me. She's an intern. She's been almost 11 months. She has finished she's completing her internship. Okay, Jancy Volvo. So I'm gonna send invitation to this girl. Invite. So the invitation has been invite this girl to this organization. A role in membership. Do you want to make her a owner or just a member? I would say members. What members can do, what privileges a member can have. Members can see all other members first and can be granted access to repositories. So they can also create a new teams and new repositories. These are the limitations for them. Whereas for the owner have full administrative rights to the organization and have complete access to all repositories and teams. They can do everything in that organization. So that's the reason I don't like to give a Warner role to anybody other than me taking in that organization. So let me send invitation now. So the invitation has been sent by Cherry Rams to Jancy and then Rahul. Let's wait for their approval. Once it is approved, they will become part of our team. So, okay, one guy has accepted and other girl had to accept. So let me check the members of my organization. So invitation. So I have at this moment in this organization three members are presented. One is Surya Charan Teja, Rahul, and then that's a Cherry Rams. Other one is Surya Charan Teja. I'm talking about the username. Cherry Rams, Rahul Ramesh 97 and Surya Charan Teja. So total three members. I hope the girl will also accept her. Then so our team is set up. So this is how we can actually manage. We can actually create, invite a new member, and then we can delete a member and we can remove a member and we can reinstate. Okay, so next we will look into organization permissions and roles. So each person in your organization has a role that defines their level of access to the organization. The member role is the default and you can assign owner and billing manager role as well as team maintainer permissions. So now let's look into those. So how many permissions we have? Owner, billing manager, and team maintainer. Let me get into the organization. That is our organization. It's a first organization ID for Y. And then here I will go to my members. So these are my members, my people in my organization presently. So now I can attach roles to them. It's like permissions and roles. So this guy Cherry Rams is the owner of this organization and other people are members. Okay, so now let me click on any user. This is Rahul. So one member selected. Now if you want to remove this guy from this organization, you just click here. So then say remove from organization. This guy will be removed. And if you just want to make him as an outside collaborator, that's he won't be a member inside our organization. Then you click on outside collaborator, then this Rahul will become outside collaborator, not the member. Okay, anyway, this is we are not going to do. Let me click on change role. So when we click on change role, either it can become a owner or member. These are the two roles we have. So as usual, we will keep him as a member only. And there, if you click here, you can find that. So Rahul Ramesh. Okay, so let me click on manage for Rahul Ramesh. And then this is where you can find the information about this guy. He's a member. So you have owner and then member and then collaborator. So At this moment, he is a member of this organization. I just want to keep him as a member of this organization. I don't want to make him as a owner of this organization. So let me go back to the settings of this organization. Just want to show you. So if you want to customize your organization, you can give organization display name. This is my org, my DevOps org, and then you can give email, everything. Let me update the profile here. So here you can find repository specific roles, member privileges. So let me click on member privileges. Here you will have the base permissions. If you want to change these base permissions, from here you can change what all privileges you want to give to a member. Okay, do you want to give, see, we will go through that. Anyway, we are looking for the permission, so we are working on that only now. Organization permissions, and then roles we have seen member and owner. So now member, what kind of privileges a member has. So these are base permissions. What are those base permissions? To the organization repositories apply to all members and excluding outside collaborators. Since organization members can have permissions from multiple sources, members and collaborators who have been granted a higher level of access than the base permissions will retain their high permission privileges. So now what all base permissions are provided normally? Repository creation. Members will be able to create only selected repository types. Outside collaborators can never create a repository. Now you are getting the difference between a member and an outside collaborator. I hope you are getting it. Okay. So repository creation, we gave permission for the private IP. Sorry, not private IP, private repository, not the public one. So then a repository forking. So at this moment, this permission is not given to this for the member. So if I want to give this privilege, let's click on check. Let's check the allow forking of private repository. Private repositories only for the members, and then we have to click on save. So then that option has been saved. Then after that, page creation. Members will be able to publish sites with only selected access control, that to only public one. So that you can do if you want to give private, but by base it is not there. Okay. Then integration access requests, it is checked in. Now admin repository permissions. Here repository visibility change. Allow members to change a repository visibility for their organization. Yes, members are allowed to see all the repositories in that organization, even though it is private. Okay, and then a repository deletion and transfer. Even we have given that access also. And issue deletion is also given. So member team permissions. Team creation rules allow members to create teams. Even we have given a member to create a team. So at this moment we can do that. If you check out that, then other member who is not the owner, uh, he cannot create the teams if I uncheck this option. Okay, so let me uncheck this option and click on save. So these are the permissions that the base permissions we have. And if you want to attach some permissions or privileges, you can do it by going to the settings of that organization. Then we will see let's create teams. So then let's create a team. Okay, teams are, again, as usual, it's a groups of organization members that you can create to reflect your company's hierarchy also. So let's do that. Let's create one team and we'll see. Okay, at this moment we have created an organization and we have invited the members, so out of which few members were accepted the invitation. One member had to accept the invitation. Okay, let me get back to Okay, let me click on your organizations, and I will enter into my organization. Yeah, here is my organization. You can see at this moment this consists of a main menu bar, overview, repositories, projects, packages, teams, people, and then settings. If you want to attach new permission rules, privileges to your member, you can do that from settings. But whereas at this moment we have three people, these are the three people, but teams, no teams, nothing, no team, not a single team. So now I'm gonna create two teams now. So total how many people we have? So we have three people. So this Cherry Rams is a DevOps guy, and Surya Charan Teja and Rahul, these are all absolutely AI guys, pure AI guys. These are all AI scientists. AI scientist, and this guy is a DevOps guy, and Surya Charan is AI scientist as well as MLOps guy. So what I will do, I'll create a DevOps MLOps team with Cherry Rams and Surya Charan Teja, and AI team with Rahul R and Surya Charan Teja. Okay, so let's get into the teams now. So to create a team from here, you can see that create team. What all you can do in this teams? Flexible repository access. You can, as admin, read all the uh, flexible levels of access can be available here, and then you can request to join other teams also, and team mentions. This is very important. This is very important to communicate with each other. Okay, that we are going to do anyway. So let me click on new team, and the team name first we will create ML ops. ML ops. ML ops team, or okay, other way around. We'll put it team ML ops. Okay. So description: this team is used to collaborate on ML ops tech. So let me make it visible. I don't want to make it secret. I want to make it visible, and then let me click on create team. So the team has been created. This is team MLOps, and this is information. So at this moment we have only one guy. Now I'm going to attach a one more person to this. Who is the MLOps guy? That is SU. This organization consists of Surya Charanteja, as here it is. And let me invite. That's it. Now two members in this team MLOps. You see that team name? We are inside the team MLOps page. Okay, this is team MLOps page. You can see first organization. This is organization name. Then after that team name, and this is the team page. Here you can see discussion page, members, teams. Inside that you can create a nested team. That's okay, and then a repositories. So in that we haven't added any repository. After some time we will add a repository. On that a repository, these two members can basically work on that. We will do, but for this moment, so let's get into the discussions. Okay, so we have two members in this team. So we have created one team. After some time we will create one more team. Okay, then we will look into managing team settings. You can for team settings, you can designate a team maintainer to manage team settings and discussions among other privileges. For to do that, again we will get into our GitHub organization, and then team MLOps Okay, we'll get into MLOps team. So now you can see that here what all roles we have. Everyone, we have maintainer and member. Let me click on maintainer. Surya Charan Teja is the maintainer at this moment. Okay, and member. Okay, sorry. That's my bad. That's my bad. Maintainer is Cherry Rams. We'll look into username only. Okay, and then member Surya Charan Teja. Okay, so that's it. We have two members, and then if you want to make this guy also a if you want to make him as a maintainer, you can attach a maintainer role and say change a role. So now we have two maintainers, this guy as well as other guys. Okay, so this is how we attach our privileges to our members inside the team. So now let's get into the discussions. Okay, so here the people or the members which are inside the team can collaborate about their project. They can discuss, they can keep their discussion. So let me start. Here, title, this is to, okay, this is test discussion. And leave a comment. This is our first comment at the rate of, I will ping Surya Charan Teja. Okay, let me change this. And let me comment it. So the first comment has been sent. So now let me get into the other account. This is my account. So let me see. Let me get into your organizations. This is that organization. Let me click on this and go to the teams because I'm inside the team. And where is that? Here is that. See, you can see that team MLOps. You see that? You see that? I been Cherry Rams. He has sent. This is our first comment and then to, pinging me. So now I will reply to that guy. Okay. Yep. I received your message or comment. Let me work accordingly. Okay, done. So I'll ping that guy now. Cherry Rams. Let me click on comment. Done. So now let me get back to this and see. Okay. So now let me get back to our Cherry Rams account and you can see that message. Okay, it was sent by other guy. So let me completely, so it was sent by the guy, same one. So let me completely log out and sign in to this Surya Charan Teja username account. Both were sent. Okay, that's fine. Now I have logged in. No thanks. Let me get into your organizations. Yeah, here is this organization and team 1 MLOps team, not MLOps, yeah, MLOps team, and click on this MLOps team. And here you see, now you got the blue, it's been turned as a yellow because somebody has pinged you. Somebody has pinged you. So this is our first comment. Of course, this is with the same account I have replied it. So I'm sorry for that. I thought I was in other account. That's okay. Now we are in, you see, this is Surya Charan Teja. It is not Cherry Rams. Okay. So now from here I am gonna reply to other guy. So what I will say is, okay, well noted. We will work accordingly. And I would say at the rate of Cherry Rams. And then also at the rate of complete organization. So that it will, sorry, complete team. It will go to the everybody. Okay. Now let me comment on this. So this comment has been sent. Now I have to get back to the other organization. For that I have to sign out from here first. Then sign in back to the other account. That is cherry rams 127 at the rate of gmail.com. And okay, so now again let's get back to our see, now you can see that this is a different account, cherry rams account. So here I will click on your organization, and let me click on this first organization. We have teams, one team. I'll go into the team MLOps. And here is the message from Surya Charan Teja that well noted, we will work accordingly. And he tagged me, he pinged me. That's the reason it was marked with yellow color. And he has pinged all the members of MLOps team also. So this is how we can keep the discussions inside the team members within each other, so that we can progress about the project very well. We can collaborate regarding the project very, very damn well. Then we will look into managing and basically security and setting organization level policies. So to keep your organization secure, you can use a variety of GitHub security features, including security policies, dependency graphs, secret scanning, and and dependent security and version updates. So, and then managing organization policies. You can manage permissions and policies for a member of different actions and features in your organization. For example, to protect your organization's data, you can restrict repository creation in your organization. You can also choose to allow or prevent the forking of private repositories owned by your organization. So these are basically security and security level policies of an organization. For that, to see that, we have to get back into our security organization. Now we are inside the team. So let me go to organization. Yeah, now we are inside our organization. That is my DevOps org. So now let me go to the settings. And inside that settings, you can see billing and plans, repository roles. Here you can find the repository roles. You can give either only read access or write access or maintain access, or you can give the complete admin access to that guy for the repository. If you want to demonstrate this, we have to create at least one repository in that organization. Okay, we will create one repo in that, and then let's see. Yeah, click on repository, create new repository, and name org organization repo, and description. This is to check the this is to test the security policies and repository level access to the members of the organization, and then make it do you want make it public, or if we'll make it private, then only we can go through that all other things. So add a readme file and then create a repository inside the organization. This is not uh, this is not account level repository. This is organization level repository. So the repository has been created. Now let's go to the settings of the repository, not the organization settings. Don't be confused. Okay, don't be confused. Now we are in the repository level page, repository level settings, repository page. We are in the repository page. Okay, code, issues, pull requests, actions. These are called GitHub actions. This is used in continuous integration. Okay, projects. This is basically secure, basically repository level settings. Okay, now here you can see branches, tags, actions, GitHub apps, and then collaborators and teams. Now here you can manage access. So it's private repository. Who has access? It's a private repository. Only those who access to this repository can view it. That's it. All three members can access this repository, and 0 teams or 0 members have access to this repository. At this moment, only 3 members can access this repository, nobody else. Now you can manage access by clicking. So you haven't added any teams or people. So if you want to add some members, you click on add people. So I will click on anyone randomly. I'll give some email. Divya. I type Divya. I like that name. So Divya ran. I do not know this girl, but I'm just giving. So now it is asking what kind of access, which role you want to give to this girl. I will give only read permission to this girl. Recommend for non-code contributors who want to view or discuss your project. What the girl will do is she will read it. She'll view that file, and if she want to suggest any changes or additions to that source code, she can suggest. For that purpose, we'll give the read. I will add this girl to this repository. Done. Okay. So next, one more collaborator. This time I will add Chaitanya Gedela. He is the business analyst. He is the EA project consultant in Volvo. Okay. Okay. Gedela. Oh, sorry. That's my mistake. Add pupil. Chaitanya. Just a minute. Yes. Chaitanya. Yeah, here it is. This guy. Okay. I've added this guy. Yeah, Chaitanya Vedula. Okay, sorry. So now for this guy, I will give recommend, or I'll give tries. What is tries? Recommended for the contributors who need to manage issues and pull requests without a write access. Okay, for that I will give. Okay, done. So next I will add one more person. This time it is Daksha. Daksha. Okay, I will give right. I want this guy to add to contribute in writing something in my code, send pushing modules into my code only for this repository, not in my account, not in the organization, not inside the team. Only for this repository I would like that guy to add some modules into my piece of code. Okay, this role is also done. So now I will add one more. This time it is Pooja. So for Pooja, I will give recommended for project managers who need to manage the repository without access to sensitive or destructive actions. I am giving permissions to maintain my repository. Then finally, I'll make Rahul R97, this guy, as an admin to this project. So admin, so what admin? I'll attach him as an admin role. So recommended for people who need full access to this project or to this repository, including sensitive and destructive actions like managing security or declaring a repository. That's it. So this is how we attach a roles. We attach a roles to different pupils. For that we have to invite them. So then once they accept the invitation, so then they can read, write and trace and maintain our repository. These are repository level access, repository level privileges, repository level permissions. So now let me get back into our organization. Okay, this is our organization, not in the repo. So here I will click on settings, and we have seen the repository roles. Now member privileges we have seen before, teams discussion we have seen before, and then here GitHub actions, GitHub actions, webhook we are going to see in Jenkins. While we are dealing with Jenkins, that time we are going to see, and packages, pages, project authentication, security, GitHub personal access tokens, code security and analysis. And okay, let me click on general settings. So in general settings, you can customize your profile. Okay, this is what the security level settings of our GitHub organization and GitHub teams and GitHub team level repositories. So repository can be created in your GitHub account, that is GitHub account level repository. The first repository, I will show that. When you go to your repository, these two repositories are account level repositories. Okay. Then we have created a repository. So now we can create a repository in this organization also. So I just click on repository and then type something and create a repository here. That's called organization level repository. Whereas we have created a team level repository also. This is team level repository. You got it? This is team level repository. So organization level repository, team level repository, and account level repository. So this is huge. We have discussed a lot about GitHub organization, teams and permissions, and repository level roles. Let's deep dive into organizations. So you can use organizations to collaborate with an unlimited number of people across many projects at once. So while managing access to your data and customizing settings. So to perform any actions on GitHub, such as creating a pull request in a repository or changing an organization's billing settings, a person must have sufficient access to relevant account or resource. So this access is controlled by permissions. A permission is the ability to perform a specific action. For example, the ability to delete an issue is a permission. A role is a set of permissions you can assign to individuals or teams. A role is a set of permissions, or role is nothing but a set of permissions that you can assign to individuals or teams. So we have seen repository level roles, not just seen, we have demonstrated repository level roles in our previous example. You just go and watch the previous session. So repository level roles give organization members, outside collaborators, and teams of people varying levels of access to repository. So team level roles. So repository level roles we have seen. Now team level roles. Team level roles are roles that give permissions to manage a team. You can give the any individual member of a team the team maintainer role. We have seen, we have demonstrated this also, which gives the member a number of administrative permissions over a team. Then we have organization level roles. Organization level roles are sets of permissions that can be assigned to individuals or teams to manage an organization and the organization's repositories, teams, and settings. So let's look into organization roles. So roles in an organization. Organization owners can assign roles to individuals and teams, giving them a different sets of permissions in the organization. So you can assign individuals or teams to a variety of organization level roles to control your members. So access to your organization and its resources. So let's begin with organization owners. So organization owners have complete administrative access to your organization. This role should be limited, but this role should be limited, but to no less than two people. So in any organization, only maximum two people can be given organization owner role. And let's see. Let's look into this organization owner role. So now we will get into our organization from drop down profile drop down menu, and let me click my organization. So in this I'll go to the members people. So total 3 people are there, and let me click on members. Yeah. Now I will filter out owners. We'll see only one owner. At this moment only one owner. So this guy is a owner. You can see that is a owner. He is a owner of the organization. We have filtered and he is the owner of the organization. And let me take out the filter and put everyone back. Okay. You can even here you can see the first guy is owner of the team and other two are the members of the team. Okay, let me get back to the slide again. Then we have organization members. The default non-administrative role for people in an organization is the organization member. By default, the organization members have a number of permissions, including the ability to create repositories and project boards. Let me get into this is organization member. So here you can see these two are the organization member, and let me filter it the member only members. You can see that these two people are the organization members, and we have seen the settings of organization members, and I'll go to the member privileges. I have shown you all those things, but one more time I'm seeing here you can attach the rules to that, attach the security rules for these members. These are called member privileges. Okay, you will have a base permissions, and on top of that you can attach the more permissions to that organization member from base permission. So you can click on read, write, admin. These are the base permissions. Whether you want to give, or else no permission only, whether you want to give read permission of all repositories or write permission to all repository or admin permission to all repository, this where you will get it. These are the base permission of the member, and after that repository creation permission, repository forking permission, page creation permission, integration access request, admin repository permission, issue deletion, so member team permissions. All these permissions are available. You can customize the member privileges. You can customize the member permissions. At this moment, it's read. I will put him as admin. No, change base permission to admin. Yes, absolutely. I want to change that. To whom? I change. All members, all members, not for, you don't do that, you don't do that normally. I'm just to demonstrate, I'm just doing that, that's it, nothing else. You don't do that, never allow that. Okay, and we have a pending collaborators. Okay, these are the collaborators that we have chosen. Okay, that's fine. Now let us get back to our slide again. That's all about the organization members. Then we have organization moderators. So moderators are organization members who, in addition to their permissions as members, are allowed to block and unblock non-member contributors, set interaction limits, and hide comments in public repositories owned by the organization. So these are the activities of the organization member. And finally, we have the billing members. So billing managers are users who can manage the billing settings for your organization, such as payment information. So this is a useful option if members of your organization don't usually have access to billing resources. So here I cannot demonstrate this billing option because that billing manager role we won't get it here. You can see we have only owners and members because this is completely free account. If you if you go to administrative or enterprise level, team level or enterprise level organization, it you can get that billing manager role also, but at this moment it's a free account, you won't get it. So now let's look into teams again one more time. We have seen it, but we will dig deep into the teams also. Teams are groups of organization members that reflect your company or company's structure with cascading access permissions and mentions. So organization owners and team maintainers can give teams admin, read, or write access to organization repositories. So organization members can send a notification to an entire team by mentioning the team's name. That's it. That this exercise we have done it in our previous session. So organization members can also send a notification to an entire team by requesting a review from that team. So let us get into that, and I'll show you one more time so that it will be much clearer. So I'm here. I'll get into the teams first. Okay, I'm in the teams. Let me find out. Yeah, this is my MLOps team. I haven't created a one more team. I'm gonna do that in a while. So now here is the members. These are the two members present in this, and I'll click on the discussions. Here in discussions, if I say at the rate of a team name, so it will ping all the members of the team. And then if I say just username of that account, that member, then it will only ping that guy. Who is that? That whoever the username belongs to, whomsoever. Okay, this is what an example. If you want to write one more, now I am a who am I? Cherry Rams. Okay, now I will request for a preview or review, whatever it may be. So you just click on preview. So nothing to preview there. That's okay. They have to do that. Okay, I will write a message to team, whole team, at the rate of either to only this guy or Rahul Ramesh or Cherry Rams. I will write entire team to entire team. Congrats for all the success that we had. So it's absolutely party time. Party time. Party time. It's party time. Yeah, team has been pinged. So that's how. So we request team and then individual members. So organization members can request reviews from a specific teams with a read access to the repositories where the pull request is opened. So teams can be designated as owners of certain types or areas of a code in code owners file. Then we have team visibility. Teams can be visible or secret. So visible teams can be viewed and you can mention them using at the rate of mentioned using this. If you mention at the rate of and mention the team name, we can mention them using that. Okay. And secret teams, we have seen when we were creating a teams, you will have two options, visible and secret. When you select a secret team, it will become a secret team. So secret teams are only visible to the people with owner permissions. So they are great for hiding teams with sensitive names or members, such as those used. You can view all the teams you belong to on your personal dashboard. So then let's look into the team page. Team page, I will show you, but we'll look into the team page first. So each team has its own page with an organization. On a teams page, you can view team members, child teams, and the team's repositories. So organization owners and team maintainers can access team settings and update the team's description and profile picture from the teams page. So now it's time to get into the teams page. So this, okay, where are we now? First, let me get into the organization and we'll do it step by step. Your organization, this is my organization, this is our organization. So now we are in organization page, that is my DevOps org. We are in organization page. Now let me click on teams. So now we have entered into the teams page. You see that? You see that? This is our, oh sorry, my bad. We are still in my DevOps organization page. So now let me click on team MLOps. Then once it opens, now we have entered into the teams page. Okay, this is our teams page. This teams page consists of discussions, members and teams, child teams, repositories and projects, and settings. Settings can only be accessed by the owners, not everybody. Okay, now let me, so these are the members, and if you see here, the team name was mentioned on which team we are. This is called the child, this is called teams page. Now if you want to edit, go to the settings, and these are the general settings. Here you can find upload a picture, upload a new picture. Okay, I'll go to the like my YouTube repo, blog posts, page development, and here is images. I'll select this one. We are uploading the team's profile pic. team's profile pic. It's not organization, it's team's profile pic. It's neither organizations nor accounts. It is team's profile pic. Okay. So from here you do that. Then after that you have to do the save changes. You may also drag and drop. There was some uh, I think issue with which format is that? Please upload a picture smaller than 1 MB. I don't think I have that. Okay, let me put this my logo. Yeah, it's getting uploaded. Okay, some part. Yeah, whichever it may be. Let me select AI only. Only AI. Now again, same. But it should be less than 1 MB. That's fine. Okay, it's not a big deal now. So here you can do the setting changes, basic setting changes. Okay. Here that's what I'm saying. Team visibility that we have discussed just few minutes before. Teams visibility. One, either you can go for the visible or else you can go for the secret. So now I have changed it to secret and then I have save change. I have done the save change. Yes, image got uploaded. So this is how you can customize your team using the settings option. But this settings option will be can be accessed only by owner of the team, not by the member of the team. Okay, so that's what the team page is. So now let's look into the complicated concept of teams, that is nested teams. So nested teams, you can reflect your group or company's hierarchy within your GitHub organization with multiple levels of nested teams. A parent team can have multiple child teams, which each child team only has one parent team. So you cannot nest secret teams. That's the most important point. You cannot nest secret teams. All teams should be visible, because if the team is secret, then how can you nest it? So child teams inherit the parents' access permissions, simplifying permissions management for large groups. So members of child teams also receive notifications when the parent team is mentioned at the rate of mentioned. If you use a at the rate of, and if you mention the parent team, all the child teams in that parent team will get the notification. So simplifying the communication with multiple groups of people. Now let's take one example. So if you structure your company, let's structure my company like this. It has a 40 teams in the MLAC organization. So it begins with the employees in a top level, and then after that, in that employee we have engineering team. Basically it's a product engineering team. Then inside the product engineering team we have a, so basically product engineering team can be further divided into, normal employees will be there, employees, some related to technical, some related to commercials, sales team, marketing team, brand team, and design team, simulation team. So what now we are only taking technical team who works on automobile designing product. Okay, so in that team product engineering will have a sub team, that's a design engineering. And after the design engineering we will have a application engineering. And then after that team we'll have a finally validation engineering, and then data science, and then data science and engineering. Basically these are the teams. These are all child teams of employees parent team, product engineering, design engineering, application engineering, validation engineering, data science and engineering. All these are child teams of employee team. And design engineering is a child team for product engineering, application engineering is a child team for the design engineering, validation engineering is a child team for the application engineering, data science and engineering is child team for the validation engineering. So now let's demonstrate this hierarchy management in Git Hub, not Git, in GitHub. Okay, so let me get into GitHub. So click on your organizations, and I'm going to create a new organization, and I will go for the free organization, and organization name would be iDevOps for you employees. iDevOps for you employees. That's the parent organization. That's our sorry. I'm sorry. So iDevOps Corp, iDevOps Corporation is our organization name. This is our organization name. This is like our company. And email I'm gonna give is cherryrams127@gmail.com, and then this is absolutely personal account. And then I'll click on, and then I'll click on similar one. I hereby accept the terms of service. So our organization has been created, and let me give Rahul Ramesh 97, correct? Yep. Then Surya Charan Teja. Only one guy is there in this earth with this name. That's me. Then Jansi Volvo. Then Chaitanya Gedila 327. Yeah, this one. Chaitanya 327. So let me complete the setup. So this is our new organization. Okay. Let me go to the your organizations and see how many organizations we have. So we have two organizations. One is first organization. Second one is iDevOps for you corporation. This is specifically to simulate the nested teams exercise. Okay. So here is our organization. This is organization level page. So now let me click on teams in this. Okay. Now let us create our first team. Okay. What is our first team? Our first team is employees. Employees is our first team, and here we'll say all 50,000 employees of iDevOps for you corporation are part of this team. I think you got it. And the team visibility should be visible only. So there are no teams that can be selected. There is no parent team here. So this itself is a parent team. So now let me create the team. So this is employees team. Okay, it has one member. That's Cherry Rams. That's it. Now in this now where I'm in employees team. You see on the screen on left. Let me zoom it more. Is it enough? No, I think this is enough. Now if you see, this is the organization name and this is the team name, employees. Okay, now I am in employees team page, and you see that here is that description that I have given. Now let me click on teams again, and I will create a sub team, a child team in employees. So this is product engineering team. The name is product engineering team. Here all 21,000. Okay, I'll give 11,000. That's it. 11,000 product engineers belong to this team, and as usual it's visible and create team. So now we are inside the product engineering team. Okay, ID 4Y Corporation is our organization. That's the, and employees is our parent team, and then product engineering is our child team. If you see that on top menu bar on left side. So in this, let me create one more team. So team name I'm gonna give is design engineering. Design engineering. So, and all design engineers work in this team. Then it's visible again. I'll keep it visible. And now if you see, this is our organization, and here employees is our parent team, product engineering child team, then design engineering is the child of the product engineering team. Now you can see that hierarchy. You can see the hierarchy here, parent, child, child. Then let me, now we are inside the design engineering team team page. So let me create one more team inside the design engineering. The team name is application engineering. So add this. So all application engineers work with this team, work in this team. And now if you see here, this parent team option, how many parent teams are available at this moment? You have employees, product engineering, design engineering. Of course, we want in design engineering only. Let me create this. Now I'll show the hierarchy one more time. Employees, product engineering, design engineering, and now we are inside the application engineering. So employees is the parent, and product, design, application engineering are the childs of employees. The two grand childs, not directly. Then we will create one more team, that is validation engineering. So add a team. I'll say validation engineering. Team has been added. So description, all the validation engineers, and parent team is application engineering I want, and create a team. So now I'll cross check again. Employees, product engineering, design engineering, application engineering. So now validation engineering, we are inside the validation engineering page. So now let me click on teams in this and add a team, and the last team that we have is data science engineering data science team. Engineering data science team. So all AI scientists and data scientists are here, and parent team is validation engineering. Team visibility is visible, and let me create it, and we'll see the complete hierarchy of this. Okay, that's it. How many teams? Let me get back here. Product, employee is the parent, and then all other, our child, grandchild, grandchilds. Okay, employees, product engineering, design, application, validation, data science engineering. And here you see now employees is the parent, then grandchild, product engineer, sorry, child, product engineering is child, design engineering, then application engineering, and validation engineering, and engineering data science. All the teams in a parent child concept or parent-child hierarchy. So that's how you can nest your teams. So before we wrap up the GitHub tool, what will we do is, before we wrap up the session on GitHub tool, let's go through the GitHub once. So GitHub user interface. Okay. So let me get to the main page. Uh, that's okay. We'll leave it like this. So this mm, yeah, this is the main page, a landing page. Now if you see here, you will have a GitHub logo. Then on top, on the main menu, you will find pull requests, issues, code spaces, and marketplace. And then on rightmost, you find a notification bar. So when somebody requests to join their team, so in that time you will get a notification here. And this plus button is very important. Plus drop down bar, drop down menu is very important. From here you can create new repository, import repository, new code space, new gist, new organization, new project. Any of this activity can be done from this plus drop down bar. Then after that, we have been using this for so long. That is profile drop down menu. Here you can find who is logged into the, whose account is that, and if you click on your profile, you can see this page what we are seeing. And here if you click on your repositories, you can find all your repositories. If you click on your organizations, you will find all your organizations. If you click on your projects, you will find all your projects that you are working on in your account, as well as in somebody's account, your stars, your gists, and your sponsors. And finally here you will find settings of your account, and then this is sign out and log into the new one. When we click on settings, this is very important when we working with the Jenkins. That's the reason I want to show it now only. So this here you can edit your image and all those things you can do from here. That's absolutely fine. But the most important aspect for us here is uh, SSH and GPG keys. So security and password and authentication. These two things are very important for us. When you click on password and authentication, here you can change your password. And whereas if you click on SSH and GPG keys, basically when you want to connect, when you want to clone or private repository into the Linux machine, it's impossible. So what you have to do is you have to use a SSH key. You have to create a new SSH key. Basically, in that this exercise we are going to do anyway, but I'm just giving a broad explanation before going there. Okay, you have to enter into the Linux machine and you have to create your SSH key. And then once you get the SSH key, you have to copy one part of the key to here and paste it here. That should look like this. And then you name it, and then you add that SSH key. Now that secure connection has been established between this GitHub account and to your Linux machine. Then after that, if you want to clone, you can clone it. Or if you want to do any action which connects the local repository of Linux machine with the remote repository inside the GitHub, all can be securely done. So that's the reason we can go with the secure SSH or GPG keys. Whichever is, both are fine, both are good. Either you can go with the GPG key or SSH key. And after that, you have sign out. This is all about. And once you click on your repositories, you can find all your repositories page. This is uh, account level repositories. Okay. Then go to your organizations. You will find all your organizations and settings related to your organizations. And even at the organization level, you have SSH and GPG keys and password and authentication. Then your projects, at this moment we have not have any projects here. So if you want to create, you can create your projects. Okay, just click on create your project and you can start working on that. Then your stars, your gists, and your sponsors. So this is broadly a simple explanation about the user interface of our Git Hub. So let's, before we wind up, let's look into the summary of GitHub. We have begin with the introduction of GitHub. What is GitHub? Then we have looked into we have done the GitHub configuration. Then we have seen the vocabulary of GitHub with the practical demonstration of each term, such as repository, creating a repository, cloning a repository, forking a repository, and using GitHub discussions. Then we entered into the teaming up in GitHub using organization. So we have created our first organization. In that we have created our first team. Then in that we have invited a lot, three members into that team, into that organization, and we have attached two members into the team that we have created. Then we have done the team. We have managed the team settings, and we have managed security and setting organization level policies. Then we have moved into, we have dwelled a little bit deep into GitHub organizations. In that we have seen what are different types of roles in an organization, what is a role, what is a permission, and what all different roles available. So this we have seen. And in addition to that, we have seen the repository level roles, organization level roles, and team level roles, and various privileges or permissions that are attached to the each role, and how can we change those roles, and how can you attach the new roles to that. Then finally, we have moved into the GitHub teams in depth. So we have seen the team visibility, team pages, and the nested teams. We have finally demonstrated nested teams exercise. So far in Git and GitHub, we have seen Git architecture and the way to work in a local repository by converting a current working directory into Git directory or Git working directory, then creating some files inside the current working directory, and adding these files into the index, and then committing these files into the local repository. So local repository. So that means we know how to work in our local repository, which is inside our local machine. So now after that, once that is done, then we jumped into the GitHub. So then we have created some repositories there. Then we have created organization teams, and then inside that a repository we have added the files, and we have changed the files. So we know how to work on a remote repository also. So now it is time to bring up together. So bring both together from local. It's time to connect a local a local repository to the remote repository. So how we are going to connect? If you are excited to know about this, just brace yourself for the complete full level action. So how Git and GitHub collaborate? So a collaboration between a local machine, GitHub makes a lot of fantastic things possible that we are going to see now. So before we begin, one thing I want to make sure that when we say master branch, it doesn't mean you will have a master branch and then slave branch, master slave concept. No, a big no. There is no master slave concept. There is a master version concept. A master will have, it could be a master branch or it could be main branch. It is, you can change it to any name. I'll show it. So git, so let me clear the screen. If you see, this is our master branch. If you want to see clearly, I'll show it. Sorry. Okay, where I am. why not dot git? Okay, it's there. Cat git head. You see, this is master branch. At this moment, the branch name is master. Now I will save it as a slave, just for fun, nothing else. You can do, you can put any, you can give any name to that. It doesn't matter. It has become a slave. See now, it has become a slave. I'll make it that too as a Krishna slave or Krishna. You see, it became a Krishna. Now I'll make it Shiva. These are all our historical figures of India. Shiva. So you see that it's Shiva now. That's what I'm saying. There is no master. It doesn't, when you say master means it will have some functionality. No, not at all. It's just for reference purpose. Either you can call it master or main branch. It doesn't matter. Okay. There is no master slave kind of concept. Then the master branch only exist locally, and the master branch which is there in the remote repository is different, and this is different. They are not same, though the name is same. They are not same until unless you do some pull fetch or commit push. Until unless you do these things and make them same, they are never same, although their names are same. So let's take this example and we'll see. My first question is, we will see you have a remote repository and you have a local repository. Are they connected? Will they be connected? If they are connected, if they will be connected, how will you connect them? That's my question. Okay. Until unless there is no connection between a local repository and a remote repository, you cannot do anything. So how it is possible now? So let's demonstrate that example now. So for that, what we are going to do is, we will create a local repository, and similarly we'll create a remote repository. Local repository, we will commit 3 commits, and similarly in a remote repository also we will commit 3 commits. Then we will see whether they are same or not. If they are not same, how to connect them? Because they are not connected, that's the reason they are not same. Then how to connect them? That's the next question, obviously. So how to connect them? So that we will see now. Okay, let me get into Git bash here. I'll keep on this side only so that you can see the figure. Let me clear the screen and then make it a little bigger. Now this much of is enough. CD, I'll come out ls, again CD, I'll come out ls. Now I will say this exercise name is mkdir git GitHub collab. Then cd git GitHub collab. So now see, there is nothing inside that directory. So now what I'm gonna do is, first we will initialize a local repository. Okay, then after that, first we will do all the settings in a local repository, because we are presently in our local machine. So I will do git initialization. Okay, you want to check ls option A also? Yeah, there is nothing, no git. Now I am gonna initialize git. So git initialization is done. Now you can check. Yes, dot git, and the branch name is master. Okay, branch name is master. Now let's start our commits. As usual, Here in local repository, we are going to put programming files as usual. I would say touch mod.py, git add dot git commit and message and yeah, done. Now let's give git log graph decorate all. Okay, your commit A is ready. Then touch template dot packer git add git commit message b. So we got the two commits. Now let us tag both the commits. Okay, we'll commit all at a time. That's fine. Then what we have, okay, one more file. This time touch index.html git add, then git commit message and it is c. Done. So now let's add tags. Let's tag all these commits. So git tag option a and it's capital A. Okay, capital A is this, right? Yes. See, then after that what we have, M, and again we'll put capital A. Git tag. Okay, let me B. Here it is. Let me scroll a bit up. Okay, rest all same. Then third one. Third is this. Yeah. Then C. So all done. A, B, C. Presently it is pointing at the master of local repository. So this is local repository. Done. So our local repository is done. See, you see, taxi master is a taxi. This is the recent commit. So now let us get into our remote repository. You see that? You see here? This is our remote repo. Let me get into the remote repo. So this is our GitHub account. Let me click here and click on your repositories. After your repositories, let me click on new repositories. So in new repository, I'm gonna name it as the same name that I have given here. What's that name? Where it is here. The name is GitHub collab. I would say GitHub collab. So same name. Now this is to experiment and prove the Git and GitHub collaboration. Done. Let me keep it public. So add a readme file. No, not required. We will add other files. We will add our own files. Create a repository. Done. So now Okay, copy this and put it in sticky note. Okay, so let's start committing codes here. Let's create a new file. So file name here we will use article.word file. Done. Let me commit the changes. So commit, here we are going to give the same commit messages, yeah, and click done. Article.word, and you can see that. And let us add one more file. So add file here, business.ppt, sample business ppt template. So let me commit this also. I would call b the commit message and commit it. Then let's create one more file and commit that file also, and this time it is .png, image.png. This is sample image. So commit, oh no, okay, commit with it's been committed without a message. That's okay. So you have three files here. This is remote repo. Let me put side by side. And then you see that this is a local repo and this is a remote repo. I'll click on view code. Yeah. So these three files are here, and sorry, that's the wrong place. Clear LSL. Three files are here. And three files are here. You see here, index mod template article business.ppt. Now my question comes, the same question I will ask again. There is nothing much difference in question. Remote repo with three commits, local repo with three commits. Now how will you connect these two? One is remote, it's somewhere in the GitHub. You do not know on which server your files has been stored. And you have three files in your local machine, that my local machine. So how can I connect these two? Answer my question. How can we connect these two? How can we? Let me connect it and show. So get back to this. So as it says, you have two options. You can add remote repositories with the git remote add command. Okay, let's use git remote add command to add remote repository with local repository. Let me bring up. So this is the I'll keep it here. I'll type, okay, this is master and that is main branch name. You see, this is master branch and this one is main. That's what I was saying. Master doesn't mean it's master, it's slave. No, it's just for namesake. Master and main. That's it. You can say base, base code, source code, uh, prime branch, origin branch, whatever you want. So here I will change the name first. Git branch I would say main. Sorry, that's my fault. So now it's become main. So now this is main and this is also main. So now I have to make the connection between remote repository of this one and remote repository this one and local repository this one. So let us make that connection using git remote add and alias name, the pet name or sweet name or cute name that you want to call the remote repo. What is it? Do you want to give any specific name? If you don't want to give any specific name, you can by default you can take origin, okay, because that's where it comes. Then bring up the http URL and paste it here. So now it's time to execute. So I hope the connection had been made. The connection had been made. So what will we do now is, let me check. Git status, nothing to commit, working tree clean. Now let's use git log graph decorate list and see what it's gonna show. So you see that as usual you have 3 commits. We have just established a connection between local and remote repository, but nothing we have done till now. Neither we pushed nor we pulled. Because if you see here you have 3 files, and if you see the remote repo you have 3 files. This is article. These are word, ppt, png file. These are html, python, packer files. There is no connection at all. Now how to make the connection? Okay, so we have made a connection, but how to integrate from one to another, that we will see in our next slide. So this one we have proved it. So how to make a connection between remote repository and local repository? So that has been done. Now when you check out a branch that only exists as a remote tracking branch but not as a local branch, Git automatically creates the local branch from the remote tracking branch and checks this one out. Let's see the infographic now. So you have a remote repository on left, local repository on right. So as usual, 3 commits on left we have done it, and 3 commits on right we have done it. So that's a local repository. Now first, before I push all my code into remote repository, what I have to do is I have to fetch whatever is there inside the remote repo. Once I integrate all the files which are there inside the remote repo into my local repo, then only I can push into the remote repo. So that's what I can do. But how can I get all the files which are there inside the remote repo? That's my question. That is using fetch, the command, using the fetch command. Got it here? So once you have that, you can merge the contents of the remote branch into your own branch. So you can see that in this figure, this checks out into the local master branch, but that does not basically main. We have changed into a main now. So but that does not need to be the case. So you can merge it into another branch with a common history. That's okay. That's all fine. Okay, that we'll see that the checkout, that we will see that. But for now, we have to fetch from here. How can we do that? What do you want to do? Let's do fetch and merge, or directly pull. Which is better for you? Let's go with the, you know that, did you remember fetch plus pull is nothing but fetch it and merge it. So in spite of fetching and merging, let's use a pull directly. So git pull, I'd say origin, because that's the alias we have given. Origin, that's more than enough. So now we are pulling, basically we are pulling, but what's the issue here? Okay, enumerating objects 9 done, all done, but it's showing some issues. No, that's not the issues. Let me clear the screen before I pull and integrate remote repository with the local repository. Let me clear the screen first. Yes, now it's time to give git pull and space and URL. Copy and paste. Let's execute it. Here it is, git pull remote. It has pulled all the files from there and branch head, and it became a fetch head. Okay, so let us check the files now. ls, okay, here it is. You got business.ppt, index.html. So let's continue with our exercise. So now so we have to, so once completely we pulled all the data from remote repo into local repo, now it's time to check out to the new version. So new branch, let's create new branch and we'll check out to the new branch, and then we will see how many files has been transferred to the new branch. Okay, so we'll continue the same exercise. It's here. So let me check list. You can see all the files are there. Of course, all the files are there. Now let me give git branch and branch name version 1. So let me check. So branch has been created. You can check the git log, of course, that's fine. So branch has been created. Now let me check out git checkout version 1. Now you see that if you see version 1, you will find all the files. ls. So even in version 1, all the files has been pushed. So now let me check the head cat git head. You see head is pointing towards version 1, and you see here version 1. So now in version 1, we are in version 1 repo, local repo, in version 1 branch. You see all the files. That means all the commits has been, even from the remote repo and a local repo of the main branch, everything has been transferred to the version 1, and then head is pointing towards the version 1 also. So with this, we have done with this exercise. Git fetch is shown. So what it does, so it updates the remote tracking branch. So then you just do a normal merge operation between the remote tracking branch and the local branch. So the example that you see on the screen, so remote repository has 4 commits and the master branch, and local repository also has to fetch all these 4 commits. So once you do the fetch, you're going to get all those data that was committed using 4 commits in the remote repo in the master branch. So and after that, if you use a branch, and so the same exercise we have done it previously. So now here what we are going to discuss is the various commands that we have used in that exercise. It's like a summary. It's like summary of the previous exercise, because if that is clear, then we will go to the next exercise. Okay, so git clone, we have used it not in previous exercise but in a different exercise. Then git remote add, that adds a remote repository with the given connection URL. Then git fetch fetches changes to the remote tracking branch from the remote repository. Then git pull, so we have done it. So maximum all these commands we have used it. The difference between a fetch and pull is the git pull command is a convenient command that combines fetch with the merge. And finally git push, this exercise, the push exercise, we haven't done. So next we are going to do that. Yeah, so now here pushing a change to remote repository. So push also allows you to create new branches in the remote repository, but that's not the point of matter here. The point of fact here is to push a data from local repository to remote repository. Okay, so let's do that. Let's take, this is our local repository with master branch and then feature 1 branch. And then from the feature 1 branch, we will merge all data into master branch. Then once feature 1 branch data has been merged into master branch, then we will push everything back into the remote repository. So you see that complete data that was in local repository should be pushed into the remote repository. That is the that's the exercise here. It's literally what we are doing. We are connecting or making a connection between local repo with the remote repo, and we are using Git and GitHub with our local machine, so collaboratively to store and version our files. Okay, let me get into the exercise. So this is the GitHub. Let me go to your repositories, then create a new repository, that is GitHub, and push exercise. So we are gonna experiment git push command. So I'll make it public. So I'll create a repository. So our repository has been created. Now let me copy this and paste it in. Now let me create a first file in it. So I would say test.txt, and this is the first file in this repo, and I'm gonna commit it. this is the first commit in this remote repo, and commit this file. Done. So let me take this URL. So now let me get back ls. Let me create a directory mkdir git and github collab push cd git github and collab and push ls. Nothing is there. Now let me clone the same remote repository that we have just created and added a file. Let me clone it first. So now I'm cloning it. So it's been cloned. Let me check. Yes. Let me enter into that git ls. Yes, test.txt. Let me make it smaller. So on left and right window, you can see that. I'll click on code here and let me clear the screen and show it to you very clearly. Now ls lr, you see that test.txt and test.txt. Done. Till now all fine. Now what will we do is we will create a file, not one file, 2-3 files we'll create. We'll do it 2 to 3 times. Then we will push it to the remote repository. So that's what our motto right here. You see, from local repo we want to push it into the master branch of remote repo. Of course, that's the main branch. Remote repo is main branch, and local also at this moment it's a main branch only. Just consider this as a main branch. Okay. Now let me, oh, where is that? Yeah. So let's create a file first. Touch mod for .python ls. You see, total 4 files has been created, but here not even a single file. You have only one file. I'll just refresh it and I'll show it to you. Still only one file. You see that? Only one file, because though there is a connection between local repo and remote repo. You see, here you can see the local repo of the main branch on right side. Let me make it. Yeah. Here you can see the local repo of the main branch. Here you can see the remote repo of a main branch. Though I have done modifications here in the local repo, but nothing has been visible. Sorry, in the current working directory, nothing has been visible, because we have to add these files, the changes, into the staging area, and after that we have to commit into the local repo. Then we have to push it into the remote repo. So then only it can be reflected in remote repo. Let's do that. So let me do git add. So all files has been added. Now let me commit, git commit. This is the first commit from the local repo. So commit has been done. Total mod 1, mod 2, mod 3, mod 4. 4 files has been committed into the local repo. Now it's time to push it across the globe. Sorry. Of course, I'm saying across the globe because my machine is in India and GitHub server might be in America. So when I'm pushing my files from my local machine from Bengaluru, it will go to the America. So I'm right. I'm pushing across the globe. I hope you got my point. That's okay, just for fun. Yeah. Now let's get back into the tutorial. So let's push git push u and then origin and branch main. Congrats. It's been pushed. So enumerating objects, 4 done. Total how many projects? Sorry, how many objects? 4 objects. Counting objects, 4 by 4. Oh, just a minute. Yeah, 4 by 4. Compressed. After that compression started up to 16 threads. Then all the objects has been compressed. Then it's been writing into the remote repo. Writing into the remote repo. Writing objects into the remote repo. And then total 3. So to whom? To HTTP. So this is the remote repository URL. Then with this commit ID from main branch local to the remote main, from branch main to the remote origin main has been pushed. Okay. So let's refresh this and see what is going to happen. Let me click on view code. That's the magic. Got it? So let me clear the screen on and say ls. You see that you have 5 files. You have 5 files. 5 files, 5 files. Okay, let me do. Let me add few more files. This time I will add touch index dot html, git add, git commit, m option and message. This is the second commit, and it is html file. Then let us push it now. Git push u and origin. That's it. It's done. Let's refresh it and see. Here it is. Here it is. Index.html. Okay. So now let's create touch template styles.css. Okay. Styles.css, git add, and git commit m option. This I'm committing css style rules, and this is the third commit. Done. Again git push u origin, and let me refresh it and see the magic. Here it is, index and styles.css. So now let's add touch function 129 dot java js. So git add function js, all of javascript has been added. Git commit option m, committing all the java files. Now let me use git push origin. That's it. Done. And view code. Here it is. Complete. You see that? JavaScript modules, CSS, HTML, text. And final one, let's do markdown, touch, and description or readme.md. Git add, git commit m option, and readme file has been committed. And as usual, git push origin, and let me refresh it. Here it is. Here it is. Here it is. Readme.mg. So with this, it's clearly visible on your screen. On left side, you see local repo. On right side, you see remote repo. So local repository has been connected with the remote repository, and then we have pushed all the files that we have created in local repository into the remote repository. So this is how a developer who writes the code in his local machine in VS Code or somewhere, he writes that in a local machine, then he pushes it into the remote repository, into the GitHub. Similarly, somebody else writes the code in his local machine, and he also pushes that module. So a complete application will be broken into few modules, and each module will be allocated to different developers. So each developer will complete their module, and from their local repository, each guy is going to push it into the remote repository, and there you can find the complete piece, all modules together, and you will get the complete one application. This is how we write a code. We are going to see the demonstration of that also. So we have seen enough. Now before we wrap up, let's going to look at the Git and GitHub collaboration simulation. So here what we are going to do is, let me open a sticky note. Here what we are going to do is, we will simulate the real scenario of how three developers who are working on one project is going to use Git and GitHub to work on, to collaborate and integrate their respective modules into the repository, into the remote repository. So here first we create a remote repository in GitHub. Then employee 1 is a front-end developer. He is going to front-end developer actions. He will clone the remote repo. Then he develops his module front end, then pushes that to remote repo. And third, backend developer actions clones the remote repo, then writes his modules, then pushes that into remote repo. Then fourth, data scientist actions writes his modules, before that he has to clone, basically not just pull, he has to clone the remote repo, all the changes whatever that have been added, and then write his module and push his modules. And fifth, once all done, front end developer and back end guy and data scientist is going to pull all of the changes from the remote repo into their respective local repos, so that everybody will have unified and uniform repository. If by mistake a remote repository is missed, then everybody, all three, will have a complete piece of code. If backend developer missed his code, and front end will have, front end will miss, and data scientist will have. This is the benefit of having a distributed distributed code version. So we'll have a centralized one, central repository kind of one, and second one is distributed version control system. One is centralized version control system. Those were all previous versions, subversion, SVN. So those are their versions. Whereas now Git is not the centralized version control system. This is distributed version control system. So here everybody is going to have a unified, uniform source code. Because of that, if somewhere somebody misses, other people will have for sure. Okay, so that's what our piece of code, so our exercise that we are going to do. Okay, now let's begin our exercise. Business analyst has to execute some prerequisites. So those prerequisites were executed by the business analyst. So he has created an organization called Imloic org, and after creating that Imloic org, he has added all the developers and AI scientists and quality assurance personals who are working on this project. He added, and here there are four members in this project. One is AI scientist, second one is front-end developer and back-end developer, and this guy is quality assurance personnel. So, and after that, business analyst, project lead is creating a team with the name data science team. Project lead has created a data science team. And after that, he's adding all those members into that particular team. Finally, all respective members were added to the data science team. Finally, he's creating a repository with the name MLApp. And he's assigning data science team to write access to this repository. Teams all four members received email notification as they were added into new team and new repo. In addition to that, project lead also sent the GitHub repo URL and SSH link to the respective members of project team. So Charan, the AI scientist, has started working on the project. So he has begun his work with configuring his Git in his local machine. Then is cross-checking his global configuration. So he started after the global configuration validation. He started working on his actual project. So he cloned his project first. Cloning has been successfully done. So he cross-checked what all files he has just cloned into his directory. Then he started writing his Python code. He has written all his ML modules. So his part of writing a code has been done. So now he is planning to push all the changes that he has done it to his local repository into a remote repository. For that, he is adding the changes into staging area. Then he is committing the changes. Then he is ready to push into the so the code from the AI scientist has been pushed into the remote repository. So now the AI scientist is just visiting the remote repository and he's just cross-checking whether the code has been pushed into remote repository or not. So all ML modules has been pushed into a remote repository and it was committed by Charan, the AI scientist, and the commit message he has sent was committing all the ML modules. Now let us move to Rahul R, who is the front-end developer for this project. So as usual, Rahul has started with configuring his Git. So Git and he's revalidating his global configuration. So his configuration is done. Now he is ready to start working on the project. As usual, he is also starting by cloning the repository. So he went to repository, then he copied the URL of it, then he has run the git clone. Cloning has been done. So now he has entered into that cloned project directory. Now he started developing his front end modules. His part of front end development has been done. So now he is ready to add them into staging area. So then he will commit those changes. So once commit has been done, now it's time to push it to the remote repository. So the front-end developer's code has been successfully pushed into remote repository. So the front-end developer, he would like to cross-check the data pushing into remote repository. So he verified it. He found that the files were successfully integrated into the source code in remote repository. backend developer Jancy is waiting for her turn to push the code from her part. So as usual, she also started by configuring her Git. So now she is cross-checking the global configuration of her Git. So cross-check has been successful. Now, as usual, she is ready to clone the repository and add her piece of backend modules into the remote repository. So clone has been successful. So now she can see all the files, all the modules, all the code, source code that was developed by the AI scientist and front-end developer. So while she is cross-checking what all codes were committed by whom, she found that Surya Charan, the AI scientist, committed some modules when in at this time, and ML modules were committed by Surya Charan or Charan, other Charan, and when she is observing who all done the commits, she found that project lead has initiated the first commit, and after that Rahul R has committed his front-end development code, and in between Rahul R and then project lead Charan, the AI scientist, has committed ML modules. So this is the history of the remote repository that she cloned. So now she is ready to write her backend development code. So she has developed all the JavaScript's features and functionality and databases that are required for various purposes. Mm, So all were developed, and the JavaScripts and databases were developed by Jansi because she is a backend developer. So now she is ready to add them into staging area, and she is committing them. So her commit is done. So now it's time for her to push from local repository to remote repository. The push has been successful from her local machine, local repository. Now just she wants to confirm whether it has been gone to the right place, to the right remote repository or not. After cross-checking, she found that all her JavaScripts and databases were successfully integrated into the source code or base code of the project. And she also verified that the commits were made from her Git or not. Jansi Volvo and Jansi Volvo committing back end modules. AI scientist Charan is ready to integrate all the changes that happen to remote repository into local repository. So you see the global configuration, it is Charan. So now he's gonna integrate the remote changes into his local repository. So he has successfully pulled all the changes that had been happened to the remote repository that he was part of. So he just cross-checked whether he has received all the files from the remote repository or not. Yes, it is. He has developed machine learning modules that anyway he has it, whereas all other files from front-end developer and back-end developer JavaScripts and HTML, CSS database files also integrated into his local repository, into AI scientist's local repository. With this, he successfully integrated all the code changes that happened to the remote repository into local repository. So total in this project, 4 people are working. Surya Charanteja, project lead, Charan, AI scientist, Rahul R, front-end developer, Jansi Volvo, back-end developer. So Surya Charan Teja initialized and Charan committed ML modules, Rahul R committed front end modules, Jansi committed back end modules. Now Rahul is also ready to integrate the code changes that had happened to the remote repository. So before that, he just want to show us its global configuration of Git. Yes, it is Rahul's. So now he is ready to pull all the changes that had happened to the remote repository. So he has integrated his local repository with the remote repository, and it is already up to date. And he has all the files which remote repository consists of. So Rahul, the front-end developer, has also successfully integrated all the changes into his repository. So now project lead wants to check the status of the project. So he just want to let us confirm that his global configuration of Git. Yes, it is Surya Charan Teja, the project lead. So he is just cross-checking whether all the developers has completed their work successfully or not. And the initial commit was made by project lead. The next commit was made by AI scientist Charan. He has committed all the ML modules. And the next commit was made by Rahul R. He has committed all HTML and CSS template source code. And the third commit, the last commit made by Jansi, backend developer. She has committed all backend modules. And he also wants to cross check whether all files has been successfully moved to remote repository or not. He found that all the modules from front end, back end, and ML modules were successfully integrated without errors, and you can also see the number of commits which were made, the commit history also. So Jansi has committed their backend modules, Rahul has committed front end modules, and Charan has committed ML modules. So he is pretty satisfied with the complete project source code. So now he will forward this repository URL to the operation team for further operations. So now let's look into advanced exercise in GitHub and Git. So here we will use Visual Studio Code for Git and GitHub. So in this, what we are going to do is, in spite of using Git Bash, we will use a Visual Studio Code. Okay, the purpose would be same, but it's much simple, so and much intuitive. So here what will we do is VS Code for GitHub and Git. That's, and first activity here is open, create a public repository in GitHub account, then open your VS Code and go to Git section and clone the remote repository. Then once that is done, now let's give a destination local address to the remote repo. Then we'll start writing our files and modules, add the changes, commit the changes, and push the changes. So this is the exercise we are going to do. So let's get into the action. Let me go to the VS Code first and click on your repositories. So here I will create a new repository. I'll say this Git Hub and GitHub remote repo, and this repository, this is a remote repository for the purpose of experimenting with VS Code. So let me create a public repository, not private one, and let me add a readme file and click create repository. So our repository has been created with the main branch, and you can see that readme.markdown file here. So let me copy the URL, HTTPS URL of this repository, and then let me open a Visual Studio Code. So Visual Studio Code has been opened. So let me click on, I think, let me click on Git and go to this three dot menu bar. So three dot menu, so it pops up a vertical menu bar. In this you will get all the information, all the various activities that can be done in Git. Basically these are all commands. So push, pull, clone, checkout, fetch, commit, changes, pull, push, branch, remote. Even in branch you have all the options. So instead of giving commands, actually you can interactively, intuitively, by selecting the commands, you can do the operations. That is the only difference. But I always prefer GitHub, I always prefer Git bash rather than VS Code or Intelli, uh, or any other uh, text editors or any other um, tools that are presently available in the market. Any other IDE, integrated development environments, presently available in the market, because that's where you use your command and you look into each and every detail in proper. So you involve yourself inside into the activity. So that's where you'll get the complete exposure of how things are going on, what's happening behind, and what you can do and how to solve that. But here in this case, it's like kids play. You just select, 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 select. That's it. Okay, that's fine. It's all up to you. What you want to do, which one you want to use. Of course, using VS Code is much easier because you don't need to type commands. You just need to select. Okay. So let me, so you can add that remote, you can remove the remote from here. Then we have created the tags using tag command, so you can create using by selecting here. Then so let me go to the clone, click on clone. So now, so let me paste that URL here. Now I say clone from GitHub. So once we say clone from GitHub, it will bring all the repositories that are available in that GitHub. You see that? So I will click on the latest one because it's a GitHub remote. Yeah. So now it is asking me to select a repository destination. Repository destination. So I will select a repository destination now. Go to the D and then I would go for them like my YouTube channel, IDEOps course, and then in that CI/CD pipeline. It's Git and hands-on. In hands-on, I'm going to select a new folder. Create a new folder saying VS Code Git GitHub exercise 1. So let me select as a repository destination and click OK. So now it is cloning that. So would you like to open the cloned repository or add it to the current workspace? I would say open here, not in new window. I don't want a new window. So you can see that everything has been cloned and you can see that GitHub remote repo. GitHub remote repo. This is what the remote repository is. So now I will go to that folder and I'll show you in hands-on GitHub. I think it's VS Code. Yeah, here. You see that? You got the GitHub remote repo. It's been cloned. Yes, you see that? Readme.file. Let me open this. You see that? GitHub remote repo. I think now it's clear. It's pretty much clear. So, but before that, what I would like to tell you is the one most important thing to be done before working with the Git in your VS Code is you have to configure your Git. How do you do? you will have, as usual, you have to install your plugin, Git plugin. Once the plugin has been installed, you just write down the process, okay, or else I will only write. So how to configure Git in VS Code. So first step is to click on plugins and install Git plugin. Then once the plugin has been installed, it will ask you to log into the system. So provide your GitHub credentials, that is password, username and password. So once credentials, once logged into the GitHub, once logged in is done and the credentials are accepted, so it's all set, because this VS Code will connect with your GitHub, and it will take your GitHub repositories as remote repositories. Okay, so that's how this is very important. I hope most of the people, you might have known how to install the plugins in it. Okay, anyway, I will show you that, but by this moment we have completed create a public repository, and then open your VS Code and go to the Git section and clone the remote repository is also done. Then give a destination local address to the remote repo, that's also done. Now we have to start writing our files and modules. Okay, but before that I will show you. So here you can see that extensions, here you can see run and debug, and here you can see, so basically when you go to the settings, or if you just type so you can easily find out your plugins here. So once you click on your plugins or extensions, uh, you can see that. So Git history, because for me Git has been installed, and Git patch, Git auto config, Git repo. Of course, all these are not required. At least you have to install Git. So if it is latest one, by default Git will be installed, or else you have to install it. If it is if your VS Code is very old version, then so you have to install this extension, or else it's not required. Okay, so now let's get back to our work. So this is our local repo. So you just look into this vertical menu bar. So now we are in Explorer section. So Explorer section, this is our menu, this is our local repository. So I will click, I'll create a file. I would say calculator dot python. So I'll download some simple code from internet, anything. So calculator python code, anything. I'll just take a few pieces of python code from here, so that okay, there are lot much. I just want to copy a few things. Okay, I'll just copy the initial module, I think complete. Let me take this one, and if it is required, I'll see. This is the simplest one anyway, so let me paste it here. You can see that. I'm not here to explain this piece of code here. So anyway, I have done Python course. So if you want to learn about Python, you just visit Intuitive Python for You course. You just watch that course. And I'm gonna do course on artificial intelligence also. So if you want to learn more, just stick with me. No problem at all. So let me execute and see whether it's a working code or not. Okay, so enter choice 4 4 4. Yeah, that's fine. Let's do the next calculation. S 4 2 4 5. Okay, that's okay. So it's working fine anyway. So now our calculator app is ready. So now what we have to do is we have to push this code into remote repository so that everybody can see, so that whoever part of our team can view it, and if they want to suggest new changes or if they want to add few more modules to it, they can add it. Okay, so for that what I will do is, so now we are in explorer section. Now let me come to the source control section. So in this you can see Git source control section has been highlighted with the one, okay, one round icon. So what it is saying is excuse me, yeah, so what it is saying is changes. So changes, one changes has been done, one changes have been done. So now would you like to add them? Because normally whenever you do the changes, we say git add dot, then the changes will be added. But here in this case, you just click on plus, all changes will be added. So I am clicking on plus symbol, you see, and all changes has been added. You see that staged changes 1. So now these changes has been moved into staging area. These changes has been added, these changes have been added into staging area or index area. So that's what it's saying, staged changes. Before they were normal changes, once you click on plus, it's become staged changes. If you click on minus, this changes will be taken out of index or staging area. Anyway, that is not important for us now. So let me commit now. To commit, I will type a commit message. This is the first commit of calculator application using Python lang. Okay, first commit of calculator, that's more than enough. So now let me click on just commit. So you have three options when you click on the drop down menu, drop down button of commit. So you have three options: commit, commit and push, and commit and sync. Okay, when you click on drop down button of commit button, so you will find three options. One is commit, commit and push, commit and sync. So we'll do commit now, and for now we'll do commit. So now commit has been done, so now let's give a message to push it. Basically synchronized changes. This is our first push in this repo. So then let me click on sync changes. So it's taking some time, but finally the changes has been done. So the changes has been synchronized. So now let us get into the GitHub and see what's going to happen. Let me refresh the page. Here is the app, calculator.py. Find it? Got it? I think you might have found this VS Code, using VS Code for the Git is much easier than git bash. Of course it's easier because you're just pressing the buttons. You're just pressing the buttons, nothing else, nothing much you're doing. So that's the reason you feel it's easier, but that's okay. All depends upon your preferences, what you like more. I like to go with git bash, not a visual studio code or something else. But in some cases when you're working on big projects, so that time you have to write a big modules in VS code. In that case you can directly use from VS Code, or you can use Git Bash, whatever you want. Okay, so this is all done. So now we are going to add one more file. So that is this time we will add the index.html template. So I have moved to Explorer section again. So let me click on a new file here, and I would type index.html. This is HTML page, and we will download some sample HTML templates. Anything is fine. Okay, there are a lot of we want just a simple piece of code. Actually, I don't want all those things. Just to okay, here also I think we are not getting a proper example. In that case, mm, yeah, I think this is more than enough. Let's take this. Just some piece of code. Of course, we can write our own code. It's not a big deal, but I just want to attach. Yeah, this looks a little better. I'll take from body to body. Yeah, body to body I'll take. Rest all will create. So here, this is our HTML snippet. So here I'll write this is like sample website, and then inside of this body I'm gonna paste our body that we have copied. So rest all done. If you want to live check this, how does it look like, you can just click on go live, and you can check it. So that's absolutely fine. Okay, something lower some dollar something it's there, it's obviously fine. That's not the issue for us. So let's get into our work now. So now edition has been done. Now it's time to add this file into the remote repository. So here you can see that the changes has been highlighted. Now you just click on the plus symbol so that these changes will be staged, these changes will be indexed. So once the changes has been staged or indexed, now it's time to commit. So this is our second commit, and you will directly say commit and push this time. So it's committing and then it's pushing. So with one click, commit and push has been done. So it's synchronized. Let's get into the Git Hub and we'll see what's the status. So GitHub, let me go scroll up a bit. So get back to my repository. Here it is. You got the index.html. So that's it. It's that simple. It's not that difficult. If you deal with a git bash, you have to write your commands and subcommands and then options, and a lot of stuff is there. Whereas here, you just mention the file names. That's it. It's all done. That's how basically all the developers who work on the same project, they collaborate through Visual Studio Code. You can do the same using IntelliJ path also. So with this, let's get into our yeah, you see, activities. Fourth activity is completed, writing of files and modules. It's done. So add the changes to the staging area. Also done. Then commit the changes is also done. And finally push the changes into the staging area. So with this, we are able to successfully demonstrate the uses of Visual Studio Code with the Git and GitHub for your projects. We have a similar tool as Visual Studio Code, that is IntelliJ IDE, Integrated Development Environment. This also will do the similar kind of work, but in a different way. So the user interface and user experience, and then the way we proceed, all will change. But the flow of working remains same, but the experience would be slightly different. If you do not know how to handle, if you have never handled IntelliJ, means it's difficult to use IntelliJ for Git and GitHub collaboration. So that's the reason I would like to take. That's the reason I had decided to take this exercise as part of Git and GitHub. So the procedure by and large remains same. So as usual, the only thing that differs is, so let me change this from VS Code to IntelliJ, and then only thing that we are going to add is, I'm going to add an GitHub account for the IntelliJ IDE. So I'm going to do this configuration here, and then we will execute the steps one by one. The flow remains same by and large. Okay, so let me get into the GitHub, and let us create our repository for this. So now if you see, I'm in I'm Cherry Rams. It's another GitHub account. Basically, I have created this GitHub account only to demonstrate the exercises for these tutorials, nothing much. So here I'm gonna create GitHub and IntelliJ remote repo. So I would say same thing, I'll copy here also. So let me go with the public repository. Then I would say add a readme file, and let's create a repository. So the repository has been created in Cherry Ram's GitHub account. So now, so our repository is ready. The name is GitHub IntelliJ remote repo. So now it's time to jump into open our IntelliJ and do the needful. So let me maximize this first. This is the launching page or initial page whenever it opens, and it asks for the tip of the day. It basically pops as soon as you open up. It will pop up the these tips of the day. If you want to see the tips, you can just go through it, or you just click on close, and so this is the initial page, the main page of the IntelliJ. So whatever you want to do from here, you can open your projects in file, you go to the new project and you click on the new project, or if you want to bring an existing sources into here, then you can go for the project from existing sources, or if you want to go for the new project from version control, you can go here, or you can simply open your project, and then here you can get the open recent project. From here you can close the project, and here you can have a settings, and then if you come down a bit little bit more, you can find the most important thing is new project setup. That's okay. IDE settings. So this is also one important thing, because the overall user interface, whenever this IDE integrated development environment, if you do any modifications on the IDE on user interface sides, like if you move the tabs one and there, and if you remove the tabs that are existing, and if you find difficult to bring them back, then you just say restore default settings. Then automatically it quits the IntelliJ, it closes the IntelliJ, and then it restarts it. When it restarts back, it brings up all the uh, default icons and tabs and everything as usual. You can see this is the best way to put up. So here you can see, if you click on double shift, you can search, and then for you can create a new file from here. Once you open your project, you can click on new file, and then you can create. So this is how it works. And here you see here we have edit options of the file, then here view options, and then navigate, code related, refactor, build, run. These are all bugging, debugging. This is specific to Java, right? So that's the reason you have this build. What is a build? That we are going to see in our next part of this module. That is Maven. Using Maven, we are going to build JavaScripts, Java codes. We'll take a Java source code, and from Java source code we are going to build an artifact using a Maven tool. That we are going to do. So this is similar to that. You can click on build project, and you can do the build, and then rebuild, and you can build the artifacts. So all those things you can find here. So okay, this is run and debug. This is about the code. So here you have tools, different tools. Here is the Git. This is important for us. Okay, this is important for us. So here you can see all the options in the Git menu: commit, push, update. These are all nothing but a commands in Git bash. Yes or no? Yes or no? Yes. I'm only answering. That's fine. If you like, you just answer the same in comment section. So then merge, rebase, branches, new tag, reset head, everything, all the information. See, if you click on here, you can clone, then manage remotes. So current file basically, and then patch and all this information. Here Windows to add more windows or anything, active tool Windows, so background tasks, all that information you will get it from here. Okay, so we've seen enough. Yeah, so now first act that we are going to do is, let's get into the settings that you see on the top uh, horizontal horizontal menu bar. Just click on this small settings icon. I hope it's visible for you. The small settings icon, this is called IDE and project settings. Let me get into that, and then you'll find you see that a wrench, a spanner icon, and then click on settings. So now here you'll find the appearance. If you want to increase the font size, use custom font and put 18. Apply. I hope now it would be much clearer for you. Okay. So that's like that. Here you can find menu and toolbar. What all toolbars? It's like complete user interface. How do you want to customize for your preference? That's it. That you're going to find here. So file color, scopes, notification, path variables. Here you can have some path variables. This is Maven repository path variable. That's okay. All fine. So let me minimize that drop down menu of appearance and behavior. Then here you will have a editor information, editor, font, code editing, color scheme, code style, whatever you want, all that information you'll get it from there. I will minimize that also from there. And let me go up, scroll up a bit up, and then minimize the editor editor drop down button also. Now here you can find this version control. Here you have plugins. From here you can actually install your plugins. Okay, similarly we call this in version in you see that here we call it as a extensions. You see that extension, sorry, here extensions, whereas in IntelliJ, we call it as a plugins. You can install all the plugins, whatever is required for you. So if you see, these are installed packages, installed plugins, Ant, Gradle, Maven, all those things installed, because I work on this development also, building a JavaScript application. So that's the reason I've installed Ant, Gradle, Maven, and all those things. Okay, but that's not the point of matter here. Now it's time to speak about the version control system. So here I just maximize this one. So now you can find all the information about VCS. So there are different types of tools that you can use in VCS. It could be Git or it could be Subversion, whatever it may be. But here in this case, we are using Git as a VCS and then GitHub for the source code repository. So here, because we have set it completely to default, I have restored to the default. So all the accounts are gone. All the accounts are gone. So no, not even a single account has been attached with my IntelliJ IDE. So now I'm gonna attach an account, add account. So you have two options, either login via GitHub or login with the token. So in spite of going with the token, I would say login via GitHub only. This uses a browser to log into your GitHub. So now I say authorize into my GitHub. So through browser, it is authorizing. It is saying, just read this. I think it's visible now. You have seen successfully you have been successfully authorized in GitHub. So you can close the page now. Okay, I'll close the page. So now let me get back into my, here you see that. So Cherry Ram's account has been, the Cherry Ram's GitHub account has been attached to IntelliJ. So that account has been configured with IntelliJ. So now you can use it. So what I will do is I'll just apply the changes. So changes has been applied and then I'll click OK. So this is how we configure your GitHub account with IntelliJ. So the configuration is done. Now it's time to clone your Git repositories. So for that, before that, I will minimize this one. It's not required for us at this moment, so it saves some space for me. So now on main menu, on top a main menu, I'll go to the Git. I click on the Git. Here you can find a lot of options: commit, push, update, project, pull, fetch, merge, rebase, branches, new branch, new tag, reset head. So out of which I'm gonna select clone. So when I click clone, it opened up a new window. In that you have three options. First one is a repository URL. What you can do is you directly go to your GitHub account. Here is my GitHub account. This is my repository. Just go here and copy the HTTPS URL and paste it here. That is one option. Okay, and then you can choose the local repository directory here. So that's one option. Or second option, you can see here, this is directly as you have connected, as you have configured your IntelliJ with your GitHub account. So that GitHub account will show you, will populate all the repository that are present inside your GitHub account. You see that these are all repositories are there inside my GitHub account. If you don't believe this, I'm going to show you that. Let me get back to my your repositories and I'll click on repositories alone. So now you will find, see how many are there? 1 2 3 4 5 6 7 total. We have 7 repositories. 3 4 7 repositories. So out of which, now which repository we want to select? We want to go with GitHub IntelliJ remote repo. Yes, is this the one? Yeah, let me cross check it once. GitHub IntelliJ remote repo. Yes, this is the description that we have given. Proper. Correct. Absolutely correct. So now this is one option. And second option is GitHub Enterprise. Of course, I do not have a GitHub Enterprise account personally. Official is different, that we cannot use anyway. So that's the reason these two options, either a repository URL, you can paste a repository URL and you can give the destination of the local repository, or you can go with the GitHub account. You can click on the GitHub account and it will populate all the repository that belongs to that GitHub account, and you select the one repository that you want to clone. So this is the one I want to clone, and the destination I want to put, I will do it. I will select from here. Okay, I'll scroll down a bit. I'll go to the D drive, and inside that I will go to my imlac. So in that I'll go to the YouTube, and in that I'll go to iDevOps for you course, and inside that I'm gonna go to module 5, that's part 1, that's Git. So inside that I will go to hands-on, and hands-on, yeah, hands-on is fine. Or in hands-on I'm gonna create one new folder saying IntelliJ and GitHub exercise, and let me click OK and select that. It's been selected. Okay, this has been created outside of that. Okay, that's fine, whatever, wherever it may be. So the folder has been selected. Yes, part 1, yeah, part 1 Git. Inside that part 1 Git, it's been selected. So this is the destination directory of the remote repository in the local machine. So when I clone it, the remote repository will be cloned into this directory. So let me clone it now. So cloning is taking place. So it's asking, I would say, Rust project. I would say, where would you like to open the project? I would say you do it here only. Don't go anywhere. So it's loading. Yes, here it is. You see that? This is the project. IntelliJ GitHub exercise. I'll show you. So in that directory, the project will be stored. So the project will be cloned inside this directory. Okay. IntelliJ. So if you go to the readme of a remote repository, you see that you have only two. This two, and here also these two. Okay. We are in a proper place. Externally added files can be added to Git. That's okay. So now let's add our piece of code. So so far I hope everything is clear. So now what will we do is we will create our first file in the same directory. For that I will click on here. I'll click on new HTML file. So I would say index.html. Yes. I'd say okay, add file to Git. So not now, just give me some time. I will tell you, just give me some time. It's directly asking should I, if you choose cancel, you can still add it later manually. Okay, I will add it manually. You just wait for some time. I need to do some other work. So this is, and I'm gonna customize this one. So for that, what I'll do, I'll copy the code from here and I'll paste it here. So this is my index.html. My HTML page is absolutely ready. Yes, it started with the doc type and then heads, and after that body has been started, and there is a huge amount of code is presented in this. We have written that just few months back. That's fine. So now let me get into the repository and see where it is. So I'll get back to the part 1 Git. So here you can find that IntelliJ GitHub. Here is that in this directory, this is the local, this is the current working directory, and this is where the Git has been initialized. Okay, the Git has been cloned. So now what I'm gonna do is, so I will attach some files here. So with this, let's get into here. So this is our complete present working directory. So now project configuration files can be added to Git. It's asking directly, it's asking. Now I'll say yes. you view files, or we know what are the files, I'll directly add them. So I'll click on always add. So now we are in a second. I'll take, so first step is done, then second step is also done, then open IntelliJ, and this is also done. This, the third step is also done, giving a destination. So now it's writing our files and modules was also done. Now we have add changes. Now we have to add all these changes to staging area, then commit the changes and then push the changes, and we'll see what's going to happen. Okay, let's get back. So let me click always add one more time, and let's see. Let's update the project. We have used that notification, but if you want to do it manually, you come here on the top menu bar, and then you sub menu, you can say it as a sub menu, and then on this menu you can see the Git section specifically. This part from here to here, this is Git section. You can click on update project, or you can give the Ctrl+T if you want to update the project, but at this moment I don't want to do. So anyway, the changes has been added to the staging area. Now it's time to click on commit. So now it's asking 71 files are there, total 71 files, 71 changes are there. You can see that 71 changes. Do you want to commit? And I would say commit all the files, all the files of my resume application. Okay, I would click on commit now. So now it is committing all the files. All the files means literally all the files. Total 71 files has to be added. So checks failed, 5 errors and 3 warnings. That's okay. I would say commit anyway. It doesn't matter. Because here we are not here to do the debugging. Okay. We are here to explore the way to collaborate using IntelliJ with GitHub. Yes, 71 files committed. You can see that this green message, 71 files committed. Commit all the files of my resume application is the message that we have, a commit message. Now it's time to push it. It's been committed. Now it's time to push it. So for that, you can see that this is commit, and here the green arrow is to push it. I'm pushing it now. Here you can see the main is the local repository branch, and origin main. Origin is the alias name for the remote repository, and this is main. So now origin is the remote repository complete URL, and then inside that we are handling with the main branch. So now we are pushing from main branch to the origin is the remote repository's main branch. That's what it means. So then here we are giving the message. It's a commit message. I keep the same. I don't want to change. I don't want to add the other one. So now it's time to push. So you have some option. Force push. We'll just push normally. There is no issue, I think. I don't think we'll get some issue here. It's pushing. You can see that here at the bottom. Pushing. It's been pushing. So it may take 2 more minutes. I don't think it will take 2 minutes. At least 1 minute it will take, because it's a huge data we're pushing into it. So let it take its own time. Meanwhile, you can explore the user interface of IntelliJ. You see that the main menu, what all items are there: file, edit, view, navigate, code, refactor, build, run. Build is very important tool for the Java build, to build the Java source code into an artifact. Why we need to convert a source code into artifact, that we will discuss in Maven part. Okay, pushed one commit to origin main from main branch of local repository to origin, the remote repositories, and main branch. It's pushed to pushed. Okay, from local to remote main branch, it's been pushed. So now let us get into our remote repository and refresh it and see the magic. Here is the magic. So your complete application has been pushed into remote repository other than one file, that is index.html. Okay, now we are going to add that also. We are missing index.html. So let me add that file also. So here is my of course it's there, then why are we missing? So let me check that. Let me come to the project. Okay, okay, about this. Yeah, here is the index.html. So let me commit this time. Save it. Let me cross check the directory one more time whether we have received about assets vendor and about readme is there, but there is no. Okay. Let me save it. Add one more comment. So custom comment, and then we will these changes we will push it again and we'll see. Let me save it, and now I'll say commit. So unversioned files. Okay, this file hasn't been versioned. So now I'd say directly commit and push. So this time I'm committing index.html only. So commit and push. One error, commit anyway. So this is what I want to commit. Okay, all done. Let me commit it. Pushed and committed. Now let me get into this and refresh it and check. Yes, you got the index.html, and let me try to open this in browser. Okay, this is what the source code, and let me get into the folder. So now just to demonstrate the application that we have pushed into the remote repository. Okay, with that we can successfully proven that. So even using IntelliJ, we can also do the same kind of operations with ease. So this is also not that difficult. It's similar to that, but most people prefer to go with I hope whom the most of the people that I know, so they prefer to go with the Visual Studio Code. So I just want to show the application that we have just deployed or just pushed into the remote repository. This is what. Yeah. So let me get back. So with this, we have seen how to use IntelliJ IDE code for Git and GitHub. So to sum up, let me get back to the sticky note. We have configured our GitHub account with IntelliJ IDE. Then after that, we have created a public repository in that, in a GitHub account. Then we have come to the IntelliJ, and then we went to the Git section, and then we have cloned the remote repository. Then after that, we have used a destination local address to connect with the remote repo and to set up the clone. And then we have written our source code. Then we have add the changes that we have done to the source code, and then we have committed the changes. Then finally we have pushed the changes into the remote repo, and whatever activity that so far we have done, all is successful. So now let's see some of the GitHub challenges that we normally face when we are working in our projects as a operations engineer, or are part of the operations team. Then you have to uh, deploy, or you have to get the code, you have to get the source code from the GitHub, and while we are trying to fetch the code from the GitHub, so we may face some challenges in real case scenarios. Let's see, so how can we solve that challenges. So the main challenge for us is unable to clone a repository into Linux machine. So this could be a usual problem. This is the main problem. A lot of times we are unable to clone a repository into Linux machine. So I have faced this problem. So I have used many methods, three methods from GitHub, and then I have created my own method to solve this problem, because whenever I had faced some or other way, I had to found a way to basically clone a repository into my, either clone a repository or just copy the files into my Linux machine so that I can deploy the application. So the first one is using HTTP clone, that is HTTPS, and second one is secure shell clone link, and third one is GitHub CLI clone link. These are options that were provided by GitHub itself, whereas the fourth one that I have created, so it's like I have found this way workaround, so that if one of these three won't work, then I would go for the fourth one. So using HTTP clone link, I do that. I'll show you how I do. Okay, so total these are the four ways we can basically fetch and gather the data from GitHub repository into your local sorry, not local, into your Linux machine or your Linux server. Okay, so for this how we gonna go ahead, so we're gonna follow for GitHub challenges. What will we do is, first we will go to our GitHub account and create one one public repository and other private repository. 2. So once the repositories have been created, now it's time to create your server. So let's go to the AWS and then create an Ubuntu server. Ubuntu instance, Ubuntu EC2 instance. We will go with T2 small only. Then set up security group. 2 done. So once it is done, so now it's time to fetch and transfer files from GitHub to EC2 instance. For that, we will begin with we will begin with HTTPS clone link for both private and public repository. If that doesn't work, then we will go for the using SSH clone link again for both private and public repository. Then third one, we'll use Git Hub CLI also for private and public. Then last but not least, my technique. So my workaround is using HTTP download link and wget GNU utility in Linux. So these are the 4 ways, and we will do it step by step. So let us execute our first step. I will go to GitHub account and create public repository, and we'll integrate with our local repository, and we'll push all the files into the public repository. That means our repository will be ready. And similarly for private repository will be done. So it's like I just want to simulate a real case in such a way that if some developer pushes the code from his local machine into the remote repository, and after that, once all the source code has been deposited into the repository, then the ops team will collect this code from the GitHub, and then they will take this source code into the respective Linux server or a respective production server to deploy this application. So I just want to simulate this one. So first we will basically push the code from our local machine. Then the second activity would be, after creating AWS, the second activity would be again fetching the files. Okay, let's create our first so let me create first public repository. I would give name GitHub and challenge, and it's pub rep. Okay, this is the name of our repository. This is okay, I'll just copy this one. This is GitHub. Okay, GitHub challenge just public repository. So I'll keep it public, and I'll add a readme file, and this will set a main as the default branch, and let me create a repository. So then let me copy the HTTPS link. So then I'll open VS Code, Visual Studio Code. So let me close this folder. Yeah, file, new window, and close the old one. So now let me close the get started and click on Git. So here you can click on clone a repository. Now clone from GitHub. So this, okay, that other GitHub I do not have, so I will use IntelliJ IDE. Okay, so here I will create a new project. Get from VCS. So I'll directly click on GitHub, and what is the name that I have given? GH challenge pubrep, and click on clone. So it's been cloned. So now I will add uh, two more files to this. I call it new. I'll open HTML file, that is index.html, add, then one more file I'm gonna create, sorry, no, new. I would create one more file, that's styles.css, add, then after that I'll create one more file, that is JavaScript. So there are a lot of files of this from scratch. I'll click on JavaScript syntax highlighting .js. No, not inside the scratch, is it? I'll cut this one. Okay, here at this part, new, I'll click on Java class file, let's say function.js, add. So it's done. So three files have been created. So okay, this opened the, okay, so our repository is ready. Now for us it's time to commit, push, add it to the staging area, and then commit them. So unversion files you put all together and then commit and push directly with one key. So he wants me to specify a commit message. I would commit all the files. So all the files has been committed. So now one warning is there, but still that's fine. Commit anyway, and then it took me to the push. So what I'll do, I'll click on push. So with the message is same as a commit message. So pushed one commit to the origin. So it's been pushed. Let me get to the repo and let me do the refresh and we'll check. Okay, our function, that's JavaScript, and then HTML, CSS, everything is ready. This is Java class format. So our application is ready. So this is a public repo. So one pub rep is done. Next we have to create private repo. So let me create another repo. Go to the your repository and click on new, and I would give the same name, gh, and gh challenge. Then after that what we have is GitHub challenge, then we say private rep. So this is GitHub challenge private repository. So I'll click on private now. So description is that it's private. Let me add a readme file. Initialize this a repository, skip. Okay, then let me create the repository which is private. So now as usual, let me clone this and get to the IDE. So this one is done. So one commit. Now I'm gonna create, sorry, I'll come to the Git and I'll create, or else I'll create new project, and in this new project it's asking new or empty. It's new, and location I'm gonna set, okay, anything is fine, but still it's better to use the proper one because it takes huge amount of time nah? So I'm like YouTube iDevOps, and it is Git in action. Okay, that's done. This is GitHub challenges. So let me create this. I'll replace in the same window because it's been done. So we'll replace it in the same window. So main.java, this one. So let me, okay, this has been created like a project. It's not like, okay, now the project that we have created is completely different format. There is no version control. Let me click here. So now whatever repository, so we haven't cloned a repository, so let me click on a create a repository. So on the same, click on OK. So local master. So now let me add few files here. Source is fine, yeah, here new. This time I'll add Python files, all the Python files, and .xlsx files, some data files, and one db. So module.python add, and next we'll add database file, records.db, and then we'll add Excel sheet. Okay, data file data.xlsx. Okay, so all files are ready. Now it's time to click on commit and push, but before that it's better to connect it once, I think. Okay, let me select GitHub, and it is private rep clone. So cloning is taking place. That's a private rep. So it's asking a, it's a warning kind of thing. So trust and open project GitHub challenge private rep IntelliJ IDEA provides features that may execute potentially malicious code from this folder. If you don't trust this source, preview the project in safe mode to only browse it. So I trust this because this is from my account only. So I'd say trust project. So do you want it in this window? Yes, of course. Yes. So we got it our repo. So now I'm gonna create few files here. The initial one would be module.python, add it, Then I'll create a records.db, and I think two are enough for this moment. So now let's push this commit and push this into our directory. So let me type commit all files into private repository, commit and push together. So these are the two files will be pushed, and I pushed it. So two files committed all files into private repository, pushed one commit to the origin main, which is a remote repository, which whenever you find a branch name with alias means it is a remote repository. So now let me refresh it. So here the module and then database file, so we have received in our repository. So now as we have discussed in our prerequisites, so our GitHub 2 repositories are ready. So let me mark it. So now it's time to get into AWS and create an Ubuntu EC2 instance. Okay, and set up a security group proper. So I'm in Ubuntu, so I'll go for Oregon. Then I will click on EC2 instance. Launch an instance. Name of the instance is GitHub Challenge Server. Ubuntu 18 would be fine, or else 20 also fine. I would go with Ubuntu 20. That's also fine. It's not a big deal for this. It's a small activity. So then instance type, I would go with T2 small. T2 small. T2 small. Where is that? Okay. Yeah, T2 small only. Then let me create a new key pair. This is GitHub challenge key. So let me edit the network settings and add some security rules. Before that, let's name the security group name. This is GitHub challenge SG. Replace the same with description. Then we have our security roles. So let me get into the security roles. So I want to access it. I want to do SSH to our machine, so that I will go for the SSH and port number 22 by default, and I'll go for my IP. And for now, this is more than enough. So add one security group rule. That's enough. So rest all, let's leave it. Nothing much to touch. So let me launch an instance now. So meanwhile, I'll get the key pair. So let me collect the key pair and put it in Git in action folder. So I'll place it here, paste it here. Yeah, here is our this thing. So now let me open a Git bash. Okay, so let me get into the instance whether it started or not. Yes, it is up and running. So our instance is up and running. You can see that. So with this, we have completed the second step also, that's AWS EC2 creation and setting up. So our Ubuntu instance is running up and running. Now let's begin fetching the data. But before you begin fetching, what one important task you have to do, that is installing Git inside your server. Okay, so installation AWS EC2 instance is ready. So now let's do SSH into AWS instance and we will install Git. So let me go for connect. So copy this one and open git bash in this location. So git bash here and make it bigger and then zoom it and paste it. So let me do SSH to the GitHub challenge server. So yes, it's done. We have logged into GitHub server. So now let me do sudo I. So I became a root user. Let me clear the screen and let me install applications one by one. Apt update. So apt package management tool. So we are updating that tool. So then we will go for the installation of Git. So how many packages can be upgraded? So 7 packages can be upgraded. If you want to do that, apt list upgradable. Of course, here it is not required. So once the installation is done, now it's time. Now let's install the Git. So a package management tool got upgraded. Now let me see. Apt install Git and I would give S. So as was given, so it's directly installing the Git into the GitHub server, GitHub challenge server. So Git was installed. So Git version is 2.25.1. So now let me clear the screen and installation of Git is successful. So the third step is also done, installation of Git. So now we are on the important task now. So it's time to fetch or transfer files from GitHub to EC2 instance. Okay, so first we will do with the public repository and we'll see what's gonna happen. So I would go to that public repo first. So here is that, and here is I'll copy this and create one more. So here it's a private repository, whereas here I'll go to the public repo and click on this first repo. Okay, I'll click on all repositories. So here is the public repo. So this is a private repo. So now let me copy. You see that you have a clone section. In that clone section you have two sections: HTTPS section, SSH section, GitHub CLI section. So we will look into these things later. These are pretty complicated. So for now we will look into HTTPS section. So here we will copy this URL for the HTTPS section and we'll get back to our machine and we will say git clone and paste the link and execute it. So cloning into Git challenge and it's been done. It's too quick because the files are small files. So it's pretty quick. And if you look into if you do ls, see here is your GitHub repository. the everything. Let me get into that. cdgh, you see that you have the same files. So let me clear the screen and show it to you one more time. So ls, you see function javascript 1 index.html styles.css. So it's clear that with respect to public repository, with using just http url, you can clone in your server. Fantastic. So now let's do it for the private repository. So private repository is here. So yeah, modules, this is Python application, and let me copy the file URL of HTTPS again, and let me execute it and see. Git clone and private repository URL, and let me click. So cloning, so it's asking username. So this is what I was saying. So username is Cherry Rams, gave username. Now it's asking password. It is so I gave password. It's saying remote support for password authentication was removed on August 13, 2021. So this is what I want to prove. Okay, for this only I'm doing this big exercise, but that's okay. So it would be helpful if anybody who wants to know, who wants to understand in depth, who is working, who is gonna work in operations team, for them it would be great help. It would be great help. So okay, so so remote support for password authentication was removed on August 13, 2021, because this is not that secure than compared to the other options that are available in the GitHub cloning. So that's the reason a remote. So if you have anything, so it's fatal authentication failed. Of course, authentication failed because that provision itself is removed. So now what is the option for us? So you have only one option. So but one thing is clear with SSH. Let me get back to our slide once. So with HTTP clone link, so with this you can only clone public repository. You can't clone private repository. I hope it is clear for you. So now if you want to clone private repository, how can you do that? How can you clone private repository? For that only we have SSH, secure shell clone. So how does this work? A secure shell clone. It's a pretty complicated concept. Sorry. So it's a pretty complicated concept. So let me write the activities to be done in this for SSH. So this one is done. HTTP with private and public both done. Let me cross this. So now using SSH clone. So let me go here. Come. The first step here is you have to using SSH key. If you want to do that, so first thing is it's most secure way. So we have two ways. Using SSH we have two ways. Either you can go with the SSH key or other one is GPG key. So here first we will look into the SSH key only. So I will show you both. So what we have to do is you have to create an SSH key in your Ubuntu server. So in the Ubuntu server that I have created, where I have installed Git na, in that server we have to generate SSH key, generate SSH key in your server. then copy the public key and paste it in the token of GitHub account. So this is what you have to do. Once this is done, so basically because of public and private keys, so you can the GitHub can securely connect with your Linux machine, or GitHub will allow Linux machine to enter in their premises. Basically the most secure way. So these are the 3 steps we are going to do. So let me take you through the steps one by one. Okay, so let us get into the GitHub now. This time, yeah, GitHub is here. So click on the drop down menu and come to the settings. So here on left menu bar, you can see that public profile account appearance. These are general settings, but as you come down, you have access section. You have specifically an access section. In that you have billing and plans, emails, password, and the authentication. Here you can set up a new password, and but anyway, to clone a private repository using password credentials, using username and password is not possible these days. That was deprecated in 2021 mid itself. So that's the reason. So what else option we have left for the access is SSH and GPG keys. So now SSH key is 1 and GPG key is 1. So using SSH key, so what we have to do is, if you want to do it using SSH key, you have to create new SSH key. When you click on new SSH key, so it will open a window. So in that window, you have to paste your public key that was generated in your Linux server. Same thing happens with the GPG key. You have to create a public private key, and then public key should be copied in this section. So at this moment, we will look into the SSH key only. That's the primary target. So let me click on new SSH key. So the title I'm gonna give is, this is GitHub challenge key. So that's the name. So here I have to copy, you see that authentication key. In this place I have to paste the public key. So but before that, before we pasting it, let us get into our server. And so it's gone. So let's get into our server and let's generate a SSH key. So sudo I clear the screen. Now where I am, ls pwd. So I am in root user home directory. I am inside the root user home directory. So let me give SSH keygen. So now we are gonna generating a SSH key. So what it is asking, generate a public or private RSA key pair. Yes, that's what we want. Enter file in which to save the file name. So the file name I'm gonna give is the same name. What is that? It is GH challenge key. It would be a big name. So I'd say GH key. Okay, GitHub. No, I would give Ubuntu machine. Na? So I'd say GitHub. GitHub key, and then click enter. So then it's asking enter passphrase. So either you can give empty, or either you can leave it blank, or you can add your passphrase. Passphrase is nothing but it's like a password. whenever you use that key pair, so basically it asks that passphrase. So I will click on enter and then enter same passphrase again, same enter. So it's been created. So your identification has been saved in this GH key. Your public key has been saved in ghkey.pub. This is our public key and this is our private key. The key fingerprint is this. Okay. So now let me do ls. You can see that GH key is a private key. ghkey.pub is a public key. So always and always and always private key should be in a machine where you have created a SSH key, and public key should be stored in a any kind of machines, and number of machines you can store the public key, because public key is to basically use it for the public purpose, and then private key is secret one that you want to put it here. So when the public key from any machine with the private key of my machine matches, so the connection makes. So now our let us look into the keys. So how does a private key looks like? So this is how a private key looks like. We have used this private key in our previous examples in our previous sessions or slides. I think it is in Ansible. Okay. So this is how a private key looks like. So we'll keep the private key in our Ubuntu machine, whereas let's look into public key. So this is how a public key looks like. You see, it started with SSH -RSA and some alphabets and some other characters, and it closes with the alphabets and then root user of my Ubuntu machine and then IP, the private IP of the Ubuntu machine. It is nothing but, let me give who am I. So who, okay. So basically this is username and this is host name. So the whole private key has been whole public key has been attached with whom? With the root user and then host of IP 172.3.1.15.184. So this is the reason a private key and public key can be connected through this. Okay. So now what will we do is we will copy this from SSH. Okay, let's get into the machine once. You see how should it look like a public key? It should always begins with SSH RSA and it should end with username and host name. Okay, so we got the same one by and large. So it will start with SSH RSA and it will close with the host name and username. So copy this and here is the machine. Yeah, paste it here. Correct? Something is wrong. Yeah, let me. No. This is the way. Okay. Or else I'll do one more thing. So I'll use in spite of cat, I would say vim gh key dot pub. Yes, now it's better to copy from here. Copied, put it in. Yes, correct. So now let me add this SSH key. So it's asking password. So I would say I would give my password. So password has been given and key has been added. You see, authentication keys the key name is GH challenge key, and this is the public IP. Sorry, not public IP, public key, and then private key will be with Ubuntu server. So now let's get back. So what will we do is, we got to know how to do that. So now we will delete this key and we will bring a private IP. Anyway, public IP can uh, always be cloned. Okay, we'll see that also, whether we can clone it or not. So here is the, I think, where is that? This is public IP. So here I'll keep private IP only. Mhm. Yeah, private rep would be here, public rep would be there. So here public rep, let me move into SSH. So let me copy this. You don't have any public SSH keys in your GitHub account. You can add a new public key or cloning this repository via HTTPS. Let's see. Let me clone this using SSH and let me try to pull it here and we'll see what's going to happen. So git clone and do S through SSH. What's going to happen? What's going to throw this? It's saying fatal destination path GH challenge pubrep already exists and is not an empty directory. So we have done it before in this directory. So let me get into another directory, that is a CD home Ubuntu user. So here I will do that again. So git clone. So it's cloning. So are you sure? Okay, the authentication of host github.com. This is the IP of the host, can't be established. So at TSA key fingerprint is this. Okay, that's fine. That belongs to GitHub machine. So are you sure you want to continue connecting, as I would say, as without any proper secure connection, but still that's fine. I'll say continue. So but what had happened? Warning, permanently added github.com at DSA to the list of known hosts. That's fantastic. But git at the rate of github.com permission denied. Okay. So whatever you do, even it's saying finally git at the rate of github.com permission denied because public key. There is no public key. So fatal could not read from remote repository. So please make sure you have the correct access rights and a repository exists. So with SSH, even you can't clone a public repository also to your machine. And okay, if you do not set up a public key, a public SSH key. So if it is not set up, it's impossible. So if public we are unable to clone, means private it's impossible to clone, I guess. So anyway, let's take the public private IP also and we'll check that also once what's wrong in it. So here is, and let me use SSH link and then copy this. This is a private rep and same git clone. Cloning, same thing, same problem, but this time it's even did not ask that condition. So because git at the rate of github.com permission denied because of public key. So now what will we do is we will do the same thing, whatever we have done earlier. So here we will get back to the settings and we will go to the SSH key and we'll create our new SSH key, and this the name would be GH challenge key, and here we're gonna copy the public key. So let me get into the root user, ls vim gh key at the rate key dot pub. So this is our key. Let me copy this. We have done it earlier, but I just want to show you that if you do not set up a public key and private key relationship between your server and GitHub, it is impossible to clone even a public repository from GitHub into your server. To prove this, so I just skipped that one. So now again we are adding our public key to the GitHub from the server so that we can set up that connection securely. So I have added SSH key. So now let's refresh it and let's get into the, you see that here also. So now let's refresh this one more time to the public repo. Now let me do the SSH clone URL link. And now let's do SSH. So cd home Ubuntu mkdir. This is public rep. cd public rep. So inside you just cross check. Nothing is there inside to execute all the things that we have mentioned. So let's quickly finish it. So what I will do is I will show you the methods and how to do that. If you want, you can continue with the further procedure. So as we have mentioned here, so using SSH key is done. So similarly we can do the same with GPG key. So that also we're gonna do that. So GPG key, whichever is possible. So now to do that, let's get into our server again, and then the GPG procedure is similar to that by and large. So you have to go with GPG. Let me click Control C. Yeah, clear the screen. We have the GPG utility in our machine. So let me type GPG and full generate hyphen key. So this is going to prompt a message saying please select what kind of key you want. I would give option 1 RSA. So 1024 or 4096, which bits you want. I would go with the 4096 bits long one. So then please specify how long the key should be valid. So for me, I will put 7 days. First it's 7 days, I would say 7, that's it. So key expires at Sunday, Jan 29th. Absolutely fine, no issue at all. I would say yes. Is this correct? Absolutely correct. So GNUPG needs construct a user ID to identify your key. So real name, I would give Ubuntu for this. Email address, comment, GPG key. Everything is okay. So I would give OK. So please enter the passphrase to protect your new key. I would say done. So you have entered an insecure passphrase. Okay, that's fine, no issue. The passphrase should be at least 8 characters long. A passphrase should contain at least 1 digit or special character. That's okay. Take this one anyway. So retype. So done. So now it's creating our GPG key. So this is the public secret key, UID and sub. So let me look, ls hyphen a, and here you can see the .gnupg. So let me enter into that .gnupg. So you can find all the information about GNUPG, public pub ring, private keys, everything, and test trust.gpg, trustdb.gpg. So let me give gpg long option list and secret keys and long option key ID and format. I would give long. So you see that here we got complete information. So total we have two GPG keys. This is one and this is other one. So let me check, and this one expires on 2023 January 29. So let me take this one. This is the ID of GPG. Let me copy this. So now I want to get the public key. To get the public key, so you need this ID. So that's the reason I have executed the above command. So now let's do GPG list option and sorry, I would give, okay, this is to acquire ID, GPG key ID. So now we want to get the public key. For that we need to use armor option, armor long option. Then we want to export that, and the key ID is here. So let me execute it. You see that this is our public key. You can see that begin PGP public key block from here and ends exactly here. Where is that? Yeah, here it ends PGP public key block here. So done. Let me copy this and get back to our machine, get back to our GitHub. You can see GPG keys here. So let me click on new GPG key. So title, so I'll give GH challenge. See, as they have mentioned, it always begins with the begin B PGP PGP public key block. Let me paste it. So we have pasted it. Make sure the spaces, you did not give the extra spaces. So on top and also at the bottom, absolutely fine. There is no additional spaces, neither at the beginning of the key nor at the end of the key. So absolutely fine. Now let me add GPG key to this. So now you have attached the SSH key and a GPG key. So now you should able to easily access, you should able use you should able to clone your repository using SSH URL. So let me get into one of the repository to see that URL. This is SSH URL. This is how it looks. You just copy this and then if you execute, you should able to see that. So now the third option that we have here is using, so git GPG key also executed. So that's also we have done it. So that's very important. And then the third option that we have here is using GitHub CLI for P and P. So okay. So let's use GitHub CLI. You see that when you click on GitHub CLI, you can actually clone from this also. For that, we have to install GitHub CLI. So let's jump into the GitHub CLI install Ubuntu documentation. So this is official documentation. So for macOS Homebrew, Mac ports that Windows, it's Scoop, Choco also there. For Linux instruction installations are here. Installing GH on Linux and BHD. So Debian, Ubuntu, Linux, Raspberry Pi, all will have to follow this. A huge procedure. Okay, so let's copy this. It's nothing but the similar one, GPG key rings that we have seen. So basically it is setting up a secure connection using GPG keyring. That's okay. Let's do that. Let's install. Okay. So I would give enter sudo apt update sudo apt install gh github CLI. So once installation is done, so what's the next step to execute? It's installing the GitHub. So now, so we are recently forced to change our GPG signing key. If you have probably previously downloaded this, you should re-download it again and above. That's okay. So then, okay, all that. So it's taking time. That's absolutely fine. So that is using GitHub CLI that you can directly install it. Okay, okay. Installation is done. So you can say GitHub CLI. For that you can use GH, just GH. GH version. GH version is 2023-13. This is latest one, absolutely latest one. And as usual, let's try this. Here is that link and say, so alternatively, okay, GitHub, to get started with GitHub CLI, please run, okay, we forgot that git gh auth login. So GitHub Enterprise Server, no, what account do you want to log into? So github.com, GitHub Enterprise Server, I want to log into github.com only. So through HTTPS or SSH, through HTTPS, that would be easier. So it will take me through, okay, authenticate Git with your GitHub credential. I would say yes. So log in with a browser, or you will paste an authentication token. I would log in with a browser only. So let me click on. So first copy your one-time code 67EE8965. Press enter to open browser. So execute file not found in path, because browser is not there in this Linux machine. That's the issue here. So what you can do is try entering the URL in your browser manually. So let me take the URL. Where is this? This is the URL, and copy this, get to my browser, take it here, paste it here, enter. So and Okay, okay. Let me get the piece of code and paste it here to get a device activation. Yes, let me click on continue. So it's asking authorize GitHub CLI. I would give all permissions. So authorize GitHub. So congratulations, you're all set. Your device is now connected. So my device is now connected. Let me re-execute the same command git auth login. So you're already logged into the github.com. Do you want to re-authenticate? No, I have logged in, so I don't need to re-authenticate. So it's done. So now let me execute the GitHub clone. So I think the destination path already exists and is not an empty directory, so failed to run. So let me go to cd home directory. So ls, so ubuntu. So you run the same command here. So cloning, remote cloning, and finally your completely cloning of that repository is done. You can see that. So let me click here. So gh challenge public rep, it's been uh, cloned into our ubuntu server. So that's how you can use either that or this or github CLI, whichever the way, HTTPS, SSH, or GitHub CLI. So GitHub CLI is also secured one, and SSH is most secured one because we are using SSH key and GPG key, whichever is possible. That's fine. It's not an issue. So so these are the three ways we can do. So now let's do the where is here. So this is, let me get to the CLI. This is CLI. Yeah, here it is. So let me get into my repository, your repositories and get into my private repo, and let me go to the GitHub CLI and copy this and get back to the place and say and paste it here and execute. Cloning, enumerating, so counting, and finally ls. This is your private repo. So irrespective of public or private, if you use GitHub CLI after authentication, you should easily fetch the codes. So these are the three ways we have seen so far. So using HTTPS and SSH, there as using SSH key as well as GPG key, and after that we have used GitHub CLI to get it. And finally we will look into my one technique. It is using HTTP download link and wget GNU utility in Linux. So for that, so what we have to do is, first we will do for the public IP, sorry, public repo. So I'll click on F12. It's a secret, don't tell anybody. Secret. Click on F12, open DevTools, then bring it a little bit this side so that we can see the download option. I think now we can see. Let me click on download zip. It's getting downloaded. The zip has been downloaded. Now let me click on main.zip. So and main.zip, we have two main.zips. We'll take anyone. So 302. So this is not got success. You should get the one which is successful. So main, this is successful, but here we do not have a zip. Okay, so anyway, let's copy this and we'll check whether we'll get a link from here or not. So this is the normally I do every time if I'm unable to do anyway. The initial three ways anyway they will work. If it is not, then finally you can go for this. Finally, if it is not, this is not the compulsory. So wget. So wget, paste the link and main.zip. So your zip file has been downloaded. Here is the main.zip. So now let me check whether we have unzip or not. So if we have unzip, it's fine. So unzip is not there. So let's install unzip first. So apt install unzip. So unzip has been installed. Now let me unzip the file. So main.zip. So ls, clear the screen, cd, sorry, ls again. You see that there are one more directory, that's gh challenge pubrep -main. So let us enter into that gh challenge pubrep -main. You see that? Same thing. Function index.html style.css. This is my technique. This is how I do. If nothing works, if I face some issues in other types, because it's sometimes even because of SSH key and GPG, sometimes if we face issues, of course we can use GitHub CLI, but even if that is also not available for you, then you can use this technique. This is my technique. So I will reiterate this technique. I'll write down here clearly so that it would be very clear for you. So first thing, go to your repository page and click on drop down button next to the code. Then at the same time click on F12 to open DevTools. Then click on download zip on from the drop down menu. Then you go to the DevTools and click on main.zip zip text, and it opens up the request URL or response URL, request information and response URL. So from there you copy the response URL with main.zip. Then go to your Linux machine and make sure wget tool is installed. If not, install it and give wget command with response URL. Then it downloads the complete repository zip file. Then install unzip to unzip the zipped file. That's it. You can see your source code on your machine. Congrats. So let's do it one more time for the private repository now. So same thing. I'll click F12 first. Open DevTools. So it's opened. Now it is in network tab. You see that it's in network tab. Now let me come a bit this side. Yeah, so now you can see the code button. In that you can find a drop down button. So you click on that drop down icon, and once you click on drop down icon, it opens up a window. In that window you can find download zip. So I'll click on download zip. You can see that you got the main.zip. So it's getting downloaded. Now you extend this to the left side, then you can find the main.zip. Anyone you can take and copy the request URL from here, and the request method is get. Okay, this is the request URL. So response headers are those are different, but this is a request URL. So then you go to your machine and do wget and then paste it here. Okay. HTTPS. Okay. Something while copying I missed it. It will begin with HTTPS, not TTPS. HTTPS. So error something not found. That's okay. HTTP request sent awaiting response 404 not found, resolving GitHub not that's okay. So whatever it may be, sometimes this kind of errors may happen, but this is the way of downloading and bringing your file. If you want to see one more time, I will copy this and I will do it. I'll go to the CD. This is Ubuntu. CD Ubuntu ls. Okay, I'm inside this. Okay, I'll come out. That was actually directory. Now CD Ubuntu ls. So now let me give wget and then same link here I'm giving. Now click. Here it is. Here is the file. The thing has been solved. Now you can see your file. Awaiting response 302 found and all done, and you can see your repository here. That's it. So let's get back to our work. So using HTTP clone link, SSH clone link, GitHub CLI clone link, and finally my way of doing using HTTP. Okay, let me edit that. This is my technique. HTTP download zip file. So we have seen all. Using HTTP clone link, SSH, GitHub CLI, and my download zip file thing. So Let's get here. So request URL, this one, request URL. So let's sum up everything. So what we have seen in this, all this stuff from HTTP, SSH, and in SSH key, how to make SSH key and GPG key, then GitHub CLI, then my technique to download that.